Yeah,
It's like we just put the poster, like whatever you see on the screen, just entering it.
Uh, if Dave is joining and if he will start presenting, he can directly
Yeah,
present,
yeah,
am I right?
I have control on the
You have control.
yeah, yeah. So he can start sharing his screen and webcam as well. So
Okay. So in this chat, I was talking to Dave. Okay. So when I will start in 5 minutes, and then I will hang up. Okay. So you just tell me 5 minutes before that in 5 minutes we will hang up.
okay. So I should say
Like
nine.
9:10, you can tell him that we are handing over.
Ashay?
Yeah.
So yours is the opening window.
I am the opening. Yes. After that, the day. I mean 9:15. Before that.
So 9:15 you can start 9:10.
Yes. Yes. Exactly. 5 minutes before I will start.
5 minutes, then we can.
Yeah. 9:10 I will start. Hello.
Hi, this is Dave. Hi, Naveen.
Good morning, everyone. I hope everybody had breakfast. If not, then please have it. Have some tea or coffee. So thanks a lot, everyone, for coming today. Uh, we have a very good agenda, as well as we have a lot of diversity from different companies. We have service providers, hardware vendors, enterprise, as well as Microsoft today. We are also honored to have Dave opening the workshop, as well as we have Vijay talking about Azure networking end-to-end, who is the IDC lead. Um, there will be a panel discussion in the last, where before closing, and um, there will be 2 to 3 short breaks we will take. Otherwise, we'll continue with the session, and there will be like 45-minute to 1 hour lunch break we'll take. Um, I think that's all. I will hand off to Dave to do a warm welcome and kick off the workshop. Thanks a lot, everyone, again for joining today. Hello, Dave. Can you hear me?
Yes, I can.
Okay, we can hear you now.
Okay, great. So hi, everybody. It is my privilege to be here to get us started, and welcome to the Sonic Workshop in India. I'm Dave Maltz. I am the Corporate Vice President at Microsoft responsible for Azure Networking. I'm a technical fellow here, and I'm also a member of the Sonic Governing Board. Sonic, as you may know, is part of the Linux Foundation, and this is a Linux Foundation sponsored event. Thank you for coming to the Microsoft campus. Thank you for interest in Sonic. We've got, as Sashi says, a great agenda prepared for you. Start by talking just about it. What is Sonic? My guess is that everybody here already knows the answer to that, but if this is your first time learning about Sonic, Sonic stands for Software for Open Networking in the Cloud. It's a Debian Linux-based network operating system. It is the code that runs on a switch or a router, also known as the firmware that controls that device, and helps it interconnect with the other things in the network. Sonic is an open network operating system that supports over 100 different switch platforms and ASICs. It runs on millions of ports and networks at companies of all different sizes, from extremely large data centers to very small enterprises to some embedded firmware that might go into things like security cameras or devices powered over power over Ethernet. Perhaps most importantly for the context here, Sonic is open source. Sonic is what we make of it. There's going to be a lot of information today about the architecture, how it's put together, how to contribute to Sonic, what Sonic's being used for, what Sonic can be used for. So I won't get into those details here. Instead, I'm going to talk a little bit more about maybe why Sonic. Now, lots of different people are going to come at Sonic for many different reasons. You're probably here, if we were to ask the room, why are you here? We would get a whole bunch of different answers. Because people do come to Sonic looking for many different things. Some people come because they're interested in Sonic. It's a large and rapidly growing ecosystem. It is very hard to find a merchant silicon vendor, someone producing switch silicon that would be built into a router that is not supporting Sonic on top of their platform. This is sort of the logo layout, but you can see under merchant silicon the logos of many, many companies participating in the Sonic and making it real on their switch platforms. Now, The people listed under the switch platform category are companies that will then take the switch ASICs that come from those merchant silicon vendors and actually turn them into a switch that you can actually go buy. And again, we have very broad participation from very small folks who do a form of contract manufacturing or ODMs, original device manufacturing, basically producing switches to somebody's specification, all the way up through the very largest switch vendors that are in our ecosystem today. We look over who's adopting Sonic. Again, companies very large and very small are all participating with Sonic, adopting it, deploying it into the production networks in order to get use of it. And then an interesting thing about Sonic, because it has this large and growing ecosystem, because it is open source software, because it's part of the Linux Foundation, it has been tied into and adopted by a lot of people who build systems and services for managing networks around this. These are folks who are building systems to extract data out of the network and present it to the operators, people who are building systems that will help a network architect take a concept for how their network should be designed and compile it down into the configurations, the instructions are going to run on the switches in order to carry that out. And everything in between, from intent down to data analytics on the base up, to how to deploy software onto these switches, for how to treat the switches in your network as the same things you might treat servers in your network. So you can use the same kind of deployment and container maintenance methodologies for both your switches and your servers, thereby helping to upscale and upskill all the engineers who might be part of your team already. So some people come to Sonic because there's such a growing ecosystem around it. Some people come to Sonic because the industry is making pretty clear that Sonic is going to be one of the winners that moves forward into the next generation of switch operating systems. Gartner predicted in 2021 that by 2025, 40% of organizations operating large data centers would be running Sonic in their production environments. Gartner believes that their client interest in Sonic has increased 87% year over year from 2020 into 2021. We have Network World and IDC research predicting that Sonic is likely to become the Linux of the network operating system. Basically, not just that we're part of the Linux Foundation, but in the same way that Linux supplanted all of the various open, star BSDs, FreeBSD, NetBSD, OpenBSD, BSDI, to become the de facto operating system that people run on a computer that's not running Windows. Sonic is likely to become the de facto operating system that runs on switches and routers that are not running some proprietary operating system coming from that switches vendor directly. We've got analysis coming out that's showing that running Sonic on network switches tends to make them more reliable. That's data coming from experiments we ran in the Microsoft data centers. And we see that there's a great business opportunity around Sonic, that and thanks to that large and growing ecosystem, the number of companies developing services to run on Sonic-enabled switches or to enable Sonic-enabled networks, there are billions of dollars to be made here by everyone who's a switch manufacturer, software manufacturers, and all the people who help operationalize and make real networks using Sonic. So some people come to Sonic because the industry it's winning in the industry. Other people come to Sonic because, again, Sonic is open source. The energy, the innovation around Sonic is coming from folks like you all in the room. Sonic continues to have a large base of contributors, over 4,500 people contributing to Sonic, and that's up 17% over the past year alone. And those people are making hundreds of commits to extend and expand Sonic, fix bugs every month. So we're up to about 60,000 total commits as of July of this year. And that again is up around 8,000 or so commitments from the same time last year. So a lot of activity coming from a very broad base of people. Some people working in large companies, some individual hobbyists, some academic researchers, some people working in IT support. Becoming a little more personal, why am I involved with Sonic? It's because I really think that we're changing the world here. I think this notion of a disaggregated networking, that you should be able to get your network hardware and the software that runs on your network from different places and mix and match them however you want, running the software and the logic that you care about on the routers in your network, is a super powerful idea, and Sonic is the best embodiment of it, of that there is out there right now. I believe that Sonic is going to give us more reliable networks. That's why Microsoft is actually engaged in this effort. Live site quality and availability is job number one for me and everybody on my team. And deploying Sonic on our routers means that we can control our destiny, we control the quality of the software that runs out there, we benefit from this large ecosystem of people who are also contributing to deploying Sonic. The more people who use it, the better it gets. And so we found that Sonic's a way to give us that reliable network. I believe that Sonic gives us faster innovation. It's simply exciting what Sonic's enabling. If you have ideas for a new capability that requires some of that logic or functionality to run in your switch, via Sonic, you can do that. We've had really cool projects go from a concept on a whiteboard to actually running in production in just a few months, thanks to the flexibility as a platform that Sonic gives us. Trying to do that in the older world, where you'd have to convince the vendor who sold you your network router to also implement that new capability, or you'd have to do it in some kind of cockamamie scripting language that runs on the routing processor. Sonic's just gives us, as collaborators in the Sonic ecosystem, the ability to implement whatever our minds come up with. And then ultimately, Sonic enables better operations because Sonic lets us treat our switches the same way we treat our servers. We can bring in a lot of understanding, a lot of network automation systems and deployment automation systems to make the network better, to operate it better. We can script functionality more easily. We can interact with the device using native APIs rather than rather clunky command line interface languages. And I just think this is a great place with tremendous potential. And thanks for joining in with us today and to learn more about Sonic and to see how you can contribute to it and how other people are contributing to it. With that, I'm going to hand back over to Ashay. I guess I don't know if we're taking questions or not. If there are, I'm happy to take a couple if there's time.
Thanks a lot, Dave, for a wonderful session. So the next, I would like to welcome Vijat, who is a leader of Azure networking from India, and he will be sharing some information about the Azure networking, what it does end to end. Okay.
Is running good.
Hello.
Is this working? Okay. All right. So thank you, Ashay, for setting this up. Thank you, everyone, for being here. I'm sure I've met very few of you in the past. I'm not a Sonic person in the team. The other people will be following me to talk more about Sonic. But yes, welcome to Microsoft. Thank you for being here. It's a great weather outside in Hyderabad last few days. If you are from Hyderabad, you must have been enjoying it. And if you're coming in from other cities, it's a great time to be here. I'm going to talk a little bit about Azure networking. And we just take this opportunity to maybe brag a little and talk a little bit about the work we do. But also it's sort of pertinent to the sessions today because, we are the biggest consumer of Sonic. And all the infrastructure that we talk about right now that actually powers Azure, can assume is running on top of a lot of devices. We have other vendors' systems also. We're not 100% Sonic. We're pretty much less, but we're growing pretty fast on the Sonic front. So a lot of what you see today running on Azure, whether it's software services, network software services, or even the base platform runs on Azure, on Sonic. So in that sense, you get an idea of what are we betting on in some ways. All right, so yeah, before I keep going forward, my name is Vijay. I've been with Microsoft for about 16 years, been leading this team in India, the development center, for a good 4.5 years now. Before that, I was leading the compute team in Azure. So overall, been part of Azure sort of development core team for a good 6-7 years now. Azure networking is what we're going to talk about today. I have about half an hour, and I'll try to sort of keep everyone in time. We call ourselves Azure Networking, or AZNET in short, but the fact is that we actually power all of networking for all of Microsoft, right? So whether it's Windows, Bing, Xbox, Office. But in addition to that, of course, Azure hosts thousands of customers, and so we also empower them in some ways to do their work on Azure. So you name the top companies in the world, and they are on Azure, and they do some work, and we have the responsibility to ensure that they remain up and running, that critical systems keep going. And the way we do it is if this guy decides to move. All right, I don't know if you can see the world map very clearly on this, but there is a world map behind it that's more clear on the slide deck here. We are a very global infrastructure. We have many regions, upwards of about 70 regions across the world. And all of these sitting on the world map are different regions that you see. Every region, by the way, has hundreds of devices powering it, and has multiple data centers that actually run. Now, all of these regions are connected through our backbone network. So there are multiple undersea thick wire lines that we run. There are a lot of metro optical lines that we lay and we run, or we partner with our suppliers to sort of create this overall global network, which we call our backbone. So approximately 70 Azure regions. This could be inaccurate. It may be actually more, but about 225,000 plus miles of fiber across the world. 2 petabytes of WAN capacity, huge peering capacity that carries us, across our networks, but also into the internet. And 500 plus physical sites across 59 countries. And you have been in the networking world, and you know how fickle can the optical fibers be at some point. So anywhere in these 500 plus physical sites that might go connect to other sites, you can get an optical fiber breakdown, and we are on it to ensure that we provide continuity. It's heavily redundant, of course, to ensure that one connection break doesn't cause a big problem, but all of this is designed in-house within Azure networking. We have 200 plus edge POPs, and we'll talk about how we try to get closer to our customers, because then we can truly give them the type of latency that modern applications need, or the lack of latency. Either ways, and I talked about the backbone fiber. Once you enter Azure, you remain within Azure, even as you transit across regions. And I'll talk a little bit more about it as we go through more slides. Fully secure, we've done a lot of work in getting us secure, from work on the devices to ensure that we are sort of MACsec enabled everywhere, encrypted on the wire, and blah. And our customers need it. We have some really critical customers that care a lot about security, and all of us do, right? And this last one is a good one. More than 99% of our inter-region traffic actually beats the internet latency. And therefore, a lot of our customers actually find it much better for their purposes to go through our backbone than going through the internet. But how do our customers get to us? We have these hybrid connectivity options. I don't know how many of you have dabbled into how Azure works, but from the premise when you get connected to Azure, you're essentially coming through some connectivity option that we provide. Express route, for example, is one of those options that's primarily used by a lot of our customers. And that gets into our network through regional gateways. And so as you can imagine, there are a lot of POPs across the world where we actually go host our express route endpoints. And our customers use a bunch of ecosystem to sort of get in. We are constantly scaling up our networks. Right now we are in the middle of transitioning all our 100G interfaces into 400G. A lot of that work happens out of India, but a lot of that work happens out of other centers that we have in Azure networking across the world. All of this data, I'm not just going to drain all of this data with you, but in a lot of places across regions, we within an availability zone, which is a concept within a region where we ensure that if we are not sort of going down because of electric supply, water supply, and stuff that is sort of specific to that region, we guarantee a less than 1 millisecond latency. While across, within a region, across two places, less than 2 milliseconds. All right, I just keep going and let you read through these interesting data and take you to some of the networking use cases. So what do we have this big, pan-continent type of network that we have laid up with hundreds of data centers, 70 plus regions, hundreds of data centers, and hundreds of edge sites. What do we use it for, right? How do we get return on it as Azure? Essentially, we run Azure on that. And from a networking perspective, there are a lot of services that we run that ensure our customers get what they want out of Azure. And we sort of divided these into these 5 categories. And I'd sort of just tease each one of these for you to give you a sense of what we do under that category. And that's it. Then I'll close this session and let you guys proceed with your Sonic discussions. But the first category here is around network foundation, which is partly what I talked about, the basic infrastructure that we build, but more around what we build on top of that as a network infrastructure that our customers can use, right? They want to come in and have their own network within this broad network, which we call virtual network. And frankly, most of the public cloud companies call it the same. So it's a virtual network that we build on top, and there's a lot of functionality that our customers desire on that virtual network. I'll talk about that a little bit as we talk about network foundation. Hybrid connectivity is something I talked about, but I'll tease a little bit more on that when I talk about how can I use hybrid connectivity for more and better scenarios that our customers need. And then network security, it's a pretty important stuff, right? If you're going to bet your services and a lot of your business on Azure, you want to make sure that you have the tools to keep yourself secure, right? You, of course, want to make sure that the infrastructure itself is secure. And so we do a lot of work on that, but also we give you tools to ensure that you're getting the same security that you would otherwise have in your premises. And then application delivery. Modern applications really want to make use of all the load balancing techniques that we provide. So we'll talk about that. And then we look at the future and see what new things are coming into this infrastructure. So if I might get going, network foundation, talk a little bit more about that. Azure Virtual Network is our customers' network within this broad network. And that network itself could span, right? Regions, we can go from one region to another. And then as a customer, you want to feel secure also within that network because eventually you know that you are on a big world club, a network that spans world over. There are other customers that are on that network as well. So you want to have your own island that makes you feel secure. That's what virtual network is. But then you need the right amount of access into that network, right? You need peering, you need NAT to be able to go out in the open world, and you need tools. You need tools like VTAP to ensure that you're able to debug your problems, and configuration systems like Network Manager. I'll talk a little bit about Azure Private Link as well, as I go, but Azure DNS is another big service that we run. This is when you come in, you need the DNS support. But even if you are not coming in and doing DNS for your own, you may need to be a public DNS support for your names. And so we provide the public zones and the private zones within Azure DNS. And then, you are internet facing to some extent from here. So you need control. You need control on how do I get to internet and what do I do with it. And then finally, you want to be able to monitor your network, ensure that everything's going good, be warned of what's going wrong with it. I will just take a few of these and tee it up, and then I'll do the same for other categories, and then take it from there. So Azure Virtual Network, talk about private link. We gave a virtual network to our customers, a beautiful concept where they come in and they are able to go to their own resources within network. But they had a problem. The problem was we are pretty secure within this virtual network, but as soon as I try to go out to other services that you host, SQL for instance, you're not extending that concept for me to SQL. You're asking me to go through a public IP address and fall into SQL. So I feel insecure in doing that. And so we brought in this concept of a private link. And this allows you entry into all of these services through endpoint that is private, that's not public, right? And it ensures that you're not exposed to outside world and you feeling secure within your private space, accessing all the services that we provide, right? So that is what Azure Private Link is. If you go on the net, just on the Azure site and read about it, you'd know quite a lot more. Azure Virtual Network NAT is essentially your gateway to outside. So we have SNAT solutions that help you go outside with almost unlimited type of support in snatting. So you're not going to run into port exhaustion problems and stuff and like that. And so we have a lot of functionality over there. This one, I'm going to tell you something new that's coming in. I believe it's close to GA now. A lot of customers trying this out today. And customers' problem is, network management is hard because there's so many moving parts. There's so many resources that I need to manage. And there's a configuration bit that in my mind, but I don't have tool that I can uniformly apply to all my resources. AVNM, Azure Virtual Network Manager, is our answer to that. So it's a single screen, full network management solution that will be going out, where you're able to group your resources well and sort of configure stuff in much better way than you were able to do before. It has all the things that you might need, examples, the security management, the rule management, safe deployment, various topologies on whether you want a hub and spoke, a mesh topology. So it gives you those constructs that you can use to manage your network. All right, so that's Virtual Network Manager. And monitoring, we have both a proactive health monitoring system called Network Insights, where you go in and it gives you a topology on how it looks inside Azure, and you can double click and go deeper into one particular area to see what might be going wrong, if you feel something is, right? And then there is connection monitor and say, hey, I really want to monitor this connection between my front end and back end, for example. And I'm going to sort of pick a few of these and ensure that there is a 24-hour, 24/7 monitoring of this so that if there is a break anywhere, that I'm alerted, I'm notified, And we have and there are a lot of tools also within this that I'm not talking about. But let me move on from network foundation. By the way, as you can see, we're sort of skipping a lot, but the whole point is to tease this up so that you get a taste of this, and feel free to go on our site and read more about these. Talk a little bit about hybrid connectivity. Express route is one way you can come from enterprise into Azure. VPN is another way. And then there is virtual WAN. I'll not spend too long on the express route functionality, but think about it as a partner ISV sort of a help into getting you from your premise to edge of the Microsoft edge, so that you can be handed off into your virtual network inside. And that whole pipe is secured. It comes through an ecosystem that I'll talk about that we have, a pretty big ecosystem that can help you carry from your premises into, of course, our partner's edge, and then from that edge into Microsoft edge, and then within the cloud. That's what Express Route does, and gives you a huge amount of bandwidth that you can take with it. But once you are inside the network, you can, of course, do all the work that you need to do within the network. So if you're hosting applications that are sort of business critical for you, or applications that your customers need to come to, you get everything of that, right? And you can have your traveling people sort of coming in through point-to-site VPN and doing the same stuff that they do. But there is more, right? Since we provide you such a reliable, fat bandwidth connectivity from your premises to Azure, and since we say that Azure backbone is the reliable, low latency backbone that can transit the world, you can also use Azure as a transit system. So you come into Azure and you get connected to your branch offices across the world in a mesh. So, in a way, Azure becomes your secure sort of internet, right? So you can VPN in, remote users can VPN in and can get routed to even your on-prem through Azure. And that's what virtual WAN gives you. We have a lot of partnerships that help the WAN ecosystem. The virtual WAN ecosystem, we have a very growing clientele and customer base that sort of uses virtual WAN today. And this is just to give you a little bit of example on how we're sort of putting together all the stuff that comes here. And remember, all of this runs on top of all these devices that we've laid underneath to build that backbone, a lot of which are running the Sonic OS, which is the topic of the day. All right, here's another one. A customer said, hey, I really love the way you take my traffic through my backbone, through your backbone, and therefore I'd like to use more of it. So can you ensure that my traffic enters your backbone at the closest place? And then there are other customers that say, hey, I'm going to reduce and optimize for some of my traffic that I'm okay with going through internet. And so it's okay that I route myself through internet and get into Azure at a place that is closest to my service. That's a cold potato, hot potato routing that we introduced. And we give it to our customers and say, hey, you decide, how do you want this to be routed? They can go and configure it on their portals and then say, hey, this is how I want routed. I want most of my routing across the world through your backbone. And so please route me into Azure from your closest edge. Or I do not. I want to enter Azure very close to where my service is hosted. For example, if my service is hosted in US, West 2 data centers, then please route me. I'd get there through internet and then enter the Azure there. So that's the routing preference solution that we gave to our customers. Network security, we have Azure Firewall. We have a DDoS solution, that's been very handy. I don't know how many of you realize Microsoft is the second most attacked network in the world just because of its expanse and its popularity, right? But our DDoS system sort of doesn't make it look like that. We sort of protect ourselves. There are issues that we've sort of gone through, but we've sort of been enhancing it a lot. And so we have a pretty scalable cloud scale DDoS protection for all of our Azure resources, and widely used by our customers, not only by our customers, but also by our internal services, you name it, Office or Teams or stuff, we use our own DDoS service to protect them. And then there are tools that we give for you to deploy within Azure, like the Azure Firewall and the Azure L7 firewall solutions that you would find it. We call it WAF. Azure Bastion is another one, a very recent stuff where people say, hey, I want to securely go into my machines inside Azure. So I want a secure shell into these machines. I want to RDP into it. But I feel insecure because my customers, my employees are there out in the world and they are coming through a public IP. We said, okay, we can give a solution for that. So you get onto the portal and then you don't need to use public IP, but you can RDP not only to your Azure machines, but also to connected corporate machines. So not only did we secure our own, your properties within Azure, but we also secure your corporate properties so that your employees can securely go through our connectivity solutions back into your corp network and RDP into their machines. So if you read about Azure Bastion, that's another one. Application delivery, we have a lot of solutions, right? We have Azure CDN, which is commonly called the front door solution that we have. And we have a lot of load balancer options. And then we have web application firewall. All of these are at an application layer. So, your applications can leverage these. There is a load balancer, which is a L3 load balancer. These are all the load balancing options that you can find in Azure. All of these are homegrown solutions that run on Azure today, with our team sort of backing them up and supporting them. There is application gateway, which is a HTTP layer load balancing solution. There is a traffic manager, which is essentially a DNS-based load balancing solution that can help you load balance across geographies. And then we have front door that also gives you an application layer load balancing solution. The good thing about front door is it sort of gives you that balancing solution at the edge. So you get balanced across your application endpoints right at the edge of the cloud. While if you are more limited in your geographical scope, you could use application gateways to get into the region and get balanced behind application gateways. So we have all of these solutions. This one talks a little bit about application gateway, which is a very popular solution we have used by hundreds of companies across the world, but quite a few of them in India itself, that we locally support. Essentially, they run their services behind application load balancer and get all the redundancy and load balancing advantages. In addition, we support a lot of rules like, you could say, hey, distribute based on geo, distribute based on content, images go here, video go there, and blah. And so all of those rules you can use to do that stuff. And then traffic manager, I talked about it. It's a DNS-based load balancer that sort of gives you a functionality to do more global load balancing. Finally, I'll talk a little bit about the 5G and edge computing. There's a bunch of things we are doing, and our partner teams within Microsoft are doing that are more forward-looking and into the future. Edge zones is one of those. We're working on edge zones with carriers. And then there's something called Azure Orbital, where we use satellite paths as part of our backbones and also as part of connectivity options to our customers. So, we talk about intelligent cloud and intelligent edge. There's a lot of scenarios, industrial scenarios that we talk about nowadays where, new scenarios emerging where, you want really low latency for your network devices, for your industrial devices to get onto your services at the back. And so you want real close proximity to edge, get onto that, get onto your services, get real-time, feedback and implement your scenarios. And then there is this whole thing, as soon as we talk about Azure in-premise and Azure on the edge and Azure inside and edge zones and inside the cloud, we are essentially talking about, hey, am I secure all through, right? So the consistency in how we work, the consistency of identity, and the consistency of management, the consistency in security, and all the benefits that we get from the advances in artificial intelligence. All of that sort of across this horizon sort of helps our customers do smart things across. All right. This last slide I have, I wanted to talk about my team here, the Azure Networking India Development Center. We are part of the global Azure Networking Development Team. We do a lot of work, that sort of overlaps and where we extend the work being done either in, the Seattle area or the Bay Area and many other, centers we have across Azure Networking. But in terms of number, we are the second biggest center, outside of Redmond. We have a team in China as well, and so we all work together. But the good thing is that we have a pretty strong presence in the region, and we are there to help our customers. And we utilize this difference in time zone and presence in time zone for the benefit of our customers, and we organize ourselves in that way. We have three main sites where teams are. This building right here, it's a beautiful building. We have a team sitting here. We have a pretty strong contingent sitting in Bangalore, one in Noida, and we have few people who just work from home. So, and as you can see, we work on a variety of things. We have a big team. We have about more than 400 people now, and we work on starting from hyperscale, which is the backbone, right? The WAN and the physical network and its reliability, but also into how do we access our devices, what are the tools we build, the virtual networking stuff I talked about, the security application delivery stuff I talked about, the hybrid connectivity I talked about. So we do all of that work across in India and are happy to collaborate in whichever way that it makes sense. All right, with that, call it a day. Thank you for giving your valuable time. Thank you for being here. I'd let the session go on. If there are any questions, you want to come interact, I'd be around during the day. Happy to interact for whatever that may make sense. Welcome again. Thank you.
Hey, thanks Vijay for a wonderful session for Azure networking overview. So the next session will be from Guohan from Redmond. He will be talking about Sonic future and new development which has been done in Sonic. Before I hand off to Guohan, I just let everybody know and introduce myself. People keep coming to me. So in hustle of starting the conference, maybe I could not get time to start myself. I'm Ashay. I'm part of Azure Networking. And I am part of Sonic community from the start, almost like 7 to 8 years now. When I was in Redmond, I was a part of group where we all started together Sonic. And now from IDC, I do represent Microsoft in Sonic and open source community. Thanks. Thanks a lot. So I will hand off to Guohan now. Thank you.
Hey, hello. I'm Guohan. I think you can hear me. I can see the big screen. Yeah, I think welcome to Microsoft, and I'm really happy to be here to represent Sonic community from Microsoft to talk about some recent development in Sonic for our data center. As you know, the Dave and introduces why Sonic, because one of the big reasons for us to develop Sonic is that this is a white box, this is a Linux, so we can develop the feature that we want that really meet our needs. So we can do a prototype and develop using a couple of months, and we can get deployed in our production and really benefit Microsoft Cloud. And I think on the other side, you can see from the VG, there's the Azure, they have a lot of scenarios, different networking problems we need to solve. And in this talk, I'm going to, talk two examples that we did in Sonic that really, helps, us to drive the, helps the Azure to build the cloud. Okay. Okay, so the first case I'm going to talk about is the dual TOR evolution, the way that we started from the single TOR in a rack to this active dual TOR solution in Azure. So I'm going to talk a little bit about the evolution of TOR topology, and then there's a quick recap about our first solution for the dual TOR is active standby, and then now we are working on active dual TOR solution, and then talk a little bit about the future. So as you can see on the left side, that is our existing or traditional topology, where you have the T0, which is a TOR connecting to the servers underneath, and then from that T0 it connected to the cloud, all the physical networks, the T1, the T2, and the global network, right? So for this topology has been used since the beginning. However, this topology have one fundamental issue, is that this T0 becoming a single point of failure in regard to the servers. Right, so because all the servers are connected to the T0, if the T0 is broken, then the servers lose the connectivity to the network. And also, if the T0 need to do some software upgrade, then the customer may experience the downtime because the T0 is upgrading, cannot forward the packet for the server. So that's one of the challenges in the physical network world. So therefore, we have been thinking about this problem, and then we first propose a solution where we introduce a smart cable, and using that cable to connect to the server with two TORs. So on the left side, there is we call the upper TOR, which is a green red path, and on the right side there is a lower TOR, which is a blue path. So these two TORs are in active and standby mode, meaning that at one moment a server can only talk to one of the TOR and go to the rest of the network. However, this does solve the previous single point of failure problem, because if one TOR is dead, then we design a protocol which allowed us to for the server to quickly switch to another TOR for the network connectivity in hundreds of milliseconds. Then with this already already in develop and in production, then we are looking at further to see if whether we can improve on this dual TOR solution, basically moving from active standby to active solution. Okay, so this is how the active standby dual TOR works here. So what we did is that we worked with the hardware vendors, especially the cable vendors, to design and build a smart cable. So usually when you see the cable, right? So that connecting to the Tor server, it's usually a DAC cable. It's a copper cable, that passive copper cable that connecting to the Tor to the server. However, with this active standby due to solution, we work with the vendor to come up with a smart white cable. In this case, the cable will have one side connecting to the server, and on the other side, this cable has two legs, and one of them connect to each of the T0. One of them connect to the T0, and one of them connect to the LT0. On this smart white cable, there is a specialized chip, we call the Maltz chip. The Maltz chip is able to direct the traffic based on our control path for the server traffic to either go to the upper Tor or go to the lower Tor, and this direct can switch within microseconds. So in this case, if we connect the Maltz, the red line, to the upper blue line, then the server now talk to the upper Tor. If we direct the Maltz, connect the red line to the dotted line for the lower Tor, then the server connect to the lower Tor. This is how we build the cable, and then be able to achieve this active standby due to a solution. As we see, right, so this solution allowed us to move the single point of failure from the Tor to the server, which solves the Tor failure problem. And then on our side is very backward compatible, because we don't need to change anything on the host, on the server side. We just connect the server to the dual Tor with a smart white cable, and then application running on the host is basically agnostic of all these network infrastructure changes. So for what the server looks like, it still have a single NIC with a single IP, but however, with this smart white cable solution, then we are able to provide the redundancy for them. So all this development, you can imagine, how to control the smart white cable, what is our protocol that running between the two Tors to ensure that when the link goes down, then we can failure within the millisecond. It's all developed on Sonic, and it's all open sourced, and people can see it, and they can check the code and then see how it works, and then can take the code and then deploy in their own environment. So for the next, then after we finish this project, then we work with our architectural architect to ask the question: why can we use both links of the Tor? So in that case, we can do actives, and we can, because we use both links, we are effectively using the capacity of the both Tors. Instead of say, for example, 100 gig link to the server, now we can do 200 gig link to the servers, right? So that's one of the questions we asked ourselves. Then we move this project further to develop a solution with active dual Tor. So in this setup, on the right side, you still have this lower Tor and the upper Tor, and but on the right side, on the server side, instead of a smart white cable, we put the smartness into the NIC, and use a smart NIC to deliver this active due to solution. So in this case, the NIC has the FPGA that can do similar things as a smart cable. However, because now we have two dedicated DAC cable connect to the NIC naturally become a 200 gig solution. And then because of the FPGA, the smartness of the FPGA, then we can basically now doing active instead of active standby. So next slides, I'm going to compare a little bit comparison between the active standby solution and the active solutions. So So one key point is that with this smart NIC solution, when we provide to the server, is still a single IP solution. Basically, the server would not see any of the difference, whether it's active or whether it's a single tool, active standby tool, or active. It's agnostic to them. So then the only difference is that because now for the active solution, we have both links. So therefore, when we send the traffic from the server, we are doing the ECMP now. So basically, you can see from the server northbound IO, and for the active solution, we are doing the ECMP to the both store. Imagine the traveler is sending 200 gig traffic. Then those traffic will be ECMP'd by the smart NIC to both of the TOR. Therefore, we can achieve the active solution. And also because now there's a smartness in the NIC, and then someone need to control the NIC to set up the active or standby state for each of the link. Therefore, instead of controlling the control, which we previously used the I2C protocol to control the cable, now we are using the gRPC protocol to talk to the NIC and set up its status. So the TOR still is the controller, is the brain to decide whether this link is active or not. If we decided this is active, then it's using the gRPC to talk to the NIC to set up the status. So therefore, the NIC can forward the traffic to the TOR. So this is a little bit more roomy for the IO model for this active dual TOR. So the one that we specifically talk about is northbound traffic, where the traffic is coming from the server to the TOR. So in this case, at this smart NIC side, it's doing the ECMP. This is the FPGA, so it's doing the ECMP. It has two FIFOs, each FIFO connecting to a T0. So therefore, traffic is being spread into the both T0. So however, on the southbound traffic, when the T1 receives the traffic, because he now knows that the both TOR can receive the traffic and forward the traffic to the server. So the T1 will also do the ECMP to both TORs, and then when each TOR receives the traffic, it will send that traffic to the host. So therefore, in this model, we're moving from active standby model to active model when we're doubling the capacity that we're giving to the server. So this is a more forwarding state decision table. So again, because we are open sourced, and so we put all this state machine into the open source code, and then from the active to active initially we developed the state machine for the active standby, and now we developed the active one. So the active one, the state machine will be running on top of the active standby. So therefore, we have a single state machine that can support both active standby as well active solution. Therefore, there's a single code base here that is running on Sonic to support both scenarios for our customers. Therefore, it really help us to speed up our development process. Save our investment, and we control the code. Therefore, we do quick iteration and develop all these protocol. And now, the first solution is already in production, and the second solution we are already doing a lot of progress on that. So that's the first topic. How the Sonic helps Azure to build a dual tool solution. So moving to the next topic. So I'm going to the ongoing project where we are trying to introduce a smart switch in our data center to build the limitless network for SDN. So the concept of smart switch is that now for the existing switches, you all know there is an ASIC that developed by the ASIC vendors and can do very fast packet forwardings. So that's the first the switching ASICs. So it provides all from ports. The packet coming, get forwarded by the switching ASIC and then forward to the destination. So in this smart switch concept, we are bringing additional the DPU chips into the smart switch, so that the packet coming to the smart switch, some of the packet, most of the packet will still be forwarded by the switching ASIC, but some of the packet that needs additional packet processing will be routed to the DPU and get further processing by the DPU and then send out from the smart switch. So in this case, because of the DPU has a lot of packet processing power, it can do the stateful packet processing. Therefore, with this smart switch, we can really do something that helps Azure to build the SDN functionalities. So here is why we're doing the smart switch in Azure. It's mainly because of the for our Azure, we have a physical network which is doing the data plan forwarding, and then we have a virtual network which provides the user the isolation that they needed. So a lot of the policies that user sees is applied on the SDN layer. So, however, one of the challenges of the SDN policy is that all these SDN policies is stateful policies, meaning that you need to track all the connections, the TCP connections, UDP connections, in order to apply the policy. But traditional switching ASIC, they do not have such state to apply SDN policies. Therefore, generally the SDN policies is applied on the host side, on the NIC side. However, if you think about it, right? So each host, they have their own NICs and they do the SDN policy apply. The problem for that is that when you have a lot of hosts aggregated, and some hosts need, need more SDN policies versus some hosts that need little SDN policies. So therefore, you cannot really aggregate all those SDN policies, because when you're trying to apply each SDN policies, you need those computing powers, those network packet processing powers. So the idea of the smart switch is to be able to create a pool of network processing powers so that it can be dynamically allocated to each of the VM that need the SDN policies, so that it can be used on demand. So therefore, for example, some VMs use more SDN policies, some VM use less SDN policy. They can all get those network processing power from a common pool, which is from smart switch, and then therefore we can amortize those network processing power among all our customers, therefore bring down the cost for building such SDN processing capabilities. So for example, in this case, as you can see, this is one of the VMs. So normally the SDN policy is applied on the FPGAs, right? So instead of, in this case, we're moving those SDN policies on the smart switch, and then therefore, the SDN policy is applied on the smart switch, and then, packet goes to a smart switch and then go back to the VM. So therefore, we can create a common pool that be used by all the VMs. That's the idea for the smart switch. So, and previously, we talked about the Sonic innovation on this T0 layer where we build the Bluetooth solution. Now, we're also trying to innovate on this T1 layer where we build the smart switch and provide the SDN capabilities. So therefore, user can use it on demand, and we can lower the cost. And sometimes, you think about if the user needs lots of SDN policies, and it cannot be supported by a particular PGA. Then because we build this common huge pool, then the people can find those demands on those common pool and then satisfy their demand, right? So therefore, the concept of pool is not just helping those users that use a little SDN policy, but also helps the user use lots of SDN policies. So then I think so for the smart switch, in order for it to work, so we build a data plan that processing all those packets on the DPUs and both on the NPUs and also on the DPUs. So in this case, for example, when we build the smart switch, we build at the T1 layer where there are multiple smart switches there, and so one of the key challenges here is to be able to provide the high availabilities for the services, because now you have a common pool, and what if one of the T1 is dead? And then at that moment you don't want to lose the customer VMs to lose the connectivity. Therefore, you kind of need to build high availability solutions among all those T1s in order to provide the service. Therefore, when one of the switches is dead, then you still have other switches in this cluster to provide the same service for the VMs. So then the customer will not experience any disruptions, right? So this is basically the idea that leveraging smart switches within a cluster to provide HA solutions, where one of the or several of the smart switch goes down, it doesn't affect the customer. The other smart switch will continue to apply the policy for those VMs, therefore letting the traffic to continue go through. So we do use a VXLAN, and we use a lot of technologies here to provide that high availability. So this is more concrete examples of how we are providing availability here. So basically, for the DPU, one of the DPU will be active. One of the DPU will be active, and the other DPU will be standby. So however, both of these smart switches will advertise the same customer IP to the network, so that the traffic will come into both of the switches. However, because the switch knows the DPU status, so when the standby switch receives the packets, it knows the active DPU is on the other switch. Therefore, it builds a tunnel and first tunnel the packet to the active switch. And then when the active switch receives it, it will decap and send the packet to the DPU. However, if the packet arrives this active switch, it knows the active side is on my side, so we'll forward the traffic direct to the DPU. And we build the monitoring among these NPU and DPUs, so that any of the switches, component is dead, then automatically failover will happen. So this is more, quick example of how we doing these pairings between all these different smart switches. So there are several pairing schemes. So what we eventually do, what we are trying to explain here is that for each DPU, it can host multiple VMs, which we call the ENI, the Elastic Network Interface. And then we are basically duplicating those ENIs among different DPUs so that the state can be replicated among those pairs. And then one of the smart switch, for example, in this case, 1B, this smart switch is dead because all their ENIs, these 5, 6, 7, 8, are replicated in different smart switches. For example, this ENI 5 is replicating the smart switch D, and the ENI 6 is also replicating D, but 7 and 8 are replicating the smart switch C. So therefore, when this smart switch is dead, this T1C and T1D will be resume the responsibility of carrying the traffic for those ENIs. And so therefore, through this way, we can provide high availability for the customers. Yeah, I'm going to skip these slides and go to the next. So in order to build this solution, we do need some new requirement for the. Of course, we need the SDN policies apply on the DPU, but we also need some new requirements on the NPU on the ASIC side. These are the list of requirements we gathered, and then we are working on to develop a solution, based on those requirements on those switches. And here is our software architecture. So the smart switch, we have DPUs and we have NPUs. Here, all these DPU and NPUs, they are within the same smart switch. They are within the same smart switch group. And however, and all of them, including both DPU and NPU, they are running Sonic. So they are running the same software architecture. So we can leverage a lot of components we have already built on Sonic. So therefore, we just need to build some additional component to do this HUA stuffs and then apply the SDN policies. So there we already have a, so as you know, Sonic is an open source community. So we operate under Linux Foundation. So for this solution, we build a smart switch group, working group, which is open to everybody. And we are having weekly meetings on this smart switch group to discuss all the architectures, requirements, and we share the code with each other. So we are all doing the testings together. So this is how, it's an ongoing project. It's a lot of interest because it brings a new capability to the Sonic. I think this is the two cases we want to share with everybody on the Sonic side, that how the Sonic helps Azure. Thank you. Wonder if there are any questions or.
Thanks a lot, Guohan. If there's any question, I think we should, yeah, please go ahead. Okay, let's go. Yeah, I will hand off the mic.
The Sonic instances you mentioned, right, on the smart switch and the DPU. Are you running separate Sonic instance on the DPU and separate instance of Sonic on the main switch, which is the NPU? Or the configuration comes through a common Swiss layer, right, and gets synced to a syncd depending on whether it is going to NPU or it is going to the DPU. So I think that's not very clear here.
So I hear some echo.
Okay, let me repeat the question again.
No, I hear the question. I hear the question. I just when I talk, I hear some echo. Now it's fine. Okay, so yeah, so I think I skipped these slides because it's a little bit more detail on the software architecture, right? So I think first is that yes, so the DPUs. This is a smart switch. In this case, we have two DPUs and one NPU within the smart switch. And for each of the DPU, yes, they are running separate Sonic instance. Because the way the DPU works, you have the ARM core CPUs, right? So therefore, it has a Linux system running on it. That's how the DPU works. So therefore, we are bringing the Sonic up on those DPUs. So therefore, the DPUs are running Sonic. And meanwhile, I think we have the NPU, it has a CPU. That NPU is also running on Sonic. So in terms of SDN policies, when we apply the SDN policies, here is what we're thinking, right? So to the outside world, we provide a single northbound interface to the outside world. So therefore, when the SDN controller they are talking to the smart switch, they do not see the DPU separately. They only see a single smart switch, right? So so therefore, that's where we run this agent on the NPU side. It's called a GMI agent. So it takes that SDN policies. So SDN policies will say, okay, is this a policy applied to a particular VM or which VM it is applied to? Then on this agent, there is a mapping to say, okay, for this particular VM or ENI, which DPU it maps to. And based on the mapping, we will put the SDN policies into what we call the AppDB on a particular DPU. And once the policy is being synced into this AppDB, then the corresponding DPU will read from the AppDB and apply the policy on the DPU edge. So hope this answers your question.
Yes, it does. I have another follow-on question on the active-active connection, right? For the first use case, where you have redundancy through the cable, right? The same cable runs from the server to the switch, to two T0 switches. Okay, and when you make it active-active, you're basically doubling the bandwidth. Okay, and on the one way, I think from the server to the switch, I think there is a load balancing, works fine. But what's not clear is when it comes from the T1 to T0, and if you're running ECMP and the hashes essentially map to one link, and they will if you use a 5-tuple hash. So there is no load balancing happening. It's like 200 gig going out and only 100 gig coming in. How do you are you doing a round robin kind of ECMP in this specific case from T1 to T0 and LT0?
Yeah. So I can explain this one. You are talking about how this ECMP works. How this ECMP works. From the T1 to the T0, right? So.
Right.
Yeah. So, I think you are right about if the flow is a single flow, meaning that the TCP/IP 5-tuple is the same. Then we basically cannot do a good load balancing. The flow, all the packets belong to a single flow will either go to one of the T0, right? But this is the same problem with it going up. Therefore, in this 200 gig solution, we are not really be able to provide a single flow to 200 gig, right? But however, for the server, right? So because most of the case, the server is talking to many other servers, right? So for example, you have this, web server or, doing some kind of computation. They're talking to many different servers, either the internet or within the cloud. In that case, the underlying 5-tuple is actually different. For example, they talk to two servers, and your source IP or destination IP, depending on which direction, it will be different, right? So therefore, when they're going down, for example, the two server trying to reach to one of the server, so therefore the 5-tuple, the T1 sees the source IP will different, therefore will be spreading among those two T0s.
Okay, that answers. Thank you.
Yeah.
So
Thank you.
another question. So just wanted to understand rationale behind this design when you have another solution like multi-home EVPN, which provides redundancy in terms of end server connectivity. So why you're not going ahead with that solution rather than this solution? So.
Oh yeah, I think that's a very good question. So next time I'll make sure I add that slide into add the explanation in the slides. Okay, so there might maybe many solutions for multi-homing, either layer 3 or layer 2 at the layer 3 layer or layer 2 layer, right? So I think at the layer 3 layer, you have to use the BGP to advertise the multi-homing, right? So those kind of solutions, I think one of the fundamental principle we're doing this one is that when we provide these network services, we want to be transparent to servers, right? So, basically, when we first introduce this active standby solution to our network, this one, to the network, there is no single change on the server side at all. So basically, we just plug a new smart white cable to the server NIC and then make it work. Therefore, there's the server side, they don't have to do any development at all, right? So therefore, we completely decouple the changes in the network and the changes on the server side. So it makes develop much easier and make those changes much more contained. Because otherwise, think about if you have to develop a solution where you need to change some part on the network side, some part on the server side, then doing this coordination is very difficult. I mean, it's certainly doable, but it will be a lot more challenges to bring that into Azure at scale. So therefore, one of the key things that we do not need any changes on the server side. So that's why, we don't, for example, some of the L3 stuff, you need to run some stack on the server side. Therefore, we didn't choose that option. And then the another one is that, for example, like MLAC solutions, those solutions, I think one of the fundamental issue analyzed on those solutions is that the splitted brain problem. So basically, you have two TORs that both think they are active. Then, or both think, right? So in the MLAC solution, if both TORs think they are active, then there is a problem, right? So because of the peer link could be dead, and if you use UVPN, those tunnels could be dead, right? So therefore, in this active standby solution, we actually solve that problems of the split the brain by leveraging the cable. So we have a very unique design to how to communicate doing the state communication between this T0 and LT0 through the cable. We leverage some unique properties of the cable and then basically solve the splitted brain problem. So in our run, we did a lot of TOA analysis, the state machine transition for our state machine, and there is no case that we can go into split the brain problem. So I think there are some more detail of the design docs that always solve the problem, but these are the two fundamental reasons why we choose these approaches, and then the further work on the active hash solution based on the project.
Hi, Guohan. This is Ravi from Marvel. Nice talk, and I was able to appreciate how this solution improves the ECMP path from the server to the spine and the reverse way, right? It improves the ECMP path, but I didn't follow when people are saying it doubles the bandwidth, right? Because the server to the smart NIC connection is still the same. That hasn't doubled. So while this solution allows us to do better ECMP, yeah.
No. Okay. So when I say double the bandwidth, we're comparing the active. We're comparing the active to active standby case, because in this active standby, you can either connect this red line to the upper blue or lower blue. You cannot connect to both. So in that case, the server is 100 gig. Even you have two TOR, the server is still 100 gig. But in the active solution, because you now have two links coming out of this, to have two 200 gig links, you can effectively leverage both towards capacity, right? So that's what I mean. The double the bandwidth. It's not comparing. I mean, it's comparing the active standby solution.
Okay, makes sense. So the server's capacity still remains the same, but both the TORs get better utilized. Is that what you meant?
In the active solution, the servers, there were coming out of the server. So therefore, there's 200 gig bandwidth, right? So on the active standby solution, there is only 100 gig link coming out of the server, even though that cable split it and then connect to both TOR, but still you only have 100 gig bandwidth for the server. Therefore, you are wasting half of the bandwidth that the switch can provide.
Okay, yeah, okay, got it. Thanks.
Thank you.
Thanks a lot, Guohan, and thanks a lot, everyone, for asking great questions. Very interactive.
Thank you.
Thanks again. Next presentation is from Saurabh from Dell. Please come join the stage with me. So I will hand off for this session, and after that we'll take a short break and we'll continue.
Thank you, Ashay. Hello, everyone. Very grateful and excited to be here. This is the first Sonic India conference, and it's very exciting to see the Sonic momentum building up in India. And thank you to the Microsoft team for hosting this event. There's a lot of time, energy, and resources that go into in organizing an event like this. So very exciting. I'm Saurabh Kapoor. I lead product management and strategy for Dell Technologies. I'm also the Sonic Governing Board member representing Dell at the Sonic Governing Board on the Linux Foundation. Pleased to be here, and in this session I'm going to talk about some of the bits and pieces around the vision strategy, the set of activities we're doing in Dell in championing the technology forward, enabling the user group in networking with Sonic, and happy to take any questions at the end of the session here. So before we start, right, it's important to see how the networking ecosystem has been evolving over the period, right? And the way we see this is, right, following the footsteps of compute, right? Back in pre-90s, we used to see different vendor solutions and technologies in a rack, right? For application developers, in order to port an application across an infrastructure was difficult, right? There was no application portability then. But when Windows and Linux came into existence around early 90s, we saw one rack running multiple hardware platforms, same operating system, which led to a lot of application portability. What that led to was choice, ease, and flexibility for the users to deploy applications, to move faster, the time to market in terms of building services and capabilities, and take that forward. In 2002, Red Hat offered Enterprise Linux, and this is when a lot of adoption of Linux started to happen in the industry. This is when the users were able to do 1-800 support to get that velocity and get the infrastructure supported. So we see a similar trend happen in the networking space as well, right? Traditional networking solutions are proprietary stacks, create vendor lock-in, create dependency on the vendor to source the hardware, source the capabilities, the features, etc., enable to the solutions overall. Dell Technologies, looking at the challenges in that space, decided to take a path of a notion called open networking, which was basically disaggregating the hardware and the software to enable choice, flexibility, and the freedom for the users to adopt technologies of their presence. Around the same timeline, Microsoft was championing Sonic for Azure networking. We've been working with them over the years and looking at the technology benefits of Sonic, the containerized architecture, the API-centric posture. We decided to jump in and join the momentum. We decided to champion Sonic, extend the technology from hyperscalers to the broader enterprise market, to the telcos, and bring this technology forward, right? So in that pursuit, we wanted to follow a model like Red Hat, bring an enterprise version of open source Sonic, add features and capabilities to it, roll back those features back to the community, over the last few years, we have been contributing all those features back to the community, championing the technology forward, enabling enterprises and telcos and others outside the hyperscalers to adopt this for their environment. And it's been a great momentum. We enabled a bunch of use cases. I'm going to share that in the coming slides here. But it's great to see the momentum building up around Sonic. And in fact, in that pursuit, we have also extended Sonic on Dell and non-Dell platforms too, because the whole idea is openness, right? The freedom across the rack from hardware to software to application technologies give our users the flexibility to pick and evolve their networks with more freedom and choice. So looking at how the infrastructures have been changing over time, right? Now, if you look at the modern infrastructures, they're very different, right? If you look at, engage with users, you'll see that they want API centricity. They have in-house applications and tools that they want to integrate with the ecosystem. They want more openness. They want choice. They want, solutions and infrastructures that are cloud-inspired architectures, right? Because scale and performance is key. And while they achieve all of that, they also want to reduce their TCO, right? The total cost of ownership of those infrastructures. And in that pursuit, they want to have choice of silicon, multi-vendor ecosystems. They want to have unified software layers that run across multiple vendor platforms because, the pandemic was a big eye-opener, right? The vendor lock ecosystems were forcing the customers to be dependent on the vendors with the supply chain capabilities, et cetera. So it's important for them now to accelerate and gain momentum and build infrastructures that are vendor neutral, that are vendor agnostic in order to move with momentum and deliver to the services and capabilities they need from an infrastructure perspective. So how does Sonic enable that, right? It's a check mark across the board, open and extensible technology. Such a rich ecosystem, championing Sonic all the way from the silicon to system and service providers to early adopters and technology solutions which offer niche orchestration and monitoring capabilities, right? We heard Dave and Vijay talk about how these infrastructures are evolving, and very quickly. So Sonic provides a check mark across the board. The DevOps readiness, API-centric posture is important, right? They want solutions, they want capabilities that allow them the freedom and deliver on scale. Sonic running one of the largest Azure network, one of the largest cloud networks in the world, right, is a testament to the scale and the performance of this technology and how it caters to that across infrastructures, right? Innovation is key. Now, Sonic moving into the Linux Foundation ecosystem has been a great initiative where it now resides in a house where there are multitude of open source technologies that it can closely tie in and drive with velocity, drive with more infrastructure enablement across Kubernetes and other initiatives that are housed within Linux Foundation. And in that pursuit, we see a lot of momentum now garnering around Sonic. In the ecosystem around Sonic community, we have a governing board, which is responsible for championing this technology across the board, making sure that it's true to the cause of its value, enabling this across use cases, growing the community overall, and taking it across regions and use cases that's supposed to be, right? If you look at the journey over time, right, starting all the way from 400, 600 members in early 2016, early 2017 timeframe, to all the way 1,800 plus members now. It's massive, right? And you have the likes of Microsoft, Dell, LinkedIn, Alibaba, Google, Broadcom, Cisco, Marvell, and others now championing, all these technology forces now championing this technology and taking it forward is impressive, right? This is something very unique that is happening in the networking space. And from where we see, Sonic is the future of networking, period. Right? It's one technology that delivers on the value, the experience, and the utility that these users are looking for. Now, one of the big things that have happened, right, there's a Sonic Outreach Committee, and very impressive work happening by, or being done by the Linux Foundation team, Microsoft, and others participating organizations there. In terms of championing and enabling these conferences, creating more awareness of this technology across multiple forums. There's so many initiatives brewing up within the outreach committee that are championed by different organizations, different representatives in taking this technology forward. Every major industry conference that you see, Open Source Summit hosted by Linux Foundation, Open Compute Platform. Other events like ONEG, etc., have dedicated Sonic sessions. Be it the CFP, the call for presentations, or hackathons, Sonic is features across the board. And it's important for us, like a family, to participate, to contribute, to enable and champion this technology and take it forward. So I'm going to shift gears here and now talk about the Dell strategy around Sonic. So as I said, right, it's been around more than 5 years we've been championing Sonic. We have a commercial distribution of Sonic. What we do in that pursuit is offer a 24/7 support model around our commercial distribution, bringing more features and capabilities that are needed for enterprises, telcos, tier 2 cloud service providers, managed service providers to champion Sonic into their ecosystem. Right? We're building features, we're enabling new platforms, we're enabling next-gen silicon capabilities, we're building integrations with other open source tools like Telegraph, Grafana, Prometheus, Ansible to create automation solutions, to create monitoring technologies that are truly open to the cause, right? Enabling a complete CI/CD infrastructure as a code for the users to adopt their ecosystem, right? Along with that, we partnered with some really great solutions and organizations who offer niche orchestration capabilities and monitoring capabilities. Like, to name a few, we have Beyond Edge, Dorado, Abstract, Octera, etc. And I'm going to touch upon that more in the coming slides. These solutions bring choice, flexibility, and capabilities for the enterprises to adopt Sonic into the environment, right? And this is important. Why? Because this is not just about the hardware and the network operating system. It is about managing the network life cycle. It's managing the infrastructure where everything from storage and compute and networking comes together in delivering that promise. In that pursuit, one thing I will call out here is education, right? Training, demos, enabling and acclimatizing the users around Sonic. We have done things like management framework CLI to simplify the Sonic CLI experience, contributed back to the community. We have built Sonic trainings to help our users, our community, to get acclimated to Sonic, be it access to free hands-on lab, or getting access to user documentation where we are building reference architectures, like a solution at a time, production environment at a time across industry verticals, and making it available for the community to learn and absorb and understand what is out of the possible with Sonic. And it's rapidly growing. I have a slide coming up soon to talk about how those use cases have been championed over the period. So this slide actually talks to some of that, right? So starting all the way from a simple L3 underlay use case, starting early in the Sonic journey, to all the way starting in getting into the multi-tenancy, the VXLAN, VPN use cases that are primarily across the enterprise landscape, right? We've enabled features and capabilities to feature for the hyperconverged infrastructure, the converged infrastructure, solutions. Enable Sonic for the telco environments, things like Q&Q, VLAN translation, EVPN multi-homing, and whatnot to ensure that the telco data center environments are covered on that front, right? And then the latest release also brought in capabilities that we need for generative AI use cases, right? Bringing in the Rocky V2 support on the next-gen silicon to enable those enterprises who are championing generative AI use cases in the environment are able to build infrastructures that deliver on the scale and performance that is needed for those environments, right? And also enabling DCI. Why? Resiliency is important, right? These are infrastructures that are hosting big workloads. We saw Vijat talk about, how Azure is delivering on the promise, the wide range of services. This is mind-boggling, right? And these infrastructures powered by Sonic are delivering to those capabilities. So bringing things like DCI and enabling that. One other thing we have done in that approach is, as we champion Sonic across different enterprise data center environments, we also extended Sonic for the edge. These are branch edge use cases that need power over Ethernet, port security, and other capabilities that are important for these enterprises to enable a unified operating system from data center to edge. Why? Because it simplifies their tooling, it simplifies their automation and monitoring capabilities. They don't have to work with different vendor solutions in dealing with these use cases and pockets. They can have one technology that extends across use cases, enabled with the same set of tools and technologies, simplifies their experience, simplifies the skill set they need on the team, and grow that ecosystem overall. Here's a snapshot, a 360 overview of what we have in the truck, a snapshot of key protocols that we've enabled over the years, a portfolio that covers all the way from 1 gig to 400 gig. And look, here are some of the Dell platforms all listed in blue, and our partner platforms from Atcon EdgeCore. We're rapidly scaling our open hardware ecosystem, which is Dell Enterprise Sonic enabled on Dell and non-Dell platforms. And why is that important? Because we want to be true to the cause of openness, right? At Dell, non-Dell platforms, you have one operating system running across the board, one under Dell for support and enablement across the board, right? The other important aspect I want to talk about here is management and monitoring. Sonic is one of the very differentiated technologies. Why? It takes monitoring all the way from reactive, the SNMPs and syslogs, to streaming telemetry. It gives you the ability to have AI-based monitoring solutions to monitor your fabric. And it's important because the workloads are changing, the bandwidth utilization is changing, and next-gen monitoring solutions allow that. It allows for intelligent orchestration, right? We see so much goodness happening in the community where a bunch of orchestration organizations are coming together, championing Sonic, creating a true multi-vendor ecosystem, right? Every environment has multiple vendors, right? There's no real greenfield environment that we see out, right? And these intelligent orchestration solutions allow you to build infrastructures with Sonic and at the same time have multi-vendor ecosystem supported. So here's another view, right? This is what I mentioned earlier. Over the last 5 years, we've been championing use case by use case, right? Starting all the way from a simple L3 until A use case, which was primarily important for the tier 2 cloud service providers, for the managed service providers, then extending into multi-tenancy with VXLAN UBPN, right? We started to champion a lot of large enterprises, higher education institutes in that pursuit. Routing of the host was another interesting use case, where a communication service provider, wanted us to do routing from the host, simplifying infrastructures at the top of the rack, right? Then we extended Sonic for the edge, the branch edge use cases. When we were championing different stores and retailers, they had Sonic running in the data center, and they were very acclimatized to it. They wanted us to extend it to their thousands of stores, right? Massive infrastructures, very difficult to manage. And we extended Sonic to support on our next-gen E series, Edge series switching platforms, which offer 90-watt power on every port, enabling those next-gen use cases. There's so much data happening. So data is the new currency, as I say, right? Data boom on the edge is important. So enabling that one unified NOS experience, simplifying the infrastructures across the board. Then enabling DCI for Sonic, right? And taking it across different SDN ecosystems we have. Enabling HCI and CI solutions infrastructures that need for that. And then in the latest release, bringing in support for RDMA, Ethernet, telco provider use cases with Q and qubit and translation capabilities, helping extend Sonic addressable market, as well as emerging technologies, emerging use cases across these environments and taking it forward. It's been a fantastic journey, right? Enabling Sonic across use case by use case, taking a variety of industry verticals and use cases in production, hearing from those customers on why Sonic is important. In fact, at Dell Technologies World, we hosted a conference, hosted a session, and instead of us talking about the product and Sonic, we invited, the users of Sonic to come on stage and share their experience on why Sonic was important for them. How did they champion that technology into their ecosystem? What were the automation monitoring best practices they involved in their infrastructures? And these organizations are massive organizations that are scaling quickly. They want a lot of infrastructure capabilities to build new services and business capabilities on that. So it's great to hear. We had representation across every region, every industry vertical, and phenomenal feedback across the board. While all of this goodness is happening in the commercial distribution, we want to be truly open to the cause of open source, right? So all our contributions that are happening within the commercial distribution of Sonic are rolling back into the community, right? It's a crawl, walk, run. We're working with the community, making sure that every feature follows the IEEE standards, RFC standards, working with the community. We are among the top contributors to the Sonic community, simplifying this technology for consumption across enterprises, building an ecosystem of technology partners and solutions that enable that, take it forward, and we're going to continue to do that, right? It goes across product features, capabilities, as well as integrations with open source tools, right? It's a CI/CD infrastructure as a code ecosystem we're talking about, as well as documentations, release notes, tracking, website management. We have been championing a lot of those scenarios across the years. Lifecycle management is critical, right? It's not like a piecemeal strategy we're following, right? We need a element to support network infrastructures from day 0 to day 2 and beyond, right? A lot of good native capabilities available in Sonic, right? You have the cabling, the only install, zero-touch provisioning, Ansible-based automation to configuration with Ansible, bunch of partner solutions that allow differentiated niche capabilities specific to the use cases to enable that, operating and monitoring and diagnostics, right? A lot of good capabilities and API-centric capabilities available in Sonic. The containers architecture, the modularity of this technology further enhances and eases these partner solutions to come together and rally and bring the goodness of Sonic across enterprises. Here's a snapshot of the footprint so far, right? And why I wanted to insert it here is to show and reflect the applicability of this technology is beyond hyperscalers. It's gone across enterprises, and within enterprise is a big bucket, right? We see higher ed, we see FedGov use cases, we see banking, fintech, manufacturing, automotive, and whatnot. And name every industry vertical, we have Sonic running there. And it's been a journey. It's been a crawl, walk, run to enable features and capabilities. Sonic comes from a pure cloud environment, so there was a lot of enablement that happened between Dell, Broadcom, and others, championing and rolling back those features back to the community. And it's great. I think it's just the beginning to a massive evolution happening around Sonic. These customers have been very vocal about their experience, sharing the journey with Sonic, sharing the best practices, how they went about, the automation, infrastructure management, what worked, what didn't work, how they went about those roadblocks and challenges, and move forward with Sonic running the largest infrastructures across the globe. Team Blue, one of the great customers, right? They were one of the early adopters of Sonic within the enterprise space, managed service provider, right? And they were the traditional proprietary shop. They wanted to go towards open standards. Obviously, during pandemic, they didn't want to be in supply lock-in. Working with them, enabling capabilities and championing that, and they were very vocal about, about the journey and the value we were able to get with Sonic. One of the feedbacks was like, we were expecting this to be a brand new technology, have a big learning curve in terms of adopting this technology in our infrastructure. But we were surprised to see how quickly we were able to move and set up infrastructures and then move Sonic with Sonic into production, right? They rolled it in the backup data center, spent a few weeks, and then, boom, they were ready. They said, this is ready for scale, and moved into production, 100+ racks, running Sonic in production. So massive growth, massive adoption. The customers are very happy with Sonic in production, and it's a great testament to the value of the technology, right? The fundamental, capabilities that Sonic offers, the value we bring as community and independent vendors, bring to the table around Sonic, we'd support, we'd services, we'd orchestration capabilities, building hardware platforms, next-gen silicon, and things like that. Feedback from industry influencers, right? It's important to keep a pulse on the market. And we've been working very close with these industry influencers, analysts from Gartner's, IDC, 650 Group, and others to keep a pulse on how the user environment, how the user requirements are changing, the networking infrastructure requirements are changing over time. Massive input, massive feedback around the potential for this technology to be scaled for growth. It's predicted to grab $5 billion by 2027. That's an addressable market for Sonic. And they have further broken them down across the hardware, software, and orchestration capabilities. In my journey in networking, I've never seen impressive growth for technology like this. And it's a testament to what this technology has to offer, right? And what they're also predicting is a significant percentage of these industry infrastructures, running Sonic in production, right? There have been numbers around 30 to 35%, big savings when they bring Sonic into the infrastructure. So it's all goodness, right? From next gen technology to overall, market, addressable market to, delivering the TCO benefits overall. What we have done in order to simplify the Sonic experience for our partners, for our customers, is create hands-on lab, right? These are pre-made hands-on lab for customers and partners and the community, right? And it's available for everybody to come in, experience the technology. These are pre-made, custom hands-on lab to get acclimated to Sonic, feel it, experience it, validate for the use cases, and take it from there. We're also building knowledge repositories of documentation, best practices that we have been, capturing and experiencing across multitude of use cases that have moved into production. And some of those are captured and made available. And why is this important? Because there's so much we can learn as a common knowledge across use cases, right? A telco can see what a cloud service provider is doing, what a managed service provider is doing, and enterprise can do the same across telco and CSP. So there's a lot of common knowledge. Route the host, which was typically a CSP use case, is now running across enterprises, right? Fintechs and banking, which is impressive, right? Because they're now able to build cloud-inspired architectures to feed for those environments. So really good work happening in that side. With that, I'm going to wrap up here. Point you to a bunch of links that point in that direction. We've built a lot of material around Sonic, the capabilities. We're doing a lot of that in the community. We're the number one in the community to enable documentation, website management, analytics, and contributions, etc., as well as making sure that the customer-specific knowledge is captured specifically on the Dell website. So here's the link to check it out. Any questions, partnership opportunities, discussions, etc., please feel free to reach out to us. Ask Sonic PLM is the email alias for you to reach out to us, and then we'll continue to champion Sonic across the board. So thank you all for joining and having me here. Great to see the Sonic momentum building up here. On my role at the governing board for Linux Foundation, we continue to champion Sonic across the board, take it forward, do more of these sponsor initiatives like these, and then scale this technology to the next heights. So thank you again. I appreciate the time here. Any questions, anyone?
Yeah, so it was very interesting to hear about your journey with creating a fully supported Sonic offering for your customer base.
Yeah.
So the one thing that I was curious about is, what has been your experience since you've done this for 5 years and beyond, reconciling the needs of your customer base and their timelines and their kind of solution offerings with what's going on in the community, similar work going on out in other parts of the community, and then kind of reconciling it all over time?
Yeah. That's a great question. So it's been a fun journey, right? Every evolution comes with its own challenges and in the adoption cycle. So it's been a crawl, walk, run, as we say. What we followed from a strategy perspective was addressing a use case at a time, right? Building a capability is what we need from a banking perspective, fintech use case, a telco use case, identifying niche, wrapping our arms around it. What are the feature capabilities we need from a hardware perspective, from software, from orchestration capabilities, etc., and then knocking it off use case by use case. If you look at the broader industry use cases, right? Sonic may not fit all the use cases today, right? So it's important to narrow down what are the requirements needed for a certain use case and how do we address that with Sonic. And while we went about this journey, right, we wanted to make sure that all of the stuff that we're building into the Dell Enterprise version is not locking in the customers, because the value is openness, right? So we've been working with the community over the years, rolling back our features or platforms, enabling even the community Sonic on our platforms, and rolling back those features and capabilities back to the community. I think roughly, in million lines of code, 5,000 to 6,000 plus defect fixes. We also have a dedicated engineering team that is running and hardening Sonic into the environment, and then contributing those bug fixes back to the community. So that what we have experienced, what we have fixed, is not a struggle for others in the community. And it's important that as a community, we come together in that effort.
So one other follow-up, what has been your experience migrating across generations of Sonic?
Well, the generations of Sonic, I think, it's been a lot of work around quality, scale, and performance, right? Especially when we come into the enterprise play, there are certain regions that are very differentiated from a scale and performance perspective, right? I'll take an example of telco, right? What we see number of subscribers for a telco in North America, Latin America, and even in Europe is very different from what you would see in India, right? The number of subscribers to a tower is very significant. So in that pursuit, looking at the scale and the performance requirements, right? A BFD scale that we need in Sonic in India could be very different from what we need in North America. So we have been kind of fine tuning some of the knobs in terms of taking that journey. Sonic is very mature now from where we started in 2016, 2017. I think the credit goes to the community working together. Broadcom, Marvell, Cisco, Dell, everybody coming together and championing this forward. So I won't discount anybody's contribution that in development. We've all championing this technology forward, and so it's come to a very nice maturity level. It's getting enterprise ready broadly, and now getting into the broader telco environments, right? Telco DC is good. Next would be ORAN, backhaul slicing, all those use cases.
Hello. Yeah. First of all, thanks for your presentation. Yeah, I saw the number is around 4 billion for the Sonic addressable market, right?
Yeah.
Would like to know the market size, which is beyond the data center, as you have mentioned, like 5G, edge computing, or maybe more. Yeah. And how we can grab, what are the contributions or the action we need to take to grab that market in coming years?
Yeah. No, that's a great question. So what I have is very latest from Dell Oro. They reported $5 billion by 2027. This is across hardware, software, and orchestration capabilities. There's also a view that they have kind of carved out where there's a portion that is available for commercial Sonic, community Sonic, across enterprises and telco. So I would refer you to that, Dell Oro results. They've also predicted a cumulative $100 billion market overall for the next 3 years, and then around 10 to 20% of that dedicated to Sonic. So there have been some, data and analytics available out there. I think one thing that is important for us to address, to target that addressable market is looking at what those enterprises need, right? For enterprises, they don't have an army of engineers to really, have in-house support around community Sonic and things like that. So I think support is very important, right, for a software. We're talking about data center use cases here. What's also important is, right, the silos that these enterprises have. Take a typical retailer, they have data centers, and they have like maybe 2 or 3 data centers in a region, and then thousands of stores, right? And those are massive environments. So how do we simplify those enterprises to deploy Sonic across those use cases? How can they manage it, creating federation, create better orchestration, simplifying the monitoring experience, right? A typical retailer now is no more using the security cameras to look at the security aspect of it, right? They're monitoring the avocado heap, the apples in their inventory, they're running analytics around it. There's so much edge compute that is going behind it. They're getting, their store managers alerts on how they can better manage the supply chain inventory. So there's a lot of edge compute that is also happening, right? How do we simplify that experience? So it's all about, I think, engaging with those customers, those users, understanding their networking challenges from supply chain to technology to the next gen business capabilities and services they're building out, and offering differentiated capabilities that address those challenges. So that'll be my take on that.
Sounds good. Thank you.
Right.
Hello. Yeah, thanks. You already kind of asked my question. This is Amitabh from Broadcom. What has been the market take so far on Sonic on Edge, and what kind of features do you see immediately comes on top of your head? Yeah. What we are missing at Edge to really take on?
Yeah, no, that's a great question. So it's rapidly scaling. Sonic for the Edge is a very recent enablement. We started by enabling power over Ethernet and port security as the first ones. And it's very customer centric, right? So a customer by customer, use case by use case. So we started with the branch edge use case as the first enablement, and now we're looking to extend that out, to the telco edge use cases and beyond. A bunch of capabilities available in Community Sonic that we could leverage to drive feature velocity and bunch to work on. Security is key. I think when you look at the edge, you know, the one thing that is very key, and especially with an open source technology, is the security aspect. So a lot of our focus from a feature enablement on the roadmap is around that, right? And that goes across from what are the standard federal certifications like, you know, FIPS and USGB 6R1, common criteria, DODN, etc. So getting those certifications to make sure that, you know, it's a secure solution. And then also extending out those use cases, those capabilities that we need, right? Some of those available in community are SRv6, ISIS that you need for telco backhaul, network slicing, and those kind of edge use cases. So I think it's more around use case by use case. We've knocked out branch edge use case now, and then we're looking to extend that across the roadmap in the next set of releases. All set? All right, thank you everyone. I look forward to meeting you all during the conference.
Hey, thanks a lot, Saurabh. So what we will do is we will take a small, like 15-20 minutes break, get our energy back and come back. The next session will be from Cisco. If anybody in the room has not collected a t-shirt and lanyard, please collect that. So it's like 11:10. So what we will do, like 15-20 minutes break, like have a quick chit chat. And if you want, anybody wants tea, coffee or juice, it is at the same place where we had the breakfast. So let's start like 11:30. So yeah, let's take a short break. Thanks everyone. Thank you. Hello. Yeah. Hello, everyone. So we have 5 minutes. Let's start in 5 minutes. 11:30. I hope everybody's here. Okay. Hey guys, if anybody came later who has not collected T-shirt, lanyard, and book, please go and collect from the desk in the corner.
Gautam, I'll keep my mobile here.
Yeah. Sashi, am I right? Samir.
Shashi idhar. Samir is not here. Yeah, he's missing.
Hel- Hello. Yeah. So I hope we all had a good break. The next presentation is from Cisco, from Sashidhar, who will be talking about the VPP data plane for Sonic.
Thanks, Asha. Hi, my name is Shashidhar Patil. I work in Cisco Systems. And thank you, Microsoft, for inviting us here. And thank you for supporting us in the development of Sonic VPP. There is another contributor to this, Samir. He's missing from the workshop. We'll begin with right Sonic. What is Sonic? I think a lot has been covered, so I'll skip Sonic. You'll find details in the search. Okay, I'll directly jump to the Sonic VPP, and before I go there, let me give some pretext of Sonic VPP. This architecture was presented in Seattle. It was a concept back then in November time. We had a prototype working. Now we have Sonic VPP functioning. It's already open sourced. Okay, so I'll first highlight some of the Sonic VPP architecture details. I'll not go into the detail. The details can be found in another the past presentation which was done in Seattle. Okay, so why Sonic VPP? And Sonic VPP came into picture because there is a missing virtual data plane or a software data plane in the Sonic world. Right now you have virtual switch, which is mostly used for doing the sanity test, functional test. Okay, but it doesn't support a lot of features, and the data path performance is quite limited. The reason being there is packet copy being done from various interfaces in kernel level. Okay, so those multiple copies, right, as you know, leads to performance being going down. And what we are looking for is a data path like VPP, where it can run commodity hardware. It can be ARM or Intel. It can take up any NIC. Right? Not only NIC, it supports virtual ports also. So if you want to experiment, it's so straightforward to use the Sonic VPP. You load the image in a container, right, and you pass virtual interfaces. You can create a very complex topology with Sonic VPP right now. And second important one is the use cases. Sonic VPP, can be used as a development vehicle. To do the development testing, right, and doing some topology-based testing also. It can be used as a virtual router, virtual gateway, but virtual gateway still requires some other features which are missing. But as a cloud router, it is functional right now. We'll go to the last slide. You will see that there is a customer who has kind of deployed this as a cloud router to do the right VPN service for various customers. And the last one is the stateful services. Still work needs to be done, but the fundamental, I think, the foundation of Sonic VPP is there. We just need to extend those, right, SAI API to support NAT and IPsec. So those are the use cases. This is to present Sonic VPP at a very abstraction level. So you can see adapter host, VPP adapter, VPP, the prominent blocks, and they are all part of Sonic. So it's visible on the right in that square box. And adapter host being Linux, running Sonic control plane protocols, right, various things. BGP, Swiss, Arc, right, Arc agent, syncd, teamd. So all these processes come together, right, and which form the platform independent part of Sonic. And then these work together and initiate SAI messages. That is the SAI interface here. And VPP adapter is something which is developed for Sonic VPP. Right, and that's the motto of this project. And then comes the VPP, which is the actual software data plane, which does the packet switching, right, routing, packet switching. It can do L2, L3, right. It can even run level layer 4 load balancing. But right now, we have done the L3 routing, right? I have taken that as a major use case and implemented that. And the last one missing here is the NIC. You don't have, high speed, SerDes connected ports here. It's a commodity box running NIC ports, which are connected through the PCI Express, but they do get represented as the front panel ports on Sonic VPP. We just continued the architecture, right? We just extended it to the regular NIC ports. Okay, so this is the same slide, which was there in the earlier. This is how we started the realization of Sonic VPP. Three important blocks here, other than the NIC ports, which I just mentioned in the previous slide. The main block, right, the Sonic control plane, you can see on the top of it, and then the Linux kernel, and the last one is VPP. This is running as a VPP process. It can be run as a process in a container, or it can be like another, right, as a systemd process. But right now it is running as a container process. So the Sonic, as you can see, right, so there are various pieces here. The green ones are something, which are new additions done for Sonic VPP. We basically, program the platform JSON, the hardware SKU JSON, as per the number of ports available. Unlike a switch, right, the hardware switch, where everything comes pre-built, as in if it's a 32 hardware SKU, 32 by 400, 32 by 100 gig, it's pre-built. The system knows about it. So in a commodity box, you wouldn't know in advance like how many ports. So that's the reason we had to play with the platform JSON and hardware SKU to only program the ports which are there. It has a greater implication because if the number of ports configured are not the number of ports which data path reports as up, right? It doesn't work. Sonic doesn't function, by the way. That's how it is. And so that configuration fed into various databases which are backed by Redis, right? AppleDB, ConfigDB, StateDB, ESICDB. It's the ESICDB, right, which is the source of truth. And the Sonic writes into the ESICDB when everything is accepted by the syncd. Syncd is the one which takes all the SCI in this case, right, messages. And you can see the green box here, libsci VPP, which converts that into something called VPP messages or VPP API, right? From SCI API to VPP API. We'll go to that part in coming slides, how we do that translation. And then it directly sends to the VPP through to something called binary API, which is a Unix socket, and some kind of API, marshalling is done. The messages are marshaled, unmarshaled, and reaches this. And Linux kernel comes as a more of a facilitator. The front panel ports, which you see Ethernet 0, they are basically NetDev interfaces. In this case also, we'll create NetDev interfaces. But what we have done for VPP is we have extended that NetDev to also get into something called Linux CP plugin. You can see here. So that is part of the VPP. So this NetDev interface plugged into the VPP gives you the host bound packet IO. Packets generated from the system go through this and reach VPP, and anything comes to VPP meant for the host, they come through the VPP and enter into the Linux kernel. So that's the VPP part, and VPP has two parts here. The plugin which is doing host IO. There is a configuration part which takes the configuration in VPP binary API format, provisions the data plane, and the last one is VPP workers which are doing the packet processing. They take this fib neighbor entries built and do the packet forwarding. If it is a ECL, the ECL is applied on the interface in the input or in the egress. So depending on that, and the NIC ports. Though they are visible here, they are not owned by Linux. The NIC ports are owned by VPP, Okay, and it's always the Sonic which tells which NIC ports to use to the VPP as part of the configuration. We'll go to a simple deployment model, and this is what is implemented. And there are other models, thought about, but this is far simpler and what many are using. It's a single host. Everything runs as part of a single commodity server or a VM, or it can be a container. So there is a lot of flexibility, right, with this model. And you can see Sonic, right, runs in a bunch of containers. You have kernel. It's very abstract, and VPP being one of the processes, communicates with Sonic and the kernel to achieve right, the configuration, provisioning, and the data path of the data path handling of packets. And we have the foundation NIC. Foundation NIC can be anything. Okay, don't visualize it only as a physical network interface. It can be a virtual, as I said. Next. Okay, so far so good. That's all the history, right, which was already talked about in the past presentation also. This is the state of affairs now. Sonic VPP development. What really is part of right Sonic now, right? So all said and done. So from the software point of view, if you look at Sonic VPP looks like a Sonic platform VPP repository. It has a bunch of configuration files, make files, right, which define a platform called VPP. Like any hardware you bring in right in the Sonic world, you require to define a platform. VS is a virtual switch platform. You have Cisco 8000, right, comes as a Cisco 8000 platform. So similarly, it defines a platform as part of those files. And the second important part here is the SAI VPP, which runs as part of the syncd. It's the, it links with syncd as part of a SAI VPP library, and it is modeled on SAI VS. Most of the right logic is taken from there, but that's where the similarities end. And once the SAI messages come into the SAI VPP, like I said, they get translated. We'll go to that in the coming slides. So that constitutes Sonic VPP in right in flesh. And building is very straightforward. Just do make Sonic. Do a JIT clone, make Sonic, builds a container image, makes Sonic VM. It builds you a VM image, right? But to run a VM image, it requires QEMU or virtual mesh VMware. I tested only on the QEMU. So I don't have the experience of to VMware. And the build process is straightforward. Instead of maintaining the whole Sonic build image, right, the main repo, what we do is we just pull on the fly the whole code from the Sonic build image, which is SonicNet Sonic build image. Apply the patches which are meant to support Sonic VPP platform. Okay, and then we initiate the regular Sonic build. Now all the files are in place and the platform is defined. So you just say Sonic, right? Make Sonic. It essentially does make build of Sonic, and you'll see the images in the target directory. The next part is testing. There are various ways to test. Manual testing can be done. There are a lot of readmes in the docs directory. You can just consult one of those. And there is a helper script called startsonic.sh. It will do starting of containers for you. If it's a container, single container image. VM image also, there are a couple of docs available. You can follow that and test it out. It's fairly straightforward. And if there are issues, please report to us on the raise an issue in the Sonic platform VPP repository. We'll handle it. So please consult the docs directory and the Sonic platform VPP. So you'll see the URL there, GitHub SonicNet, Sonic-platform VPP. So that is Sonic's development side of things. Now come to testing. So we mentioned T0 and T1. T0 is right now symbolic because not much switching functionality is supported. T0 is all about switching. layer 2, and T1, we get slightly higher, right, to next layer. That's where, right, Sonic VPP has its functionality. It does the layer 3, right, and in this layer 3, right, it supports all the layer 3 related features, right, VRF, routes, ECMP, ECL, right. So all that, right, we'll cover in the next coming slides. And T1, every image we build, we run it through the T1, try the BGP, right, with thousands of those routes. By the way, it configures, I think, almost 24,000 routes. And the first time it ran on Sonic VPP, I was surprised how it ran. It did, actually. So Sonic VPP with T1 with 24K routes is functioning well right now. And this is to get slightly more detail into the technical parts. Right, this is the crux of Sonic VPP, the syncd part, and libc VPP, the translation layer. So we maintain the config state of all the objects, right, required, do the translation into the VPP, send it on the binary API, which is essentially, right, running through a Unix socket on the same file system. And sorry, and we have this VPP data path, and the main is responsible for provisioning it, and workers are responsible for doing the data path. So that's about the control plane. API semantics. These are two diverse, right, APIs. One is CRUD based, SAI, right, and you have like read, write, update. Update is a new thing, by the way. API. And it has very standard objects, 100 objects on that, right? You do manipulation of database operations. And when it comes to VPP, it's exactly kind of opposite. So there are, per feature, there are some 20 to 30 APIs. So to configure interface, you need to set MTU separately, right? Things like that, address separately. Okay, so but here we get the whole object, MTU, state, IP address, everything comes in one go. So we need to maintain the state and initiate, right, a translation into the VPP, and then send a success back to the syncd. So the changes are non-trivial, and they are not simple either. So it requires more logic in doing the translation. This is to explain, right, the actual host path. I have skipped ARP. Okay, you can go back to the previous presentation. It's quite more elaborate in there. The host path, essentially, we assume that the MAC address resolution or the neighbor resolution happened for a specific IP address, and packets come in. If you just follow the circles with the red, one comes to the NIC. NIC accepts it because it's meant for its MAC address. Right, it does a translation. It basically maps from VF1 to the Ethernet 0. Okay, it has built-in logic. It's called Linux CP plugin. That's how the mapping is done. The Linux CP is smart enough to captures that packet, sends it on Ethernet 0, reaches the Linux TCP/IP stack, blah blah, and then reaches BGP through socket. BGP sends the data back. Packetization happens. Routing happens in the context of kernel. Comes over the Ethernet 0. And there is a mapping again from Ethernet 0 to the actual VF1 and gets out through the 7 numbered circle. That's the host path, and that's not going to get money for anybody, any of us. We need pass through. We need traffic to flow through, right? So far we just discussed about control packet. So this is how the pass-through happens, and this is how we achieve the performance. So the VPP, right, which is based on, if used, physical ports, it uses the DPDK to do the high-speed switching. You can do pinning of this on the CPU and achieve, greater performance. Okay, it requires some optimizations to be done, but once done, the whole fib is available, the neighbors are available, right? Adjacencies. So packet comes in from the host A, gets out, switched in the context of VPP, gets out on the port 1. So it never right reaches the other parts of Sonic. And that's the important part of VPP. Current development status, we are done with right getting the packet. Now we'll see like what's happening on the development side. We have code open sourced, and thank you Microsoft for helping us setting up the repository, configuring the CI pipeline for us. It's been very helpful. And then there are commands to generate images, make Sonic, like I mentioned, make Sonic VM. And we support all sorts of interfaces, virtual, nothing restricted. So you don't need a physical switch. You don't need a 100 gig switch to test something. So you can just use this and see how things work. And feature supported right now, they're all L3 based features. Interfaces, sub-interfaces, VRFs, no VLAN right now. And routes, IPv4, IPv6 routes we have tested. We have Sanity running for every build for that. We have ECMP. And the best part is we have ECL now, which is very important. You can do a very basic stateless firewall with ECL. Okay, and you can even do stateful also with some extensions, and it supports both IPv4 and v6. With ECL, you will also get counters. Getting counters, believe me, is the hardest part of implementing a feature. The data path works perfectly fine. If something goes wrong, first thing is we run the counters as developers or testers. It doesn't work. Okay, populating in Sonic is little tedious, but here we go. We have ECL counters also running. So please try all these and let us know how it really works. And Sonic CI enabled. Anybody wants to test it, go to the CI. The link is provided. Download the container image. Very simple. Run it on any Linux system you have. It's as simple as that. You don't need to build an image. Roadmap, phase 1, phase 2 completed. You can see we have covered a lot in the last 8 months when we presented the concept, and to this day, mostly L3 has been the driving force. In phase 3 and phase 4, the emphasis will be on getting VLAN, BGP, VPNs, lag, things like that. And phase 4 will be when the higher level applications will be supported, like IPsec and NAT. That's the roadmap. And this is a real use case, which is somebody deployed, can't name the right company. It's a very simple deployment. They have some L3 underlay. They want to run L3 overlay, create VPNs for various customers, blue, orange, green, blue, all these are customers, and they're just going over this. And at each instance, it's a Sonic VPP container which is running at 10 gig rate, 9.99 actually. It's not 10 gig. Metaphorically 10 gig. And there is another customer inside, outside Cisco, who are using it to validate API message handling and trying different topologies. I think trying some complex topologies, I think it will be a very good addition, because it's so simple to configure. Just write some scripts, instantiate container images, and you're done. You just need virtual interfaces. You don't need physical interfaces, connection, mapping them. This whole thing is taken care. And I think that's where we see the mountain. Thank you.
Hey, thanks a lot. Is there any question? Oh, multiple questions.
Gautam, can you?
Hi, Shishithar. Good presentation. A quick question. This is Saurabh.
Yeah. Hi, Saurabh.
So on the phase 4, you had MACsec and IPsec. Typically, we see these are very CPU agnostic, intensive applications. Have been any thought around, are you looking at it from a software implementation or looking to utilize it on the hardware side?
There are actually two aspects to it. If I use software, for instance, it's only, say, the requirement is 10, 20 kind of Gbps of IPsec. What we can do is we can use the AES NI, right, in an Intel or AMD processor, right? It will accelerate the encryption decryption part a lot. And if you use AES Galloy mode, AES GCM, so it will run even more faster because the hash also is calculated as part of it. That is when the requirements are lower. But if you have a very high one, then it's better to deploy a DPU, right? Again with Sonic, and you can use the same stack there to enable the DPU.
Got it. Thank you.
That's what we have planned.
Yeah, a very, very specific question. This ACL ACLs, are Mac to VLAN translations also supported at this point of time?
No Mac. Right now it's only L3 and above. So we do support
IPSLs basically.
Yes, IP4 ACLs, IP6. So up to TCP ports, TCP UDP ports, and of course protocols. Which
any plans to support Mac?
Yes, it will be in phase 3.
Okay. Okay.
Yeah.
Sure. Thank you.
Yeah.
Service.
Yeah.
Both it can be installed?
In case of a container, what happens is VPP runs as a very simple process. You'll see, if in a Sonic, supervisor will be the main manager of processes. You just listed supervisor status, you'll see VPP running there. In a VM, it will run inside a container. But essentially, it can run as a system process, inside container or as part of system D. But what we have chosen is a container process because the proximity of the file system where syncd is running is important.
So can you differentiate the use case deployments with container and directly, because when we propose solution to customers with VPP, right?
Right.
Because this is open Sonic VPP, it's open source.
Correct.
If we are proposing solution where customers are looking for open networking value proposition on so they will just tell their commercial requirement,
correct,
their business case. So we as techno-commercial guys, how do we size that requirement? Like, can you map the container through hypervisor and the container directly through the bare metal? Some use cases. Can you differentiate some use cases? Which segment we should position and target through container, through hypervisors, and which through directly bare metal? Yeah.
Okay, I'll take a dig at it because it's very subjective.
Just one case study comparison.
Right.
One example.
Say the container footprint, for memory footprint is very low, right? Right now, with only BGP being running, we haven't added other things of Sonic which are there in the VM image. Okay, if memory footprint is important and you have limited functionality required, you are just doing L3, like the case I mentioned in one of the one of the customers. So they are using container and all they are doing is L3 routing with BGP peering. Okay, and they have a requirement that it has to be executed with less resources. They given 4 CPUs and 8 GB of RAM. In fact, it can run with 2 GB, by the way. So in such cases, Sonic VPP is definitely container-based VPP will be a good option. The VM comes into picture because the VM has more functionality. As in, we club so many other things, SNMP, telemetry. Right now, telemetry, SNMP, things like that, TeamD, right? We haven't packaged it as part of the Sonic VPP container-based image. So if you want all these supporting functions, you have to go with the VM. There is no option right now.
That means that your container-based solution through hypervisors is suitable for large-scale hyperscalers,
yes,
or data centers.
Yes.
And the VM-based solution with legacy technology like SNMP, campus or co-located market segment can be targeted.
Exactly.
That is correct?
Yes, maybe enterprise or edge, right, where um, you're acting like a virtual gateway for so many, right, sessions.
Sure.
There you can use
Thanks. Yeah. So I was doing the feasibility study for Sonic VPP.
Okay.
Thanks for the valuable input.
Sure.
Yeah, I have a question on the data plane. If you could just go back to the foils, right, where we have the architecture.
Gautam.
Data plane and the control plane.
Which one?
Yeah, so the one before that.
This one?
Okay, but anyway, I can speak through. Yeah.
I think architecture is better. It covers everything.
Yeah, this is also fine. So, so it looks like now so the data plane your switching and routing is happening on the VPP, right?
Yeah.
So what is the scale right now you can support?
On a, say, in an Intel latest processor, right, with now they come with a lot of cores, 32 cores, 64 cores, you can reach up to 1 terabits per second. Vanilla routing.
No, I am talking about the depth of the route table.
I'm sorry?
The depth, how many routes?
Routes, we have tried on a very simple container image, 24,000 routes.
Oh, okay.
And it's a T1, I think I mentioned about the T1 topology. This requires, it basically configures around 100 peering, VGP peering sessions. Okay. And it has 24,000 routes the last time I checked.
Okay.
And it is capable of going further. We just need to keep increasing the memory on the VPP side.
So when you use it on 24K routes, so then so how many routing interfaces you also have ECMP running? Okay, I'm just trying to compare with the merchant silicon like.
We tried in this specific case 32 ports, and these are right. It's a VM image with NICs emulated. They are not real physical NICs, but the functionally it will be exactly the same.
Okay, so you'll have 32 virtual interfaces, but the actual physical interfaces on the NIC probably could be 1 or 2.
That's a possibility. You can run ECMP on 1 or 2.
Oh, okay, but you emulate as 32 virtual interfaces upwards. Is it like that?
No, I didn't get that question.
No, see, when I see the from the kernel, you are emulating the front panel ports as Linux ports, right?
Okay, they never reach the host, by the way. The pass-through traffic will be routed in the context of VPP and everything, right, provisioned in the VPP data plane. Only the host-bound packets.
That I understood, because you actually had a U-turn in the VPP itself, where that is where you are able to get the performance.
Exactly.
Because if it goes to host, then you are gone.
That's how the virtual switch is.
Yeah, but what I thought you said was that when you said 32 ports,
okay.
So suppose the NIC physical ports probably say maybe 2 or 4. So are you actually virtualizing the NIC ports?
No, we are not virtualizing. These ports, if you look at DPDK, right?
Yeah.
They run the PMD on that. Okay. Pole mode driver. Okay, and it directly writes to the PCI address space. It creates a ring, the physical ring for sending the packets in and out. So it does take care of receiving packets at high speed, sending it at very high speed. So there is no emulation done anywhere in the VPP.
Okay, because when you said 32 ports, I got confused.
Yeah.
So basically, if you have 4 ports NIC, then that 4 ports is what you get.
Yes, it will scale linearly, provided there is not many features you are running on the system. As you increase the number of features like firewall, things like that, right, ACL, it will go down because the packet has to traverse all these features and then eventually get out.
Yeah, because so that means you are actually placing it. So it could probably, if I imagine like this, it would come between the merchant silicon and the pure software.
We will still be limited by the number of cycles available in the CPU. It won't perform as good as a Cisco silicon or a Broadcom silicon.
Okay, but you can actually position this sometime in between where some customers they don't need the high performance scenario.
Virtual deployments,
yeah,
virtual
where you do the routing in the kernel, that is low. In that case, this will be like in between because you are not doing the soft routing in kernel, you push that down into VPP, you
Yes.
get the performance.
Yes, that is done by the Sonic. Kernel doesn't do anything.
Okay.
All the configuration comes through the Sonic SAI API message.
Okay, so that is where I think your solution fits between these two.
Yes.
Okay,
Yeah.
thanks.
Sure. That's it? Okay.
I think you have a question.
You were talking about simulating different silicons, right? So do we have any customization options? For example, you were mentioning Broadcom, Cisco. Like
Okay.
if I want to use it for Marvel use case, can I customize it to mimic?
No, it's not a simulation of any ASIC.
Okay.
That's a no starter actually. It's a data path, software data path. There is no emulation of any ASIC. Okay. For the ASIC emulation, I think you have to go with individual vendors, right? They call it behavioral model or something. So that's the only way. Here, it's all about getting a good data path performance, L2 or L3, and it's a Sonic control plane you have at your disposal for configuring the device, configuring your router or switch, right? And you can place it anywhere in the cloud. That's the real value add of Sonic VPP.
Okay, thank you.
Yeah.
Sashi, nice talk. So I sorry.
Okay.
So I followed what you said, right? The use case of it being something that we could use for developing NOS features. If I want to add features in NOS, this can be used, right?
Yeah.
But when you're adding a use case saying it can be used for SAI API handling testing.
Right.
I didn't really follow that part.
So if you're implementing any new SAI API, or you have a platform you bring in, right? So you can experiment with VPP first, whether see whether it is functioning, and are you sending the right attributes, right, till the sync D, and whether that actually results in data path being functional. But like I said, it's not going to give you that ASIC kind of compatibility.
Okay.
You really can't use it as doing a comparison between this ASIC, that ASIC.
Okay.
So that's
yeah.
not there.
Yeah. I think.
So if I gave the impression, I'm sorry about
no,
that.
No, that's fine. So just going about tangential to it, right? So typically it would so happen that even VPP doesn't support that new SAI API. A new SAI API comes in and I have to support it, right? So typically I would go ahead and support in my vendor SAI implementation.
Right.
But if it's something I want to also do in SAI VPP, how complex or easy it is?
Okay. So there are two things we need to consider. One is just check whether the VPP already supports it. In all likelihood, VPP may be supporting it. Okay. In that case, you need to just figure out what APIs to use and do the translation logic in SAI VPP. If it's not supported, you can raise the issue with VPP folks, right? And if they're willing, they can implement. But if you have an implementation, you can go ahead. It's open source.
Okay.
Okay, and you can implement, push it to this one and include it in the Sonic. Okay. So one more interesting thing we have done is, you can point any VPP, as in right now what we do, we point pre-built VPP binaries, okay, which are used in Sonic. And we download on the fly during the build and make it part of the Sonic image. So in your case, you point it to your VPP, right, and okay. You have a functional system.
Okay. Yeah. One small question. Yeah. How would I know what are the features currently supported in SAI VPP? Whatever it's in your fork, right?
It's mentioned. There is a to-do list in the Sonic platform VPP. Okay. So that mentions all the features which are supported, including the APIs which are supported.
APIs, okay. Very good. Thanks.
Not all are supported. Right?
Yeah,
still in development.
Yes.
Yeah.
Okay. Thanks.
Yeah. Okay. This one I'll start charging to Microsoft.
Yeah, thank you, Sashi. It was a very good presentation. So have we done any case study, like the comparison of throughput between Sonic VS and VPP?
Yeah, we did a lot of study before arriving on Sonic VPP.
Okay.
So the VS, if you look at it, right, the VS uses two interfaces. Okay, there is a something called vEth, or again, they're all NetDev interfaces, and these two interfaces packet, get copied from here to there, there to here, and there are a couple of threads which are running in syncd, right, which are responsible for treating them as raw interfaces, but doing sending packets, doing the RxTX for that, and it all happens through the kernel. So when you do this kind of thing, right, your performance will go 1/10, or depending on what you're running. Okay, in VPP you don't have any involvement of the kernel, like I said, right? It all is taken care by the VPP high-speed software, which relies on DPDK if DPDK supports that interface.
Okay, so we have any throughput comparison data available right now?
It's around 1/10, what we saw. Okay, and if it doesn't scale linearly, that's another problem, right? Okay. And there is a lot of data on the VPP. If you just visit the fdi.io, you will see that it supports 1 terabit right now, with sufficient number of resources, of course.
Yeah, thank you.
Yeah. Thank you. Thank you, Asha.
Yeah, thanks a lot for the wonderful session. I can feel the energy with the questions, to be honest. I also had few questions, but I think I'm going to ask him separately. I'll talk to you maybe at the lunchtime. I also wanted to discuss few things with you. We will continue with the session. I would like to welcome Anish and Uma from Mavenir Virtual Cell to talk about Sonic as a virtual cell site router for mobile networks. So it will be very interesting to see how are we doing in the mobile network area.
Hey, good morning, folks. So Uma and me are from Mavenir. We are into, Mavenir is basically into mobile network cloud infrastructure. So to give a picture on what that is, this is something like it's just a refresher of the mobile network that most of us have in picture. So what we see to the left side is the mobile tower network that we see on the roads. And on the base of that, we see a bunch of equipment. So Mavenir is a cloud-oriented company, so we are trying to move away from the customized hardware onto generic platform like the standard Blade servers. So almost all our equipments are based on the standard x86 server platform. So the equipment that we are keeping down is once again a Blade server that is a distribution unit, which is a 5G network component, and that basically gives a connectivity to the central unit, which is mostly located in one of the central offices of the service provider. To the right, there is a packet code which typically provides various services and internet connectivity and all those things. So the topic of interest for us is the central network, what we see as the mid-haul that is marked at the center, the one that spans from the DU to the central unit. That's the mid-haul, which is more of an introduction that came for the 5G, and it's sometimes used in the 4G networks also. So in that, to provide the initial connectivity, there is a cell site router, and the topic that we are going to talk about today is just the cell site router in this network. So what this cell site router is one that typically gets placed on the bottom of the mobile tower, and its role is more of a multiplexing device. It takes in one network connectivity and will provide connectivity to the multiple DU servers that are located on the base station center. Along with that, we can typically have other devices like the environment control device or monitoring device or surveillance cameras, and all those things can typically get attached to this cell site router. So right now, a typical cell site router is a standard switch, a 1 RU device that gets attached to the cell site router, which is typically an add-on cost to the overall deployment. So our effort in Mavenir was to avoid this device so that this device can also be incorporated onto the blade server that is there and can give connectivity to the remote and to the local DU servers. Yeah. So Uma will talk further about our disaggregation part.
Yeah, so before I actually talk about the solution, our solution for VCSR, just some introduction into disaggregation in general. So traditionally, we all know control plane is a network operating system, and it has routing and signaling, and data plane implements accelerated forwarding and is usually on the custom hardware. And all this is provided by an OEM. So this solution is kind of rigid, and so with the advent of SDN and general purpose servers, as in commercial off-the-shelf servers, came in these open and standard based, and with that we have separation of the control plane and data plane. So this is actually in crux the disaggregation, and these principles are what is used in our solution, the virtual cell site router. So as in the first slide, Anish explained where the VCSR or a CSR would be typically implemented, right? So a physical cell site router, I mean, it routes traffic from DU to the CU, which is, the CU is typically located in a edge data center, and it does this by applying all these costs and other features. So cost is very, very critical for us. Security as well. So our solution for VCSR is completely software based, and it runs on COTS server, and it is CNF, so Cloud Native Network Function, which I mean, we provide networking microservices which can be packaged into a Docker container. So this makes it pretty easily deployable. And it's elastic because we can configure the number of cores, we can configure how much memory we actually need. So we can even plug in and plug out features. So about 2 years back, when I mean, this is some history. So when we were actually trying to find the best control plane and the data plane for our needs, for obvious reasons, I think we've already spoken about it quite a lot. For Sonic is our NOS, I mean control plane. So it being feature rich with for all the routing protocols, we have FRR, and we can have, I mean, since it's Redis driven, so we can add features pretty easily, and there's very good community support. We are all part of it. And VPP was our data plane. It is open source, and it is very high performance packet processing software. So it uses vector packet processing and is based on DPDK, which actually provides fast I/O. So there are numerous forwarding features and plug-in support, as in you can just plug in features like adding node into a node graph. So debugging is pretty good. You have tracing and debugging with a lot of CLIs. So we chose VPP. So just just wanted to mention about the DCSG group, disaggregated cell site router group that was active till some time back. I think many of the companies here would have been part of it. Our aim was to solve the problems of virtual cell site router, which is pretty different from the rest of the routers. So apart from thanking many companies there, also thank Dell for their support. So here is where VCSR fits in. It is a two container solution wherein the control plane runs on one container and the entire data plane runs on another. So this is on a blade server, which is usually an x86 hardware. And it is CNF, as we already spoke about, so it can be orchestrated using Kubernetes. So this is so VCSR provides the connectivity to rest of the softwares or the instances, Docker instances running in the server. So be it DU software and other softwares running on a typical cell site router. So to note that here in a cell site router, there's a lot of memory and CPU constraints. So what a VCSR will probably get just 2 physical cores and about 2 GB in the range of 2 GB as memory. So we will have to have a solution to make it work in such a constraint. Further, before I talk about the what changes we made in Sonic to accommodate this, so here is a sneak peek into our architecture. So we have virtual interfaces. So virtual interfaces, as in we need to have high speed, those that use shared memory, those kind of interfaces that actually talk to DU, because they are co-located with the DU, as I mentioned. So apart from that, the interfaces are all, in our case, to be DPDK enabled for fast forwarding, for forwarding as such. So between the to actually for our solution, for the VPP to talk to Sonic, we have 2 ways. One is netlink through the kernel. So that is used for routing and interface states and so on. And we use SAI, which we send, the messaging is over a TCP protobuf. And this is used for the newer protocols and features, for example, COS, ACL, and so on. So for the punt path, we enabled through TUNTAP interfaces, and the LCP plugin in VPP provides that solution. So this is an indicative message. This is not the exact picture of all the processes that we exactly use. But what I wanted to convey here is that we use a single Docker solution, wherein the manager Ds, the sync Ds, the orc agent, everything runs as usual, but on a single Docker. Apart from this, we made quite a lot of changes in CLI and REST APIs, and there's Anish will be talking further on it subsequently. And for the communication, we spoke about how they talk to the VPP. So it's through SAI, and we had to develop our SAI server to handle these messages, because we need to program the VPP with binary APIs. So Anish will talk about traffic profile.
So this is about how the traffic needs to be handled on a CSR kind of a requirement. So the real revenue generating traffic is the first one, the user plane traffic. This is typically a GTP, which is a application layer protocol encapsulated or UDP IP. All the user traffic, be it the voice, video, or the data traffic, everything gets conveyed over the user plane traffic. Control plane is entirely over SCTP, and the management traffic is native IP traffic, so it can be anything in IP. We have to support V4, V6, and mid-haul is typically over a public network quite often. Sometimes it can be a private link also. The VLAN requirements will come in the subsequent slide, and the other services also there. So this is typically one of the when we are as we deal with Open RAN compliant solution, we have to. This is more the requirements in this are coming more from the O-RAN side. So primarily with more of the 5G network, it's not about connectivity. We have varied services that we have to provide to the varied customers. So the first one is the massive machine type communication, which is like IoT devices and the fleet management kind of traffic, which is quite massive in nature, and that forms one of the traffic streams, the MMTC. Second one is the most commonly used mobile use case, that is the enhanced mobile broadband. So the in network connectivity that we get there, which includes the voice calls also. And the more compelling requirement here is the URLLC, which is the ultra reliable low latency communications, which are typically self-driven cars and robotics and medical purposes, where the reliability and latencies are pretty crucial and forms a very important part in the QoS. So when it comes to the mid-haul management of all this, as you can figure out, the traffic is flying between the same pair of nodes. They are typically marked by a VLAN markings within them. So the O-RAN standard suggests typically a VLAN marking, which is generally accepted as among the vendors, and it can also be a DSCP marking. So this brings in the real requirement for quality of service related services on the mid-haul management and on the when we are dealing with a cell site router. Yeah, this is just a summary of what we discussed last. So the QoS takes an immense amount of priority when we are dealing with it, primarily because the mid-haul is quite often a constrained link. So for managing the traffic in all of this, these are the typical tools we provide to the customers. So it first starts with a generic classification that we support, and this classification is then used for varied services like QoS, ACL, and the policy-based routing. Then the QoS, and for this we do support the 5-tuple based packet classification and class of service, the 802.1p VLAN priority markings, and DSCP, and the VLANs also. Then the regular things that we are quite often familiar with, the WRF routing, and we do support integrated routing and bridge IRBs and sub-interfaces. Sub-interfaces like the VLAN sub-interfaces. So PBR is a source-based routing that we do support, because quite often the requirements in these cell sites really require us to pick the traffic and give different treatment, not just based on the destination that they are flying to. So that's why the PBR really comes into play for our requirements. So this is just a QoS model, and QoS is typically really relevant for a CSR requirement, because the mid-haul link is quite often constrained, and we need provide very high quality of service for certain traffic requirements that we have. So we support both ingress on the ingress and the egress pipelines. All this is done with the FDIO VPP. So it starts with the packet classification based on one of the priority bits, or with the 5-tuple, which is the source or destination address or the transport ports, and by the DSCP bits in the IP packet. So after the packet classification, it can go for a remarking based on the policies being supplied, and then it can be policed also, just to make sure that the traffic that we admit in is really requiring something that can be serviced by the egress links that are being provided there. And once again on the egress, we do support a marking, or it can be called as a remarking. And then it can go through a shaper, and then the scheduling algorithms like weighted deficit round robin or a priority queue. Now this entire pipeline is something that we support with the VPP, which is from the FDA. Onto the management plane, we have mostly inherited the same management plane like as Vanilla Sonic. So it's a Yang-based model that we have, and so we are using ClickCLI. We'll come to that in subsequent slide. So it's both Yang-generated ones are all used. In addition to that, we support for the programmability sake, we support REST API, and we manage alarms over the GNMI. Yeah, so going forward, these are some of the major management plane enhancements that we are looking for, and with the like-minded ones, we would like to collaborate on in co-developing this. So right now the ClickCLI that we are seeing is has serious limitations because because when it comes to managing the config hierarchies and with the different modes and those things, it's very difficult to handle with that. So support for list of lists and all those things needs to be really needs support from us for the Sonic platforms. A role-based access and a atomic model, like a config is not just one statement; it's a bunch of statements put together. So a commit model and better support for the operational models with the and one of the real difficulties that we have always faced is about when we are going with the Yang models has been the figuring out the highly cryptic messages that we get from the Yang failures, and which are typically non-intuitive in nature. Yeah. Onto the major features that we support.
Yeah, so to say we've solved for the following problems. So on the data plane, we have COS and PBR contributing to our overall solution for slicing. We have this virtual interfaces like MEMIF and IRB for our VLAN SVI solution. And control plane for the need of protocols, numerous protocols, we use FRR and IKE as such from the IPsec suite, and SAI support for VPP. For management plane, we have Yang-based solution models and CLIs. So CLIs we try to generate from these Yang models itself for consistency across. And programmability, we have REST APIs and GNMI. Services, ZTP, NTP, DHCP and DHCP relay, and alarms along with counter statistics and so on. Actually, that helps in our analytics platform in the company as well. So the security, we have IPsec right now, ACL and secure REST APIs through Java web-based tokens. So we still need to add features on this. So just a USP of VCSR here. So with the reduced devices on cell site as such, we have low power. I mean, it reduces the power cabling. So this will result in the the cost going down. So total cost of ownership per MB goes down. So with reduced rack space, it gives other revenue opportunities. Could use it for other things. And programmability, I think we've already spoken about. So we need programmability through REST APIs, GNMI, and so on. So the solution needs to be pretty apt for a 5G, and it is different in the way that first of all, CSR needs to be co-located with the DU. So, and interfaces, you need to support virtual interfaces, and you need to keep in mind the slicing as an end solution. And so with automation and all this being orchestration capable, we contribute to the overall CI/CD. And security we've already spoken about. It's pretty elastic with respect to the features. And hardware as such, I already mentioned about. We can configure the number of cores we need, the memory we need. So in that, that makes it flexible and scalable with throughput and performance in general. So on to Anish for.
Yep. So these are the few areas that we are looking forward in our future releases, and where we could typically collaborate with the rest of the community. Primarily for the mid-haul being a quite often being a pure packet network. There are requirements coming up for segment routing and SRv6, and when we are doing this, it's best done along with the PSEP. So this is one segment of requirement that we are looking forward for. And then for the reliability and redundancy purpose, we are looking forward for BFD redundancy, path protection, and path protection. Performance monitoring and analytics are really achieving importance, because 5G network is highly getting adapted to the modern AI ML techniques, and we really need to export our analytics and perform PM data. So that is one major area that we will be concentrating going forward. The throughput is going up exponentially for on the mid-haul. So over the time, we may have to consider going in switching into the DPUs, and then of course the management improvements that we talked about before. So these are primarily the areas that we are looking forward, and we would really like to work with the rest of the community. This is basically our areas of interest. These are some of the references, the common references as we use DPDK, FDIO, and FRR. We leverage them entirely. Yeah, so thanks a lot to Microsoft and Linux community for organizing such a good event. And a very big thanks to the Sony community. So it's not an easy thing to do. We started almost 1.5 years, 2 years back, and we could come up with a product that is almost deployable on a 5G core network. And we are looking forward for reshaping this entire solution onto the other deployment areas in 5G network other than the cell site router. So for coming up with a solution in such a short time frame and with a pretty small headcount, it had only been possible with the fairly good Sonic distribution and the community support, and we really would like to thank each and every person and company who have really put their resources into this. Thanks a lot.
So thanks for sharing the insight on this CSR with Sonic. So this is one of a unique solution, Sonic with virtual cell site solution. Now in a virtual cell site solution, you have mid-haul and front-haul facing switches in micro DCs, data centers in the cell site. So
no, right now we are not working with mid-haul, or we are only working with the mid-haul. Front-haul is front-haul doesn't really come into this CSR perspective.
So mid-haul basically has an uplink towards the radio network. So CPRI to Ethernet conversion, does virtual CSR Sonic has capabilities to handle? Because in that scenario, it would be a comprehensive solution from the mid-haul translating to backhaul for the your SGSN or SGW of the world to the core side. So is it able to couple the access side, the radio side of network, and the backhaul? So if you see this from mid-haul, you have the aggregation router, cell site router. This overall comprehensive solution, can the CSR Sonic, can it offer the control from the mid hall for CIPRI to Ethernet conversion, and when the traffic get processed and when it goes to the backhaul, right? So it again adds certain encapsulation to the for the core. It can be GTPU or whatever you talked about. So that was question number one. Like CIPRI to Ethernet, can it handle?
Let me answer that.
Yeah.
Let's go back. So the CIPRI to the conversion that happens in two spaces here. With the ORAN standard, it is the 7.2 split. Let's not get too much into that because that is not the core area of topic here. So the 5 split is something that happens between the DU and the RRU. That is the front door, and that is not really the domain of CSR. So CSR here is a pure packet forwarding router or a switch. So now this CSR device, at least in our solution, is co-located with on a base server that is also hosting the software, that is the DU software, which typically does the conversion of eCIPRI into the packet.
So the data unit is still taking care of the translation from CIPRI to Ethernet, and then it is offloading the services to your CSR, Sonic CSR.
The DU does some part of the marking of the services because the network slices that DU is more aware of. CSR only knows the markings that are coming in with it. So the CSR is completely unaware of what CIPRI is or eCIPRI is.
Yeah, so the question was based on the use case deployment in production, because the real cost of this network enhances when you have the data units and control units, which are hardware based, and it has to be because CIPRI to Ethernet conversion is there, high-end signaling is needed. So what is the value in production network the CSR is bringing, because it's not processing that intense the policing or the QCI part of the radio network translating CIPRI to Ethernet, right? It is whatever that data unit is doing, now it comes to the VCSR. From the Sonic VSR perspective, which all processing it is doing, what is the value of those use cases? Because today we have the cell site router, what is the differentiating value in production network with the VSR? Because you got it right for the services. Yeah.
So it's the question is the problem is not what you are saying about. So there are multiple DUs that are required here because the number of RRUs connected to a DU is limited. So what typically happens is that, and also the DUs may not be co-located; they may be in different sites also. So the cell site router is a termination device for the mid-haul link. So this termination device is typically a dedicated device as of now. So now we are getting rid of that dedicated device which takes rack space and power and management and everything, and we are just making it a Kubernetes pod, and we are deploying it along with the DU software. So we are just avoiding one device altogether in the network, and we are just making that an elastic, easily deployable device there.
Services on the fly, but the DU will continue to do the job of signaling translation. But rest all performance it will take care of.
Yeah.
Whatever the actual cell site router was doing. That is the real value. Yeah.
Yeah. Instead of a dedicated device, we are just getting rid of a dedicated device and hosting it in the practically in the cloud.
Container. Got it. The second use case question was, you are planning to support SRv6 on cell site data centers hosting such DU CU solution along with this CSR, which is very good. So how will you achieve the multi-tenancy and multi-segmentation use case which VXLAN, because VXLAN would be replaced with SRv6 in the data center. So what is the use case production value of SRv6 in this cell site deployment? I'm not aware of that, so I'm asking, because production value.
Okay, this is not a right now we don't see. So when we are doing this cell site gateway, quite often what we see immediately after a cell site gateway is another gateway or a PE router that comes from the mid-haul vendor who provides it. So one right now it is a blunt connection that goes there. The service encap, everything becomes difficult. Service marking and everything becomes difficult. So once we are introducing a SRv6 or a SR in that segment, we could typically mark the service with the tag and with the SID we are injecting there, and so this SID can also be programmed for the different type of services or the path it should take. So that kind of intelligence can now be integrated here. So I'm not well versed in the VXLAN side. So this is where these things are.
Fair enough. So the plan is to support SRv6 towards the mid-haul, right? Between the cell side and the aggregator.
On the mid-haul. Yeah.
That should be fine. Yeah. VXLAN scalability.
And also on a long term, the GTP is intended to be replaced by another protocol. So one possible solution that has seen some deployment also is SRv6 instead of GTP.
Yeah, but the point is the QCI value for radio subscribers which get translated to Ethernet, right? How will it translate in SRv6? In my knowledge, there is no standard yet for cost translation in a SRv6 tunnel. Yeah, if it's there, you can appraise.
So in the GTP, when we are in GTP, the marking is done with the TEID.
TID, yes.
Yeah. So there are some draft right now being in progress, which typically talks about how this TEID can be translated to the SID values.
I think the VXLAN would continue to play a role within the micro DC, where you have the mid-haul switches, the entering switches for CIFRI to Ethernet, and when they talk to servers hosting the 5G application. So there the VXLAN segmentation value will continue to propel.
Right now we haven't seen a VXLAN deployment there.
Got it.
Right at the cell side router. It is plain IP and Ethernet data transmission. That
got it. Thanks for the insight.
Yeah, Oma, Anish, good presentation. A couple of questions. First one, the FDIO container. Have you thought about how you're going to orchestrate or do container management of it across switch reboots, upgrades? How do we preserve the data?
Yeah, right now, our entire the DU single device, it's based on a Kubernetes orchestrated thing. So on that, we are just adding the 2 extra containers. That is the one is a FDIO container and another one is a Sonic container. So they get deployed that way. Did I answer your question?
How do we preserve these containers? Like if you have to go for a switch reboot or upgrade or put in a new NOS image, how do we preserve that?
Okay, the config and the logs are being preserved in a separate volume that gets supplied to when the Kubernetes pod bring up happens.
Got it. Okay. So, and the other question is, right? These are remote locations and difficult to manage, right? From a lifecycle perspective.
Yes.
Have you thought about like how is this going to be orchestrated across several cell sites? And for 5G, it's going to be massive, right? There's so many towers going to be there. Any thought around lifecycle management there?
Yeah, the edge core that you had in your slide. So one such, there's a company that does this, right? So they do the orchestration across. Okay. So we are trying to get their help to do that.
Beyond edge?
Beyond edge.
Okay. Got it. Right. Thank you.
I have one question here.
Two very simple questions. One is, what is the hardware you use for this kind of solution? And secondly, do you have working deployment anywhere in the world for this vCSR?
The hardware is the standard x86 server running Xenon or EPOAC processors. The standard blade servers that we have.
Okay.
Right now we are in the testing labs and we have signed up for customers and it will be deployed sometime soon.
Any further information on this product where we can get it?
You can talk to us.
The presentation has a link to our press release. the presentation has a link to the press release. Mavenir site has it. Please feel free to reach out to us. We can give further information.
Okay.
Hello. Hi.
I have one question here.
Yeah.
Here. Yeah, it's very nice to see that you have actually extended Sonic, which was there in data center and mainly enterprise side, to CSR side. It's really nice to see that. So I have a couple of questions. If you go back to the feature set, right, which is supported. So did you actually find any major feature deltas or gaps in community Sonic, which would be required to support in the CSR environment for the CSR? Are you planning to contribute any features back to Sonic? Or first, did you see any feature delta?
There were a few things like the FDIO integration, the VPP integration, the SAI part. We tried to so Cisco took the lead. So we are working with Cisco, trying to work with Cisco now to figure out how we can contribute. The other thing is we did contribute on the static routing and few other things like when it comes to the packet class, the QoS ACL part. There were already some work in the Sonic community, but it did not typically meet our requirements. So we had to do
So ACL you might have, okay, ACL you still had to do some enhancements on the ACL side, right?
Yeah, so what we actually did is that we used a common classifier for ACL, QoS and PBR, because they all required classification, and so we had a kind of a disaggregate model where the classifier is one and then it gets translated into different things based on usage. So that model was not there, that kind of management model was not there in Sonic, so we did it. We have to see, because already some models are there and we don't know how to make them backward compatible with the existing one. So we can talk and figure out if something can
Okay, so ACL is one area you had to actually have your own model kind of thing to fit into your use case. Okay.
Yeah.
So what about the basic .1p and the mapping which you needed for cell site router for the priority traffic class mapping? All those things you are used to what is there in Sonic or do you need to make any changes in the community Sonic?
Yeah, those things were part of our classifiers that we added there.
So that I think you took it as is from the community Sonic.
No, that entire classifier model, we could not really find a working one that is really matching for us, so we did ours.
Oh, okay. So that you had to use your own model, okay. Yeah. So the other question I had was now the Sonic, the footprint, the flash and the RAM footprint, right? When you actually move into the cell site router space, you don't have that much luxury there. So what are the challenges you faced, or do you actually have to make major modifications to fit into a smaller flash and a RAM footprint?
Yeah, one thing we did is that.
Okay. So we had to prune the number of modules that were there. We don't need all of them. So we just took the only those that are actually needed. And secondly, we also, I think I spoke about this single Docker.
Oh, okay. So you then got rid of all other Dockers in Sonic and you brought it, trimmed it down.
Yeah, the debs and wheels packages that are there, we packaged it into single Docker.
Okay, that is how you are able to fit it into this.
So yeah,
footprint.
with 2 physical cores. So we just have 0.5, that is one virtual core for the Sonic, and we have 1.5 for the.
Okay. I think you have done a lot of good job there to actually bring it down to that footprint. Nice work. Thank you.
Thank you.
Hello. I have one question. Here. Okay, for the cell site router, timing is one of the key features. So how this is being done, the current as well. And the second question is, what kind of performance we have seen compared to the real cell site router when we replace that virtual one?
The PTP is what your question was about.
Yeah, timing.
PTP is not part of the cell site router because a physical cell site router is typically supported there. For the PTP, we could typically spawn another Docker in the same site to start the PTP. When there is a PTP requirement, there can be another Docker that typically gets popped up for the PTP requirement. That's how the PTP is called. Right now, the given requirement was about 10 Gbps of throughput, and we were able to achieve that with two physical cores.
Right.
Yeah.
So question here. So so this is you are orchestrating two pods. Basically, Sonic is a pod in the Kubernetes cluster, and FDI is another pod, right?
Yeah.
And it is one-to-one, or it is like the Sonic manages multiple VPP.
One-to-one.
One-to-one. So when it is one-to-one, why do you need two images separately? I mean, FDI was a one, because the whole purpose of Sonic is to program the FDI, the VPP data plane, isn't it? So is there any reason that you made it two pieces?
This is for the disaggregation. We just so future, if you need more control planes, you could just scale the control plane, or if you need more processing on the VPP, we'll just scale VPP alone. I mean the data planes.
So you want to do with one control plane, you can monitor multiple data planes. That's the idea.
Yes.
So then the next question is, what is the communication channel between the Sonic and the VPP, the data plane and control plane? Is it a gRPC?
Protobuf, TCP protobuf.
Okay, you set up the gRPC connection and send.
Right, we send the messages.
Okay, then punt the packets from VPP to Sonic.
That is through TUNTAP. We have an LCP plugin,
Okay.
so that would actually send the traffic from.
Okay, and then the follow-up next question is, when you are running the VPP in the Kubernetes cluster, it gets into your Kubernetes cluster internet network, whether it's a Calico or something else, right? Now, how do you hook that into your physical NICs? Is it basically, how do you make that? The moment you come out of that network, this becomes host routing, right? So how does your packet enters into, basically, how do you bridge that gap? Basically, you spin the VPP as out of the Kubernetes network. How do you really pack that into Kubernetes network? How do your real host interfaces hooks into the Kubernetes network?
I don't know. We don't know too much about the Kubernetes part because that is the orchestration part.
Okay.
But I'm 90% sure about what I'm saying, that we are not typically using the Kubernetes networking.
Mm-hmm.
So to get into the very specific, we are giving the PCI address mappings when the devices are starting.
Okay. Thank you.
So I don't know exactly how the Kubernetes networking works.
Okay. Thanks.
Yeah, one last question on my side. Okay. So from the manageability aspect, you mentioned about the YANG models, right?
Yeah.
So Sonic has got this Redis-based YANG modeling, which we call as a Sonic YANG,
Yeah.
and then there is a open config based YANGs, right?
Yeah.
So what exactly you use? Which YANG model you use for your management?
Right now we have used the Sonic models.
Sonic model. Okay, I see.
So thank you all.
Hey, thanks a lot. Great presentation and great questions. So we have one more presentation from Pulsey Network, but I would like to ask if you guys are hungry, then we can take a break for lunch and then we can continue with the session. If you're okay to continue with one more session, then we'll go ahead with that and then we'll take a break. So we're talking about it, then we thought that it's better to ask you guys what you guys want. Okay, so please raise your hand who all want to take a break and let's go and eat something. Okay, and how many people who are ready to continue with one more session? Okay, decided. Yeah. Thanks a lot, guys. The energy is high. Amazing.
I can put it here.
Yeah.
Okay. So slide this. Which one?
This is
This is.
this is a laser.
This is.
Laser.
Oh, okay. Okay.
Hey, so the next presentation is from Krishnamurthy and Gaurav from Palsy Network, and the topic is Sonic Beyond Data Center. Thanks a lot, guys. Handing over to you.
Yeah, thanks, Sashi. So you guys are able to hear me, right? Yeah. Okay, so myself, Krishnamurthy Maya from Palsy Networks, handling the technical marketing part. So I'll be co-presenting the session along with Gaurav Sharma, who is from the PLM team of EdgeCo Network. So we have our R&D team who are primarily involved in Sonic-related activities, POCs and research-related work. Sandeep and Shiv Shankar also along with us. So yeah, maybe let's just get started, right? So the topic that we have chosen is Sonic Beyond the Data Center. So all these while whenever we hear the word Sonic, it in some way or the other gets associated with the data center. So what we would like to touch upon is we want to talk about a couple of use cases that we have worked on, and primarily we feel that those are the ones which are also getting tractions in the market. So yeah, this is the overall agenda. So we'll do a just quick round trip about what Sonic. I'm not going to touch about what is Sonic, but it'll be a bit about why Sonic and Sonic market traction and two use cases, particularly disaggregated packet broker and how exactly were we able to fit in Sonic to a packet optical deployment. So that is the other use case that we are going to talk about. Yeah, so yeah, I'm just going to skip this maybe for the benefit of time, but you know the kind of benefits when it comes to steering. Is it with the microphone or something? Use this. Hello, it's fine. But okay, sure. Yeah. So the kind of benefits from going away from the vendor lock-in and the flexibility and customization that it gives the customer in implementing new solutions and thereby enabling faster time to market. Right. These are few of the major things. Definitely why you want to go ahead with Sonic. And I think this is one of the repetitive slide I saw in one of the previous presentation also. So one major thing that we want to highlight is we took up something which was very recent also, which was talking about $5 billion probability for 2026 when it comes to data center switching. Yeah, so this is one of the very interesting slide that I took from Dave Maltz from Microsoft. So if you see the kind of features, variety of features, and the volume of features that are getting added to Sonic year on year, right? So this was presented by Dave sometime last year. So now if you see the top arrow there or the top row there, right? So it's even though the concept and the evangelization started purely targeting the data center networks, it's not purely, or it's not only meant for data networks rather. So whether it comes to powering the bare metal or powering any sort of, AI, ML based application generation, or powering enterprises, or even for powering edge, right? This is where definitely we can, use Sonic as well. Okay, so now coming to the main topic, right? So when we say our topic was Sonic beyond the data center. So one of the first use case that we would like to talk about is the disaggregated packet broker, or what we call as a network packet broker. So now network packet broker is a software solution designed to optimize the network visibility and manage the network traffic within an enterprise or a data center deployment. So what does the solution actually do? So the solution makes the typical network security, monitoring, and performance analysis tools get access to right set of data at the right time. So what we are seeing here is, So what we are seeing here is these network packet brokers, or the software solutions, right? They act as intermediary between the actual data centers and the network analytics or the security framework, wherein they intelligently filter the traffic, aggregate the traffic, and forward it on to the relevant tools. So now, what are the key functions that this packet broker is going to provide now? So one example is traffic aggregation. Now let's take a case. It won't be feasible for us every time to take a network monitoring tool and connect it to the actual box, right? So when we have network packet broker in between, it takes care of the job of collecting the data from all the networks or switches, aggregates it, and then sends it onto the monitoring tool. So thereby the redundant need for connecting multiple links directly from the boxes onto the monitoring tool, right? That gets avoided. And there's also intelligence related to packet filtering. So we can, with the packet broker software solution, we can actually put filters in the hardware to filter the traffic based on, let's say, source IP, destination IP, TCP, UDP ports, and some application specific information, right? So what are we going to achieve? The amount of volume of data that gets passed on to the monitoring tool, right? That gets controlled, and it gives the end user perfect knob, what has to be passed on to the monitoring tool and what not. And along with that, the load balancing also. So let's take a case or instance of multiple network monitoring tools sitting, right? Now you can control the amount of data that actually goes to each of the monitoring tools. So by simple TMD or the lag framework sitting in the software there, you actually control how much amount of data goes to each of the network monitoring tools. So along with that, we have few of the other capabilities also, such as packet deduplication, packet truncation, etc., added onto these tools. So now, yeah, so this is the overall thing. And when it comes to end users, right, it directly affects them or serves them the purpose of, let's say, something in the area of forensics, something in the area of network security. And also in the area of, let's say, network performance management, as well as application performance management, right? Consider the case where you want to measure the jitter or the latency associated with the network. So for all these set of things, this network packet broker can be used as an input. Now, what we have done is we have developed a software solution on top of Broadcom XGS boxes by EdgeCore vendor with Sonic as the base NOS. So that is one of the first use case that we wanted to mention about. So yeah, so the second most important use case that we wanted to touch upon was we use Sonic as a NOS for the packet optical deployment. So this NOS software, right, this runs on top of EdgeCore Cassini boxes. Now, I think most of you are aware, Cassini by EdgeCore network is one of the industry's first modular packet transponder. So basically, we developed a NOS which runs on Cassini boxes that serves the data center interconnect and as well as the long haul use cases. So what exactly this box does is, this box, right, this combines the benefits of packet switching world and the network world. So the work, if I have to, I think Gaurav is going to cover the specification of the box in detail, but to cover it in overall, right? The typical packet optical DWDM box, right? It has 100 gig packet switching interface and 100 and 200 gig coherent optical interfaces. So the idea behind this was this box, right? This box is a purpose-built box to allow the network operators to extend and migrate their existing, metro and long haul DWDM deployments to add new 200 gig capabilities to serve these two use cases, which are nothing but data center use case and metro backhaul use case. Okay, so now this is one of the slides that I've taken from the other famous open source community, which is called Telecom Infra Project. Now, if you see, there are multiple other project groups which are mentioned here. Now, the point that we were trying to highlight was this OOPNOS, or Open Optical Packet Transport Network Operating System. So the overall idea is, so the PALC was owning the co-chair position in this group in the Telecom Infra Project community, and that is where our initial trials or exercises of trying to fit in Sonic as a possible piece in the overall puzzle for developing a NOS for the packet optical deployment, right? That was started. Yeah, maybe I'll just let Gaurav handle.
Yeah, thanks, Krishnamurthy, for talking about the Cassidy product. Yeah, good afternoon, everyone. My name is Gaurav Sharma. I'm part of HCO Networks. I'm part of product line management team. So let's start talking about the Cassini product. So first of all, this is the hardware. It's a 1.5 IU, and it's a modular one. So here we are talking about the Sonic use case other than the L2 and L3. Okay. So what we targeting here, we are going to support OTN application where this product will be doing the L1 function. Okay. So if you see today's deployment, if we talk about the mobile backhaul or the telcos, they would need to aggregate the bandwidth over the OTN wavelength. Okay. So this product can't handle, because routers and switches are working on the gray wavelength. So you need to have a product which can support like conversion from fixed wavelength to the colored one. Okay, so that's we call it the DWDM network layer. We have to put it down between the two endpoints. So here this Cassini would go into this part. Okay, would be taking, we would be connecting like switches or the router on these ports. These are 100 gig QSFP28 ports. Okay, and then using these CFP2 slots, okay, which has got the DSP circuit, it can convert analog to digital on the C-band wavelength. So it gives you, one slot can give you like 100 and 200 kind of capacity based on QPSK and QAM kind of modulation. So this product can able to switch 1.6 tera. The interesting part is that we are using the Broadcom silicon here. So this product is capable of doing other than L1, but we want to demonstrate here the Sonic use case with the L1 functionality. Okay, so this product is put down here between the endpoints. It's taking the gray wavelength with the router and switch at the client side, and then converting to the C-band kind of wavelength. Okay, so it can work in the point-to-point kind of configuration, and we have also demonstrated this product with some of the customer using the switching. So if one of the link get down or there is any failure, so traffic can move to the second CFP2. And interesting part is that we have recently started supporting bidirectional optics also. So you don't need to have a two fiber. You can actually do the functionality of the CFP with only single fiber. Okay. So this is all about the hardware. If I talk about the CFP2 line card, so this is the PIU card which goes here. Okay, and on top of it, we support CFP2 with different our partners. It's a Lumentum, Fujitsu, and others. And so the partner list is keep on growing based on the use case. And if you compare the traditional, the DWDM OTN kind of transponder and our solution, you would find it would be cost effective. At the same time, because Sonic is a very stable platform, we are seeing there a lot of use case being served. So because of our partner like Palsy, they have developed the capability to do the L1 cross connect and other functionality. So it's give you, photonics kind of integration, okay? With the Sonic, it's a pluggable. So it's based on the pay-as-you-grow model. So it supports the 8 slots. So on day 1, you can go with 1, then you can increase based on the requirement. And it's quite flexible to, do the configuration. And in terms, it supports the 2 type of modulation, QPSK and QM. And the architecture is programmable. It's based on the open source. And second, the interoperability part is quite easy because we work with, different kind of demos and the POC, where we also interop with the traditional OEM player. Yep. Can you move to the next?
Okay, so basically, this is the overall NOS architecture actually. So as Gaurav pointed out, the box, whatever you had seen, right, that had the capabilities of packet switching as well as the insertion of coherent optical interfaces. Now, if you see the overall software architecture, right, so we have a unified management layer with it exposes the common APIs for, CLI, SNMP, NetConf towards the northbound. And so this is where the fitment of Sonic as a case for non-data center use case has come, right? So this Ethernet ASIC controller is running basically based on something called as microsonic. So microsonic is nothing but the regular Sonic, but you just cut down or don't run, let's say, a set of Dockers which are not needed for this particular requirement. So this Ethernet ASIC controller runs based on microsonic and programs the regular vendor SDK, so which is Tomahawk Plus in this case via the SAI. Now, there's something called as a transponder controller. That is where the programmability of the optical interfaces come in. So the way we have SAI for a regular chipset or a vendor SDK in this world, right? The equivalent of that is transponder abstraction interface, which comes to the optical world. So, and the box, like he mentioned, has the capability of, getting connected with the both at once. So for TIE also, we have a corresponding abstraction interfaces. There are multiple vendors such as Lumentum, Acacia, Regale, Philips,
Fujitsu.
and Fujitsu, yeah, people like that who provide that pluggable CFPT modules. And the entire OS, right? This is based on the Open Network Linux, and we use the ONLP, version 2 for programming the peripherals of the device. Yeah, so these two were primarily the kind of use cases that we wanted to cover, which were, so always we talk about data center when it comes to Sonic. So these were the 2 real world use cases where we have already developed software and things are in some kind of, POC or the pre-trial stage. Yeah, so I'll just take 2 to 3 more minutes in covering. Yeah, so at least from as a mid-sized startup company, right? From the multiple vendor interactions that we are doing, these are few of the challenges when it comes to Sonic adoption, right? So no matter, we see there is a big volume of features getting added day by day across a technological segment, but when it comes to some kind of deployment, customers at the end of the day, right? On day 1, they want to meet or in parity with Cisco or Juniper. That's the kind of requirement they ask. But the community is evolving and there's a set of features constantly flowing in, and thankfully it's improving a lot, but still today, till date, documentation is something which in Sonic for a newcomer, right? It's still he or she is going to face a lot of problems. So this is where I just want to take a couple of minutes what, let's say, companies of our stature can do, right? So what we have recently launched is a 24/7 disaggregated networking support, primarily for someone who wants to start on Sonic. Let's say he has purchased 2 to 3 edge core boxes or UFI space and some boxes, right? And he wants to get on Sonic and see for his typical brownfield deployment, what can he do with those boxes? So that is where the servings of Palsy on these areas can definitely help in. So we have a 24/7 support infrastructure in place along with the resident engineer support. We have few skilled network engineers whom we can send to the customer site to configure and show them that okay, with the present set of infrastructure, when I say infrastructure, both hardware and software you have, these are the things that you can do. These are the things you cannot do. And when he makes a note of the things that he cannot do with Sonic plus that box, right? Those were the things that we try to kind of accommodate in our roadmap when it comes to the extensions of Sonic. Yeah, so one last slide related to what other aspect that we do, right? So primarily Palsy Networks as a company, we do software development service, software integration service, as well as support service, and the typical development of layer 2, layer 3 MPLS multicast set of features on top of both commercial nodes as well as disaggregated nodes, right? So that is our bread and butter. And of late, since about last 1 year or 1.5 years, we have started developing custom-made or the tailor-made solutions or use cases on top of Sonic for specific customers. So yeah, so we were incorporated in 2017 and we are about 120 plus engineers now. Our headquarters is Bangalore and we have one more R&D center in Chennai as well. Yeah, so thanks a lot Microsoft team for organizing this wonderful event, and special thanks to Ashay and team for the constant coordination and the support. Thank you.
This was great. Thanks a lot for presenting. I love the presentation personally, to be honest, and I love the support model which they are introducing, because we always talk about the enterprise or cloud scale. I love the idea if somebody is going and buying a limited hardware and they don't know anything about Sonic, you will be able to at least support handhold.
Yeah.
That's what I really loved about. Great presentation, great work, guys. Yeah.
Thank you.
Any questions?
So I'm making it so Krishnamurthy, great presentation. For use case one, you mentioned network packet broker, software-based app. Traditionally, we have seen that this use case was handled by a hardware tap solution, right? And it's CPU intensive use case. I wanted to understand, have you tested software tap for a real environment? How's the performance shaping up? Are there any concerns and challenges there? And then I have a follow-up question to that, so I'll let you respond to that first.
Yeah, so we have done 2 pre-trials with 2 of the customers where the number that I was talking about, right? Let's say you can filter a set of traffic and then selectively forward only part of traffic onto the monitoring tool, right? That filter number we have tested till 2000 such filters in the hardware. So this was with the Broadcom XGS ASIC. We do see that, when it comes to the hardware performance, there may be, obviously when the moment we completely deal with software, there may be few hookups, but the point that we are trying to address is for a typical small to medium scale enterprise, right? Compare the cost of buying a hardware tap with the Sonic based software, right? So that's where the customer is still okay for his kind of deployment. He can still try to afford to buy only software tap and live with it. And also the moment we say a functionality is implemented in software, of course there are areas for bugs or improvement, but the kind of flexibility it offers to the user in terms of as simple as saying the number of packets filtered, show command related to that, or you put a few kind of network management solution on top of that to display him what exactly happening is live, right? The flexibility when it comes to software solution is also more. So to answer your question, yes, we have tested till about 2000 filters in the hardware and the performance is decent enough.
Okay. Follow-up question. So the packet broker solution that you have, is that a homegrown solution or you're basing it off open source tool like Archimey or something like that?
It's a homegrown solution where we have kind of added extra set of developed code on top of Sonic based nodes. It's a homegrown solution.
Got it. And then for the monitoring aspect of things, what are some of the solutions that you might have tested?
So we have tested with the integration of Grafana and Prometheus server. But having said that, we are under POC stage for one of the enormous solution of our own actually. So what we are seeing is typically this extends to the next set of deployment now, right? The moment you have a data center, you selectively pick up a set of traffic, put it onto some network management tool, right? What next is some kind of analytics with it. So the idea behind developing a typical analytics software and how much sort of flexibility when it comes to monitoring and visualization that we can offer to the customer as a bundle, along with filtering plus dashboard capabilities, right? That is what we are attempting.
Got it. Last question. For the network packet broker capability, have you leveraged any of the inherent Sonic capabilities like Everflow or any of that?
So basically, we are using some kind of ACLs because that's one of the major reasons, right? At least for a small to medium scale deployments, we might not have to completely depend on SAI because SAI is not that rich. But if you see from where we are standing today, the ACL capability which is present in Sonic is powerful enough to serve this kind of deployment.
Got it. Thank you.
Hello. Yeah, so I was asking that this network packet broker solution, is this a new hop in the middle, or is it like they have an existing infrastructure like this Broadcom hardwares where you are running this? Because introducing one more hop in between, like then again, there are different problems of redundancy and other stuff that come into picture, right?
So we can combine it in both the ways, but what we have presently is an out-of-band solution. So which is a new hop in between, but like I explained with regard to the lag and the bundling of traffic aggregation, right? With that, the benefits that you are getting is powerful enough for you to compensate with this new hop.
And so for these kind of solutions, one other thing that, for example, we are talking with Arista is like, so there are container-based solutions, for example, which can emulate some kind of thing like streaming telemetry and some kind of these flow controls and basically flow monitoring, those kind of solutions. So why not run some lightweight containers on the routers rather than have a centralized solution where you do all of these things?
So we can do it either ways actually, but generally what happens is if you're, it's got something to do with your software design also. Now let's say with what as the base have we built our packet broker solution, right? Now if I have based it out of something out of ACL which is running in Sonic, and if you're trying to deploy a new container in the existing network, the typical BGP or some other protocols running in the network already might mess up with your packet filtering capabilities itself. That's where till date we have tried to put it as a out of band. So for in band we need to think what exactly better can be done.
Thank you.
So yeah, thank you very much everyone. Yeah.
I have one question. This is Partha from Broadcom.
Sure.
So regarding the security, right? We are collecting packets. So this security solution is just going to predict kind of intrusion detections, or some kind of malicious activities going on the network. Is it going to predict that based on the packet pattern?
So exactly, that is the idea. This part of product line is something which we are still investigating, and to be honest, we haven't put much thought into it. But the idea is one of the key feature or the key use case of network packet broker is collect a set of data, and that sample set of data, right? It's used as a input for an analytics engine, which has a feedback mechanism for doing a predictive analysis, and both the IDS and IPSing, both intrusion detection system as well as the intrusion prevention system, what you're talking of, right? So that comes as part of the analytics.
Sure. The second question on the forensic, I just like to understand, maybe it's mainly done from the IoT perspective, or okay, even it is a generic. How do you know what data has to be kept? Is there any kind of algorithms that you are running? Because in the forensic you really have to preserve the data that are important for your later on investigations.
Correct,
so how do you categorize those data in the forensic?
So yeah, I think again the main point is, see, this is something which we have absolutely not done now. The kind of software we have developed here, the use cases for deploying that software are these two. But just to touch upon this question, right? So what actually they say is, from our research, you can try to put some kind of install some filters in hardware during some times of the day to see any malicious kind of traffics are actually entering the system. And that data, when I collect, parse it and send out to some kind of agent here, right? This agent should be capable enough to make sense out of data and then act upon that data. So that's the overall idea. But this, whatever the act upon the filtered set of data, right? That is something which we have not done.
Okay, so also I think you're talking about some of the ML applications that you will be probably employing some of the machine learning over the data that you are collecting from the switches, right? And that's what you are going to do,
Yes,
right?
yes,
Okay,
yes.
okay. Thank you.
So the usage of the filtered data into a big analytics application, right? That is the next step. Yes.
Thanks a lot. Thank you.
Thank you.
Hey, thanks a lot for presenting. I think I am also learning a lot, and a lot of good development is going on. So thanks a lot. So what we will do is we will go for a lunch break, and the lunch break initially was planned for 60 minutes, and we started early, by the way. But interesting questions. So I am thinking that by 2:15 we will start again. So we have like 40 minutes, good enough to have a lunch. Lunch is ready. So let's all go for lunch. Thanks again for the presenting, and thanks a lot,
Thank you, guys.
audience, for the amazing question.
अच्छा
Check. Hey, 1, 2. Test.
Hey, check. Check 1. Hey. Check. Check 2. Hey. Check. Hey. Hey, check. Check 2. Hey. Check.
Check. Hey, 1, 2.
hold people up. Hello. This is okay, right? Okay, I just had to.
Hello everyone. We will start in 5 minutes. I will go and collect everybody now. Hello everyone. I hope you all had a good lunch. A lot of people told me lunch was good, even I liked it. So food was good. Thanks a lot. Please don't feel sleepy. We have a couple of more presentations to go. If you're feeling sleepy, let me know. We will arrange some coffee for you. um, so the next presentation is from Marvel. Uh, Ravindranath and Rajkumar. They will be talking about Sonic Ackles. Please join on stage.
Is my mic working? Yeah. Okay, sorry. Hi, good afternoon all. I'm Ravindranath, and this is my colleague Rajkumar. We are from Marvel's switching and Sonic team. To start with, I want to thank Microsoft for this opportunity, and more importantly, entrusting us with the responsibility of taking us all past this dreaded hour after this nice lunch to try and keep you all awake. Let's try our best. Okay. This talk, here we want to talk about how ACLs are important, how ACLs are important building blocks in Sonic for various features. Overview of the current features related to ACLs in Sonic, the recent optimizations we had done in Sonic in ACLs, and our next steps. The agenda of the talk is as starts. We first want to give an overview of ACLs and show how ACLs are much more than just standard firewall rules. We then show how in all modern network operating systems there are a lot of optimization features done to make the most out of hardware ACL tables. We then take a look at the role of ACLs in Sonic, the types of ACLs in Sonic, and then move on to the different optimizations done in Sonic for ACL tables. Later, we go into the recent optimization we have done for ACLs in Sonic. Then Rajkumar would go over the current work we are doing in ACLs. Based on our experience so far, what are the things we feel can be improved in Sonic ACLs, and finally a call for action. To start with, as I said before, ACLs are more than just firewall rules. Today in a switcher router, a typical forwarding feature matches specific packet fields and does the forwarding decision. For example, an IP lookup matches the source destination IP and does the forwarding decision. An MPLS lookup would take a look at the MPLS label and make the forwarding decision. But there are several niche use cases where the decisions have to be made based on multiple fields. For example, if you take the use case of policy-based forwarding, along with the destination IP address, we also need to take a look at in some cases the source IP address, in some cases the L4 header, and in some other cases the packet QoS fields to make the forwarding decision. In some other cases like the Everflow monitoring application, where probe packets are injected into the network to trace the path to a given destination IP address. In this case, the switches in the network are programmed with specific rules that match identified probe packets based on specific DSP values and send a copy of the packet to the remote collector. So all these kind of niche use cases are realized using ACLs. Why this is so? Because ACLs support multiple field match. For example, ACLs can match different packet header fields. It can also match metadata of the packet. For example, what was the incoming source port, what was the egress port, the incoming router interface, all these things can be matched and to make some forwarding decisions. It can also do various other actions. Sorry. It can do other actions like standard security rules like permit, deny, and it can also do redirect, forwarding actions like redirect, metering, mirroring, etc. And today in Sonic, the supported use cases are, we can do standard your security use cases, Everflow kind of monitoring application, and these are all user visible. In the sense, user can create these ACLs and configure these rules. And then there are a lot more applications in Sonic that internally use ACLs. For example, PFC watchdog, data path telemetry, MC lag, policy based hash, maxsec, etc., which internally use ACL tables. And then there are a lot more use cases that needs to come in Sonic that will use ACL tables. For example, these are the list of features that are already defined in the SAI spec, supported by multiple ASIC vendors, and which are yet to be supported in Sonic. For example, telemetry and monitoring. So telemetry and monitoring uses ACL tables to select the flows of interest, which packets to be monitored. Similarly, pre-forward ACLs use ACLs to decide the VRF on which this packet lookup should be done. Adaptive routing and switching. Again, this ACLs are used to say which are the packets that should go through VSMP groups with adaptive routing enabled. So there are a lot more use cases that are bound to come in Sonic that will use ACL tables. So ACL tables is a critical feature, just to re-emphasize, right? It's going to be a critical feature in Sonic and a building block for multiple features. And now we want to see why in most operating systems, network operating systems, there are a lot of optimization features that are done in the NOS to make the most out of ACLs. A lot of ACL focused optimizations are done in many operating systems. Okay, and why is it so? Today, the latest ASICs can do 51.2 terabits per second throughput, and they have very low latency. And to do a multi-field lookup, which an ACL needs, you typically need to do it via a TCAM. And what happens is, TCAMs are one of the most expensive resources in a switching ASIC. They also consume a lot of power. While the bandwidth of a switching ASIC grows, doubles sequentially, the TCAMs doesn't grow that much. As a reason, all the network operating systems have a lot of features that will optimize the way ACLs are realized in the hardware. Now let's take a look at the role of ACLs in Sonic. The left-hand side, the left-hand left column shows what are the standard ACLs that are user visible in Sonic. For example, layer 3, V6 are the standard ACL table types which an user can create to implement standard security rules. Your firewall rules, etc., can be done using this L3, V6 ACL table types. And then there are some set of ACL table types called mirror V6, mirror DSCP. These ACL tables are used to implement a monitoring solution like Everflow using mirror actions. And then there are a new set of something recently done called custom ACLs, where users can create their own ACL table types. We'll look at it later. And apart from the standard ACL table types that are visible to the user, there are few more features in Sonic that use ACL tables. That's what we show in the right column. PFC watchdog and MC lag. In some platforms, PFC watchdog, MC lag, etc. are implemented using ACL tables. Similarly, data path telemetry as well uses ACL tables. And then there's the last category called control plane ACL tables. So these are ACL tables that are realized using Linux NOS. So these don't come to the ASIC, and these are all done in software. Now let's take a deeper look into the standard ACL table types in Sonic. These are the ACL table types that are visible to the Sonic. So in Sonic, over a period of time, these are the ACL tables implemented as features. So when a new ACL table type is introduced in Sonic, what it does is it defines a bind point type, a set of matches and actions for the ACL table type. So basically what it means is, when I create an ACL table type called L3, the features we implement such a way that this ACL table type of L3 can be bound to port or lag objects. Basically, this ACL table type can be shared across ports and lags. That's what is meant by bind point type. And then there's also a predefined set of match fields which the ACL entries in this ACL table should use. For example, an L3 ACL table should only use IPv4 match fields. And then the last is the action. When an ACL table type is defined, it also specifies what are the types of actions that can be used by the ACL entries in this ACL table. Okay, so these are the predefined ACL table types in Sonic today. L3 L3 and L3 V6 are used for your security firewall rules, and also it can be done for used for policy based forwarding. And these rules, the difference is L3 table types can be used to match IPv4 packet fields, whereas your L3 V6 ACL table can be used to match V6 packet fields. Similarly, the other set of ACL table types used are for mirroring. So these all have mirror as an action, and the difference is mirror ACL table only matches IPv4 fields. Mirror V6 ACL table can be used to match your IPv6 fields, and lastly, the mirror DSCP ACL table could be used to match your DSCP code point. So what we see here is they're all each ACL table has a predefined notion of what should be your bind point type list, what should be the matches that can be used, and the actions that are needed. The net takeaway is, in case I have an application that needs just to use the same thing as here, let's say it takes the same things as L3, but it needs to use a new match field. Okay, so for this, maybe we have to create a new ACL table type. So what happened next? This happened something a year ago. So what was added in Sonic was something as a notion called a custom ACL table type. This feature allows user to go and create new ACL table types, and the user can, using configuration, create a new ACL table type and specify what should be the bind point type list for this new ACL table type, what are the list of matches that need to be supported, and actions to be supported. The advantage with this is, for example, let's say we want to create a new ACL table type called L2 to match L2 fields. If using custom ACLs, we no longer need to do a new Sonic feature. User can just configure the user, create a new table type and implement L2 tables. While this is a good step forward, still there are some limitations and some challenges in Sonic. For example, if I want to introduce a new match field, for example, I want to match some specific RDMA field in the packet. So what happens is, we need again some NOS changes for the ACL table type to be supported before this custom ACLs can use that match. So new matches still today need NOS code changes. And one more challenge with custom ACL tables is, since these ACL tables are used, created by Sonic by the user on the fly, some of the automations that are currently done for table types like L3 and mirror, etc., don't work on these ACL tables because these are done on the fly, and Sonic doesn't have the intelligence to say how to optimize this. So when a user creates custom ACL table types, the current optimizations available in Sonic don't take effect. Okay, next, before looking at the optimizations today available in Sonic, let's have a brief look at how ACLs are implemented using TCAMs. This slide shows a simple ACL table rule where user has created an ACL table where he matches both the source IP address and destination IP address and has a set of actions. And the left column tries to show the flexibility of an ACL rule. So ACL rule can match all the bits of the field, or it can choose to match some bits of the field, or it can completely ignore that field. So to realize such a feature in a TCAM, what first needs to know is TCAM in the hardware typically comes in basic building blocks. TCAM has a fixed width, and each of these building blocks has a fixed width and a fixed depth. The width decides how many fields can be matched, and the depth decides how many entries can be fit. So standard configurations would be, let's say, a TCAM block could have 80 bits of width and 256 entries of depth, or it could be 72 bits of width and 512 entries of depth. So it comes in standard sizes. And what happens is, let's say this match fields, this list of match fields that we have to match in a given ACL table goes beyond, let's say the TCAM block is of 72-bit width, and the list of match fields that I need to match happens to be 80-bit. So what happens is that these TCAM building blocks are horizontally combined to logically create a TCAM which can support two 72-bit TCAM blocks can be horizontally combined to support 144 bits. So in order to support an ACL table with match fields that go beyond 72-bit, you'll have to use two TCAMs. And TCAMs can also be combined vertically. So in case I have to add more than, let's say TCAM black has 256 entries, and if I want to have 512 entries, we can vertically grow two TCAM blocks to create one logical TCAM. That's one part of it. The next is, in each of this TCAM block, if I want to match, let's say, a source IP address, if I want to match the source IP address, okay, 32 bits of the TCAM are used to match each of this entry. So if the first entry matches, let's say, all the 32 bits of the IP address, the TCAM entry block here would have both the key, the 32 bits of key and 32 bits of mask. And if in this case, all the 32 bits of the mask will be turned on, whereas in the case of this second entry, where only the top 24 bits are needed to be matched, the mask will have the top 24 bits masked in and the lower 8 bits will be masked out. The same way for a wildcard entry, all the bits will be masked out. So this is how TCAM is implemented. Now let's go to the, this is a common case where several ASICs have optimized this case. The case is as follows. The user has created an ACL table where he wants the same ACL table to match both your IPv4 packets and the IPv6 packets. So the match fields the user would create would have both the source IP address and the v4 addresses as well as the v6 addresses. Okay, and typically for implementing this without optimization, implementing this on a TCAM would require the IPv6 address will take up 128 bits, the IPv4 address will take another 32 bits. Similarly, for the v6 destination would take 128 and 32. So this will end up to sum of all these bits around 320 bits. But what has been optimized is in several ASICs, what happens is, the fundamental idea is a given packet could either be source IP or source IPv6. So a given row could either match a IPv4 packet or an IPv6 packet. So with this understanding, what the optimization is done is the IPv4 addresses are overlaid on top of the source IPv6 addresses. What it means is, let's say when an IPv6 entry is created, all the 128 bits are programmed based on what the user has given. Similarly, when on the other hand, when an IPv4 address is configured in the rule, then that entry, what would happen is only a specific 32 bits of this 128-bit entries are used to match based on the user given value, and the remaining bits are always masked out. So with this, what can be done is we can reduce the width of the ACL table that is needed to combine support both v4 and v6. So now, how is this optimization today supported in Sonic? Before we go into that, some of the design goals, right? What are the challenges and the design goals? The challenge is this optimization is not needed for all platforms. Some platforms use TCAMs, some platforms don't even use TCAMs. In some platforms which use TCAMs, they cannot support v4 and v6 together. So there are a lot of challenges. Each platform has a different behavior. But a goal of Sonic is to make sure for an end user, the same configuration would work across all the platforms. So typically all these are handled by Orchagent. Orchagent solves all this by doing intelligent platform checks and a lot of optimizations. Today, there are two such optimizations in Sonic. One was something done in the past for optimizing your mirror ACL tables. And the other one was something we had done recently for the security ACL tables. Let's take a look at both of this. Okay, so this is the optimization that was done in the past for mirror ACL tables. So let's say there are some platforms on the right which can support v4 and v6 rules in the same ACL table, whereas there are some standard platforms where this optimization is either not supported or not needed. So in this case, in the standard platforms where this optimization is not there, this is what the user does. User creates two different ACL tables, one for the mirror v6 applications and the other for the mirror application. user creates two tables, and the org agent knows that the underlying platform doesn't support or doesn't need this optimization, and the org agent would create two different tackle tables in the hardware and manage like whatever the user needs. And the optimization done in org agent is on platforms where it can optimize both the V4 and V6 together. What the org agent does is it internally creates just one ACL table. So let's say when the user first creates just a mirror ACL table, org agent will internally go and create an ACL table in the hardware which can support both V4 and V6. Later when a V6 ACL table comes in, org agent will reuse the same hardware ACL table. So this allows in the optimized platforms to use the same ACL table for both V4 and V6. So this is also an optimization done in the past. Now, while this optimization is good, there are some problems with this optimization. For example, here, let's say this is what is happening in the optimized platforms. The user can create two ACL tables, whereas org agent has optimized it out to create a single hardware ACL table. So now the first problem is, right, since user sees two different ACL tables as a user, he could have different configurations on both these tables. Let's say he attaches this ACL table on ports 1 and port 2, whereas he attaches the second ACL table to ports 3 and 4. But the hardware is the underlying single ACL table. So that becomes an inconsistency today. Today the behavior is, there is some issue. Today whatever the behavior in Sonic is, right, only one set of configurations take effect. The other set of configurations which the user has done don't take effect in the hardware. Another issue today that happens is, let's say user goes and deletes one of this ACL table. Ideally, there should be some reference counting mechanisms or something, but today what happens is the underlying ACL table gets just removed. And one more other problem what could happen is, let's say today it doesn't apply for ACL table, mirror tables, but let's say as a feature, I would want to create more than one V4 table and more than one V6 table. If I want to create more than one V4 table and more than one V6 table, then the problem comes into org agent to decide which V4 and which V6 table should be combined together. So that today, since there's only one V6 mirror table and one V4 table, we don't have this problem. But tomorrow, if we want to extend this approach for other features, we can't decide which two tables to combine. And lastly, this is more like a deployment case. I am an operator and I am using a platform where both V4 and V6 can be optimized together. But my requirement is I just have V4 in my deployment and I don't have V6 in the deployment. Today what would happen is the moment V4 table is created in this platform, org agent will automatically create an ACL table which can support V6 as well. This increases the width of the TCAM. So this again is a inefficient use of the ACL table. So now we talk about what, so when we wanted to support this for L3 tables, so we wanted to have more security rules for the user and more policy-based forwarding rules. So in this case, when the user needs to have both V4 and V6 together, the approach we took was different from what was there for the mirror tables. So what we did is we first created a new table type called L3 V4 V6 to the user instead of trying to reuse the existing L3 and L3 V6 types. Okay, and now what happens is, right, we inverted the approach. So what happens is if org agent figures out that the hardware can optimize V4 and V6 together, okay, he would create a single ACL table. Whereas in platforms where this optimization is not needed or cannot be supported, the org agent would create two different ACL tables and internally manage these rules. Now what's the advantage with this, right? One thing is the first problem is solved. If the operator knows he just has only V4 in his deployment and he doesn't have V6 in his deployment, he need not create a V4, V6 table. He can just create a standard L3 table. So he will just use a small TCAM and he will not take a large TCAM. The second part is, since the user sees just a single unified ACL table, we no longer have the inconsistency where user applies two different configurations on the user tables and the hardware going out of sync. And the other use cases, what was there? Yeah, I think that's what about it. I think I'll let my colleague talk about the future work and next steps.
Thanks, Ravi. So ACL implementation in SAI may vary from vendor to vendor, and there is a clear need to optimize based on the underlying platforms. And today, most of these optimizations are very vendor specific. Because of this, there is a lot of platform specific checks added in the Orc agent, especially in the ACL module, ACL Orc agent. And one such example is with mirror tables, there is something called combine and separate. And this combined mode is not enabled by multiple vendor platforms. In current model, in order to add a new ACL matches or actions, there is a need to change, there is a need to touch upon multiple Sonic components like ACL loader JSONs or Yang models in Sonic management framework. And these changes happens to be identical. So there's a need to simplify the Orc agent's repetitive logic and also simplify the platform specific checks. So we want to enhance QoS mechanisms in Sonic using ACLs, and this slide captures the current activities that Marvel is working in ACL related areas. We are supporting, we are in the process of supporting ACL based metering or policing. Support QoS based match keys and actions like match ECN and set action as traffic class and set color. So we want to collaborate with the community on how to avoid platform-specific checks in Orc agent, give operators or the users more flexibility by providing runtime options rather than instead of adding a platform checks in the code. And we want to simplify the process of adding new match keys or actions in the Orc agent code. So one of the options we are evaluating is to move the platform-specific logic from the Orc agent to some vendor or operator specific files that can give some flexibility at the runtime to control this behavior. Okay. Thank you.
Thanks a lot, Marvel team. Is there any question? Anybody? Okay. If not, then.
Okay, thank you.
Thanks.
Okay. Okay.
So you were mentioning about identifying whether that underlying platform supports this optimization or not.
Yeah.
So is there any specific means that you have in your mind?
So the recommended way would be to create some SAI APIs, right? Some capability queries, etc., to figure out whether it can be supported or not. But there are lots of cases where such APIs are not possible. For example, right, in a SAI model, it's going to be complex to say if in the SAI APIs, somebody came with a recent proposal in SAI, okay, somebody recently a year back or something, somebody came with a proposal exactly saying that, hey, let's introduce a query which says, can a V4 and V6 be together? But then there was some other discussions. What happened is, okay, why just pick only V4 and V6 fields? That could be in some other hardware, some other fields can be combined, right? So this is not generic enough. Okay, so there are debates going on in SAI, it's not converged, but ideally the way forward would be to use such SAI capability queries to use this. But today it's all done using, if platform is such and such, do this. And that's what we want to move away from.
Thanks, Ravi. So I have one question to Rajkumar when he presented, right? So you were mentioning about leaving it to platform specific action to be taken, right? So do you have any proposal or you have something in
So actually, there is one proposal that we are, it's in discussion, internal discussion, and I think there is a ACL subgroup is also formed, which will be brainstormed in that subgroup to arrive to a final solution on this.
Okay. So one thing I would want to add is, right, in the Sonic Technical Steering Committee, there are talks of creating different subgroups. And one group, I think what even Guohan was talking about some subgroups today in the morning. I think one group Guohan was looking at was creating an ACL subgroup where we can do enhance all these features and all ACL applications, right? There are some subgroups that are happening where we want to discuss, take this to the subgroup and discuss and find solutions. Thanks. Thank you all.
Thank you.
Thanks a lot, Marvel team. Next presentation is from Arista, Karthik, and the topic will be Sonicon VOQ chassis from concept to reality. So I will wait for Karthik to come and join.
is next, right?
My name is no? Yeah, good. Hi everyone, my name is Karthik Chandran. I work for Arista Networks and in the Bay Area, and I'm here to talk about our experience with Sonic, building Sonic for our VOQ chassis. For and so yeah. So going back just a little bit about myself. I've been working on this. I was part of the team that built and shipped the very first generation of this VOQ chassis architecture on our product line, and it's now been the 4th or 5th generation. So it's been a long journey. So I've spent a lot of time in this area. So hoping to share some insights on what it took to bring this architecture to Sonic. So I'll cover a little bit of the technical background and motivation behind why we launched this effort, and cover a little bit of the high-level architecture and how we brought it to Sonic, and then talk about our operational experience, what it took to actually take it from concept to reality, which is of course the title of the talk, and then conclude with some learnings for the future. So first of all, right, so why modular chassis systems, right? And so you can just as easily build a network with 1 RU boxes, connect them all together. There are very well-known configurations that you can build arbitrary size networks, right? And a lot of people do that, and certainly a reasonable way to go. But when you consider that by optimizing on the form factor, by putting things in a chassis, you can save significant amount of power, like 25% typical. You also have a lower cost in terms of components to deploy. For the same kind of bandwidth delivered in the left side and the right side, you have 1/3 fewer transceivers and cables. And you have fewer devices to manage. In this case, like you have to have at least 6 devices on the left. Depending on how you do it, you can have much fewer devices, as low as 1 device to manage. And net, you get also a higher reliability of the install base, because again, you have fewer moving parts. And then why VOQ chassis systems? So there's some unique attributes about VOQ chassis, which is that firstly, the forwarding resolution happens on the ingress ASIC. Usually you have lots of ASICs in a system spread across line cards, and you have packets coming in on a port. You do the forwarding decision right on ingress, and you know exactly where you're going, which means that you can then queue the packet into a queue, and you don't have to make another forwarding decision. And then the job of the fabric, so-called, is to deliver the packet to its final destination. And this is accomplished by this mechanism called credit scheduling, where there's a scheduler running on the egress that's arbitrating across all the bandwidth requests from everywhere on the system, and then deciding when there's enough bandwidth to let traffic from a certain flow through. And so you're not sending packets to the egress and getting them dropped because there's congestion. So in a properly working system, you should have no congestion on the egress, right? And this is augmented by the use of deep buffers on the ingress switch, so that once you make a forwarding decision, the packet can sit in a packet buffer for a reasonable amount of time until you get permission to go out. And finally, and I guess I will say that this is not the only choice, but in the most well-known VOQ architectures, you have what is called a cell-based fabric. And what that does is it allows you, the packets that are looking to go from the ingress to the egress are split up into cells. The cells are spread through the fabric and then reassembled on the egress and transmitted. Now what this does is, it does 2 things. Firstly, it lets you do highly optimized load balancing. You can, it is not typical flow-based load balancing that is common in other designs, which means that you can really build a very efficient fabric. And the fabric itself is very simple because all you're doing is cell switching. You're basically looking at the destination of a cell and deciding which destination chip it needs to go to. So, and this is widely deployed in production today. So it's proven to be a successful architecture. And this brings me to the motivation for bringing this architecture to Sonic, right? Because it's a very well-known architecture, and it's another place where we can take Sonic. And so a working group was formed, which I was a part of, and we got together and we kind of hashed out how should we go about extending Sonic to support this form factor. And a few decisions were made right up front, which is that we wanted to evolve Sonic and not do anything drastically different from what it's already doing, which means we wanted to fit within the existing paradigms that Sonic already has, and within the existing design envelopes. And obviously extensions will be needed, but do it thoughtfully. The other consideration was that the VOQ chassis architecture is obviously not the only kind of chassis architecture that is of interest. There are other architectures of interest, and we got a mandate to try to minimize the differences, operational differences between these architectures. So we wanted to keep that in mind. The other thing we said is, in order to minimize complexity, and this is fairly common in Sonic, the assumption is that you want to keep the configuration models, large part of the global system configuration to be static and not necessarily change unless there's a good reason. So that's kind of where we came at it. And then that led to the following architecture that you see in the picture. Anybody who's familiar with Sonic will see that each one of these blue boxes looks very much like what you're used to seeing in any Sonic instance. Right? If you take a fixed config device, for example, it looks very much like what we call a forwarding Sonic instance. It's very much like a one audio device. And you have, so in a modular chassis with 3 line cards, you have 3 forwarding Sonic instances. And then there is a supervisor Sonic instance, which provides external management connectivity. It provides the required connectivity for exchanging state between the forwarding Sonic instances, and it implements controls of the chassis, like environmentals of the chassis, for example. And finally, it manages all the fabric chips, because the fabric chips are very simple. They don't need a whole lot of management. So I'll walk you through a very basic packet flow just to kind of build some context on the kind of work we had to do. But before launching in, some key concepts to highlight. First thing is that there's this notion of a system port, which is a chassis-wide unique identifier of a port that's provisioned in the beginning, which means that you have, say, line cards 3, 4, and 5 in a chassis. The first port in the line card will have system port 1000. The first port on line card 4 will have system port 2000, and so on and so forth. And this is known to the entire system. So which means that you can, if you want to send a packet to a specific port on this chassis, you need to address using that system port. Next, there is something called a neighbor index, which uniquely identifies a directly attached host, typically a next hop, on a specific ASIC. And this again needs to be known to the entire system in order to send a packet towards that next hop, right? So with that in mind, so imagine that a packet comes in with IP address 10.0.0.3, and then it does a routing table lookup, which leads to, say, a 2-way ECMP next hop entry, and say you pick 30.0.0.1. And so as part of that lookup decision, you get the 2 pieces of information that I talked about, which is a destination system port and a neighbor index, right? So this then gets attached as metadata to the packet, and the packet is then sent through the fabric. And it reaches the egress ASIC, where the neighbor index is used to index into a rewrite table. That rewrite table causes the MAC address to be rewritten to that of the next hop, and the packet goes out. Right. So this is a very kind of high level understanding of what a packet flow looks like in a kind of VOQ chassis system, right? And here's how the control plane works, right? And this is where it gets a little more interesting, right? So imagine that you have an example system where you have 3 line cards, FSI1, FSI2, FSI3, and 3 attached routers, R1, R2, and R3, right? So what happens is, say FSI1 learns neighbor R1 on Ethernet 1 with on system port 1, 2, 3, 4, right? So that's what its ARP table will look like. 10.0.1.1 points to R1, right? So what FSI1 does is it allocates a neighbor index, and then it publishes it to this chassis DB, which is sitting in the supervisor, right? A chassis app DB, I should call it, right? And this then gets published to all the other FSIs, and now they can program a next hop in their routing table if it is needed, right? So at this point, every FSI can directly reach every next hop, and this is kind of similarly for the other 2, and this is what the stable state. This is what the chassis app DB will look like. You'll have each next hop, its system port, and its neighbor index. And then there's a routing part, right? So you can hear, this is where there's a certain novelty in this architecture that comes up, right? Where each, and following the independent Sonic instance paradigm, each FSI is an independent router. So it is peering eBGP with each of its neighbors. For example, FSI1 has an eBGP session with R1, right? And similarly with FSI2 and FSI3. So imagine that R1 advertises this prefix 30.0.0.1/24 into FSI1, right? What happens is that once FSI1 learns this prefix, it re-advertises this prefix over internal iBGP sessions. So this is where the novelty comes in, which is all the FSIs, in addition to peering outwards, are also peering with each other inwards. And this is accomplished by using internal ports that directly face the cell fabric. They're not visible outside, they're just facing inwards, right? And so all these FSI inward router interfaces can see each other, can talk to each other, and then peer an iBGP session, right? Now imagine that the same prefix is now advertised by R2 and R3, which means that there's a multipath situation going on here, right? So what will happen is that as a result of all this re-advertising, in a stable state, you have all the routing tables seeing 30.0.0.1/24 via 3 different next hops. And this requires some tweaks to BGP to make work, because there are some rules around prioritization of routes between eBGP and iBGP that need to be overruled, and there's some configuration. And also making sure that the prefixes advertised over all these sources are all treated equally, and then result in all of the routers arriving at this ECMP routing table entry. So at this point, right, you basically have a router where if a packet comes in on FSI1 going to this prefix, it can go out anywhere. It can go out locally, it can go out to R2 or R3, and the forwarding decision is made on FSI1. So again, the final destination is resolved, going back to my earlier data path walkthrough, on the incoming instance, and the packet is then enqueued in a VOQ and goes out, right? So this was the architecture we all converged on, right? And then we said, okay, where do we want to use this kind of architecture? And the case that we were targeting was the data center spine router. Right? And if you think about what is needed in a very classic data center spine router use case, at layer 1 you need 40 gig and 100 gig connectivity is very common, facing downwards into servers. You typically have 100 and 400 gig connectivity facing outbound into the WAN. You also have both short range fiber as well as mid range, long range fibers with ZR optics. At layer 2, very common to use MACsec, especially on the northbound outward links, LACP, LLDP. And layer 3 is just IPv4, IPv6 forwarding. With routing, you have, as I said, eBGP external peering and iBGP internal peering. For QoS and traffic management, it's classic features like WRR scheduling, priority flow control, ECN, and classic telemetry features like Everflow, IP and IP decap, counters for fabric and for fabric links, as well as VOQs, which are new in this architecture. So in order to meet this use case, all of these things had to come together, right? And this kind of tells you all the pieces that had to be built. Everything from, you start off from the left with the SAI support. So we had to define a new SAI API to support system ports, to support this concept of system neighbors, fabric ports, all new concepts. SAI APIs were defined and qualified. We defined this architecture, and then all the work to make changes to BGP to support all these knobs, building support for fabric ports, for support for lags, link aggregation groups, as well as Everflow. They all work conceptually the same, but they work slightly differently because of the novelties in the architecture. And finally, there's a lot of other enabling work that had to come together to actually get to the use case, right? So on the SAI front, we had to support gearboxes, layer 1 gearboxes to support, for example, a mix of 40 and 100 gig links. You had to support MACsec, which is all foundational work that was happening in Sonic that needed contributions. We had to support extend PMON, which is the environmental monitoring infrastructure to support the chassis, aggregate state from the entire, all the components, as well as being able to support more complicated optics like ZR with SFP refactoring. So yeah, a lot of work across the board had to come together. So in some sense, this is a really good example of the community kind of uniting to execute on such a multi-dimensional project. And this is what, to me, is kind of the highlight of this work. And finally, talking about how to put it together and make show that it really works, right? And I'm sure the community is familiar with the Sonic management test infrastructure. It's been referred to in previous slides as well, where there are some well-known topologies against which tests are written that cover large parts of the functionality. So that test infrastructure was extended to support a tier 2 topology, where it's assumed to have 3 line cards with 32 ports on them. One of them is assumed to be a core facing card, and the others are leaf facing. And the unique thing was that the supervisor and the line cards were modeled as unique devices to test, which means that there was a large body of tests that you could execute just unchanged by specifying, say, a line card. Like if you're testing ACLs, for example, right? The ACL functionality doesn't happen to care whether you're running on a fixed system or a modular chassis. So you can just execute those tests unchanged, pretty much. Like at least the tests are written as conceived will support the functionality needed. So you get a lot of coverage that way, right? But what we discovered was that a lot of the tests that were written were kind of implicitly written with single chip in mind or needed to be generalized to support multi-ASICs. They also had hidden assumptions about various things that needed to be fixed. And so this really involved the community coming together and changing hundreds of test cases and evolving them so that they could work in this environment. And we also came up with VOQ chassis specific test cases that test parts of this, the novelty of this architecture, everything from BGP peering to forwarding across line cards and making sure that the counters and fabric ports work effectively, things like line card reboot works effectively. So the whole body of new test cases that were written as well. And putting it all together, current state of play is that Sonic 2022-05 is basically feature complete for this spine role. It's like just unscientific, 200 plus PRs were contributed that were attributed to the VOQ chassis, 200 plus test issues were resolved, and this is adding up to now tests are running with pretty stable pass rates in the high 90s. And there has been some very early limited production deployment which has been stable. So there's plans to roll out more widely in the coming months. And looking ahead, 2023-05 qualification is already underway for finishing whatever feature coverage gaps are still there and for more wider deployment. So during the course of this process, right, we encountered a number of challenges that are worth highlighting for the visibility of the community and as a group coming together to see how we can address them. So the top of the list is code latency. Like anybody who's contributed to Sonic knows this, right? You have to pull requests will get blocked due to reviews or other checks if you don't pay constant attention, right? And there's also the constant tension of changes having to merge into the master branch and then having to get cherry picked. So which means that if you are a multi-party set of participants, right, in this case there were at least 4 independent participants actively contributing, right? There's a lot of inconsistency in what views of the code base they see, which means that you're kind of running into the issues. So you have to do a lot of hand patching. Oh, I can't wait for that fix to come down. I'm just going to patch it, cherry pick it, and then so you deal with code divergence. Testing latency is also a challenge because a full run of Sonic management, especially on this tier 2 topology, takes 5 days. And the reason is because in order to get full coverage, every test case gets multiplied sometimes 3 times or sometimes 4 times because it's running independently on each unit. And there's frequent test regressions, mainly because when you, oftentimes when you change tests, there are unanticipated side effects that are hard to see until they merge and then they get run in a different environment. For example, people change something with respect to some T2 feature, tier 0 feature, it ends up breaking something related to tier 2. And there's always a limited ability to change, always fighting this battle of I need to get my change in versus get all the test coverage. Right? And when you have this kind of testing latency, it's not practical to test your changes against every possible combination. And the other really interesting thing in working in this environment is that there are natural information silos, right? Because when you have these sometimes there are competitors participating in the same, collaborating in the same, on the same project. So each participant's sensitivity has to be respected. And the lack of visibility can lead to repeat work. So putting all this together, like in terms of learnings, right? I fully echo what Saurabh said, which is that it all starts with the use case, right? To the extent that you have really targeted, well-defined use cases to go after, it allows you to prioritize and focus because there are a lot of open-ended problems that you can go after, right? And you really, to actually make something happen, you always you want a use case to refer back to. Is it important in this use case or not? Okay, then I'm not going to fix this now, I'll fix it later. But I cannot afford to miss this change, so I'm going to focus on fixing it now. Or this feature gap that's missing for this particular deployment. There's no point building the whole thing if you can't support this blocking feature. So So it really boils down to that, right? And in a community where you have this kind of, participant mix, right? It's really important to focus on the shared goals, right? As a community, what does the community want to achieve, right? And then understanding your role in that, right? And then contributing towards that role. And it really helps to share information early and often, right? Towards the early part of the testing cycle, we would really go in circles around stability because there were a lot of issues that were kind of low level that were causing a lot of tests to fail, and all the participants were kind of discovering these issues on their own. But over time, we built a nice collaboration framework where there was a lot of focus on filing issues quickly. As soon as you see something, file the issue and raise visibility. There was a very organized tagging scheme that was put in place so that you can see all the issues related to the VOQ chassis in one place. There were live sync ups, and this is where Microsoft played a really important role in coordinating everything and making sure that all the participants knew what their role was and holding them to account. And this is my final point, which is that a strong sponsor is critical because ultimately it's that that is what determines the energy and the momentum towards getting to the project. And when the sponsor has a strong interest in seeing the end goal succeed, then it has a rallying effect on the rest of the participants and then that allows, they also have visibility across participants and they can see, for example, that the same issue is being seen with one contributor versus the other contributor and assigning responsibilities effectively, right? And they can also are in the best position to dispatch work, right? And in many cases, right, it's not clear what the interests. So I cannot, as one vendor's participant, know what another vendor's interest is or what their situation is. And I'm not supposed to know, I don't expect to know. But it's the sponsor who can see across all these things and navigate the situation. So, and looking ahead, I think there are a number of ways. I think this was a pretty monumental effort and I think the community should be proud of itself for pulling it off. Obviously, there's a lot more to go. Once the solution gets rolled out, we will learn from operational experience and see what kinds of, especially on the telemetry and visibility, as well as operational side of things, what could be improved and how we can make it easy to use. And especially on the testing front, how we can optimize the testing workflows, how we can speed up tests. There's probably a lot of room for optimizing. The tests are full of sleeps, for example. If you look at like sleep 30 and the test is doing nothing for no reason, like there's probably ways to rewrite those tests so that they don't need to be so slow. We can do more with scheduling and classification of tests and basically maybe have grades of tests which allow you to run a quick pass to determine top level stability, but run a deeper pass to get coverage. And also baselining, because again, it's one of the challenges. It's hard to know where one participant is related to the baseline. So you're always asking that question. Well, is it something that's broken in my environment versus something that's just fundamentally broken? And so to the extent that we can get better about information sharing in a neutral way, it helps a lot to make progress. So yeah, that's all I had.
So in the forwarding resolution table, you showed 3 entries.
Yeah.
So what is the use case of using neighbor ID?
Yeah. So the
VOQ resolution.
Yeah, here, right?
So let me just Sonic, is it very peculiar of Sonic using a neighbor index?
It's got nothing to do with Sonic. It's got to do with the actual architecture of the chip. Right. So basically, yeah, you could. So the way it's set up is that on a chip, there's a reference to a MAC address, a rewrite. So all that's happening is instead of programming that MAC address on the ingress chip, you're programming a a reference to that MAC address. And there's a good reason for it. I mean, the reason is that this index is a good general purpose indicator of rewrite operations of various kinds. It could be tunnelings, for example. It could be you are sending a packet into a tunnel. And all the rewrites have to happen on the egress chip. So you can kind of decouple the logic of ingress processing from all the rewrites by just using this reference. So that's the basic idea.
Is it agnostic to PSI layer of Sonic? It's purely on the data plane? Neighbor index.
The neighbor index is not agnostic to Sonic. There is actually extensions to PSI, and this is what this work did. Sorry. I had a slide on that. The PSI changes to support VOQ chassis have additional state to convey to both program neighbors with neighbor indices as well as share the state.
So ASIC agnostic use case is getting fulfilled with this neighbor index. There is no problem. And the performance of traditional VOQ chassis and a Sonic PSI enabled VOQ code, it's equivalent.
It's equivalent, yeah, because the data plane has no idea that it's running Sonic, right? The data plane is simply configured in a certain way. The forwarding tables are configured just like they would with any other stack above.
So one use case value question.
Yeah.
So you had tested this in Sonic management setup. In real deployment, the virtual output queuing is used in data traffic.
Yeah.
It's high speed, ultra low latency data centers with next gen workloads, with deep packet visibilities.
Yeah.
It needs high throughput.
Yep.
So why did you test it in Sonic management interface? Because there is no real production value.
No, so there is, that's fair. So I would answer that question in a couple of ways. First thing is, there is a lot of value in testing everything outside of the data plane. Because I think fundamentally there's a pretty high level of confidence that performance-wise, right, the data path, if you set it up correctly, it's going to run at 100 gig or 400 gig, right? So there's a large part of the solution which has to do with, is BGP working correctly? Is Orc agent programming the routes correctly, right? Which have nothing to do with performance. So a large part of the test matrix is all that, and that is amply covered with Sonic management. Now, with respect to performance testing and things of that nature, I think there is room for, I know that there are participants like Keysight that have contributed to integrating things like Ixias into Sonic test infrastructure. And that is something that could be explored. But at least in the short to medium term, that's been kept outside the scope of Sonic management, and each vendor, it's their responsibility to prove that performance testing is done outside the scope of the automated tests. So.
Celification is also involved in this architecture?
I'm sorry?
The celification in the legacy VOQ, talking about the backplane fabric celification, that still exists in this architecture with Sonic?
Yes. Yeah, again, that doesn't change, because ultimately what's going to happen is you have one way or the other, right? Once a packet is sent into a VOQ, what comes out into the fabric is cells. Yeah, and then, so again, data plane mechanics doesn't change with respect to what network stack you're using.
Try this in data traffic production.
Sorry?
Please try this architecture in some production, mini production network. That would be of great value.
Well, I would argue that, as I said earlier, this has run, this architecture in terms of forwarding has run for 15 years in production. Widely deployed, not with Sonic, but widely deployed. Sure, yeah.
Hi. Yeah, can you go to that IBGP slide?
Yeah. Yep.
So what advantages does IBGP bring into infrastructure when you are exchanging route via this rather than some traditional way it's done? Because now each of these FSIs have to have their own RIBs, and let's say if they are multiple verbs and all, they have to maintain all of this, each of these FSIs, right? And there can be inconsistencies like BGP going down and whole time expiry and all those things.
Yep.
So what advantages is IBGP bringing so that does counter all these disadvantages?
So the best way to think about it is again, it goes back to the founding assumptions made, right? We want to extend the way Sonic works today and not completely revolutionize the way it works. And there's a certain paradigm in which each Sonic instance is an independent router, right? And it turns out that pretty much out of the box, right? The problem of route exchange across peers in a network is automatically solved by BGP. So why reinvent the wheel? That's really what it comes down to. Right? The alternative would be to implement a full state synchronization scheme. You could do it through the chassis app DB, but you have all the mechanisms in place, right? FRR does this today. Like you just needed 1 or 2 knobs and like 10 lines of code change, and it just works. So why bother?
And what kind of load balancing does Cell Fabric does? Because you said that at least for ECMP kind of decision, it's decided in the ingress ASIC itself, right? So what kind of other load balancing?
Yeah, so the question becomes, right? So if you have, let me just go back to this picture here, my original picture. So the question becomes, so packet comes in, say, on the top box here, the top ASIC, and you made a forwarding decision, right? And it needs to go to the box, to the chip on the right, right? There are many paths through the fabric, right? And there's obviously the ECMP decision you've made before forwarding resolution. It's part of forwarding resolution. You already passed that. So the problem is one of getting the packets from the ingress chip to the egress chip, right? And it turns out that if you use traditional flow-based load balancing, right, there are a number of inefficiencies that can happen. And by using cells and by using kind of round-robin load balancing, you can utilize the fabric links much better. And it's a lot more resilient because it's very resilient to, for example, single link failures if it ever happens. Because all you need to do is exclude that one link and you still get, the cells can go out on n-1 links and you still preserve a lot of efficiency. So that's the kind of motivation. But again, as I said, this is just one way to do a switching fabric. There are other architectures that will do to make other choices. But it just so turns out that in this architecture, this is how it was designed.
Thank you.
Yeah, sorry, yeah.
So here assumption is the fabric is VOQ based,
Yeah.
right? So there are different architecture where there's shared memory and all things. So we have queues in the egress cards and
Yes.
So does it mean that this particular implementation supports only VOQ and cannot support other hardware chassis?
Correct.
Okay.
Correct. Okay. It's only for VOQ architectures. I mean, all the basic concepts such as system ports, for example, are all just VOQ concepts.
Okay. So is there any atom going to made to support other architecture?
There are other parallel efforts. There's a packet chassis effort, which is also being is active in the community. So that is another form of modular chassis support.
Okay.
But yeah, it is not directly related. It doesn't intersect with this work, at least from a kind of forwarding plane point of view. It does intersect in areas like the PMON, for example, or in support for transceivers of various kinds, which are kind of architecture agnostic.
So basically, you can reuse the blocks, basically.
Yes.
Okay.
Yes. All right, great, thank you. And yeah, shout out to the Arista team right there for coming out in strength.
Okay, thanks a lot, Arista team. And thanks a lot, Karthik, for presenting. The next presentation is from Avis. And Sudarshan and Kuldeep will be presenting about multi-vendor Sonic ARC and network visibility at scale. Please get the stage. Thanks. Thank you.
Yeah. Hi everyone. Am I audible? Yeah. Good afternoon. No, PPT you are downloading. Lunch was good, is it? I can sense that because in the morning session I can see the intensity of each engineer and curiosity of asking the question. It had gone down. So Feel free, okay? So yeah, before I start and jump on the starting my session, right? One thing, I think thanks to Microsoft and team, Ashay and team for organizing such a good event and hosting us over here. Yeah, so before even starting and discussing our topic, I think we all do the different work in this field, but we all are united by the Sonic. With the help of Sonic, we are creating something more and more, which is actually, I think, solving the problem in the world, right? One or other way, it could be anything. If you are doing something which is at the POC level, but you have a specific vision in your mind, one or other day it might click and it might solve the different problem, which we don't know. The classic example is when I think cell phone was introduced in the India, right? So at that time, I think incoming call were also chargeable, if I'm not wrong. And one of my friend who was standing next to me was asking me a question that what if I wanted to not to attend the call from the different vendor or set of people, but I wanted to address the queries or the calls from my family. I said, you can buy another one. He said, man, incoming call itself is chargeable. In this world, you are asking me to afford one more cell phone. And now look at, I think each and everyone in our pocket carries the dual SIM phone. That's something somebody would have visualized and would have thought of the need at some point of time, then only that thing is possible. Without that, it's not possible, right? So few years back when I started my Sonic journey, right? At that time, somebody has to take an effort and explain me what is Sonic really, though I am from the networking field. Okay, very long back I am saying, but now in this current time, we don't need to have, or when you go and talk to the people who are in our field, right? We don't need we need not to offer any introduction about the Sonic. That's the beauty of it. In the opening speech, I think David had covered most of the brilliant aspects. What was the past, what is the current, and what is the future, right? That is something we should all proud of it, whether directly or indirectly, whether we are contributing or not, but ultimately we are making the Sonic a great thing. That's all it is. Of course, we all have is our goal in our mind, organization, enterprise level goal, but ultimately we all are divided but united by the Sonic, right? So myself, Kuldeep, my fellow colleague Sudarshan, we are here to discuss the topic multi-vendor Sonic orchestration and network visibility at the scale. Yeah, so let's move forward. Yeah, so this is the agenda we have it today. We kept it simple. We don't want to talk too many things about at what is happening at the multi-vendor, because I think each and everyone are aware of. Earlier, it was a choice whether I wanted to go with the multiple vendor or not. But now I think who all are related to this field, they know why we should keep multiple vendor solution in our ecosystem, no matter whether you are XYZ domain or a different domain, right? There are multiple things which are really when you try to factor it in, ultimately when you have a multiple ecosystem in your enterprise, it really makes your life more smooth and easy. So yeah, multi-vendor deployments, right? So as a part of customer interaction, when we go and talk to the customer, when we try to understand their requirement, how really, if they are aware. Few years back, many of them were not aware that something like this exists. Okay, but when we try to introduce and tell them that this is what it is, the one word sometimes we get it from them is, okay, wow, do I need to pay anything? I said, yeah, if you have a hardware, you can get something Community Sonic and you can get going. You need not to pay anything for anything. You can start an experience. If it works for you, it's your choice, right? So now when we go and talk to them, and ultimately when we try to maximize their success with the Sonic, right? One thing we get it, every NetOps and the engineering team or the network admins teams, they are very much interested in going and trying it out that in the Sonic way. But look at what this multi-vendorness brings in as a problem into their ecosystem, right? That is something when you try to go and talk to the people, NetOps team or the network admins, you will realize the pain. Okay, literally in one of the customer interaction, I got a light moment answer is like, oh, another one. So I said, okay, pardon me. Then he said, okay, I have already a 7 ecosystem running in my data center. Now I have to afford one more. I said, yeah, boss, you are right. But as your enterprise choice, let's explore it out and let's think about it, whether it is a one more or really you want to. Whether it works for you or whether it doesn't work for you, that is something, all the factor has to be accounted, not only you, right? So yeah, sometimes when you look at from the top, you may get a feeling that, okay, one more. ecosystem in our data center, right? But it's not a one more. It is, I think, an advantage when you have it. So let's go straight to the topic where I'll first cover up some of the challenges which this multi-vendorness brings in, how Sonic is able to address that, and then later on our once solution, and we'll discuss more on that, and later on we will have a demo and the question and answer. Fine? Okay. Okay. So in terms of challenges, there could be minor challenges that we all acknowledge it, right? But the biggest challenge, if you look at it, that one more which I said, right, that is nothing but you don't have a single interface through which you can make everything at one point. That is a single interface through which you can ultimately make sure that your interface should become a vendor agnostic, right? Whether it is possible, not possible, that's a different story. But if you ask any customer, that's what they want. That if I have one thing which will work for my whole data center, I would love to buy that, no matter what. Okay, whether it requires for me to upgrade certain things, of course, everybody has to do all the number calculation, but they will love to, right? So currently there is a lack of single unified entity through which they can do all this management of their data center. That's number one. Now, when they don't have, second thing, challenge will come on its own. When you don't have, what you have to find alternate. What is that alternate? You have to train yourself. Yourself means your team, your people, your ecosystem has to be trained for any new thing which you are introducing to your ecosystem. So that is nothing but the training and the cost. That's the second one. The third one is, though I have written it as a configuration complexity, but it's not just a configuration, right? You take anything, you interact with any NetOps team or the reliability team or the network admins, right? It is very tough. Okay, the classic example is one person who joins as a beginner, right? If he knows certain things and if you throw another one saying that you go and manage this, first of all, he will think that, okay, what am I supposed to do with that? I don't even know. Okay, syntax, it's a taboo, I know. You know the concept very well. As an engineer, people know what is ECL. But how to express that ECL to that ecosystem, that is something is different today. So that is what I call it as a configuration. It's not just a syntax that ABC does this and XYZ does, but both are same. So, but that's a fact. Everybody has to learn that. Without that, you may not be able to talk to multiple ecosystems or the multi-vendor solution which is existing in your data center, right? Yeah, that is the third one. Let's go and see how really it solves the problem and up to what context it solves the problem. But before we jump into that, if you look at this, here we have one simple three-stage close architecture where you have 4 leaves and 2 spine, and servers and the VMs are connected to that. Now, assume that you have some leaf from vendor 1, another leaf from vendor 2, another leaf from another vendors, right? And so on. So imagine if you have such a thing, and if you want to solve the problem and wanted to have one unified way of managing and having a network visibility as well on top of this deployment. Would you like to have a different solution at your end deployed, or you would like to have a single thing which does the job for you ultimately? So that's what it is. So Sonic as a high level it helps, I think more, it tries to solve most of the problems which are the key problematic area. There could be some minor points, but again, we know that how quickly community is adapting to all the requirements, right? I think Karthik, right, in the last session, he spoke about the learnings he shared. I think he spoke, engineer's mind. I would really appreciate your thought on that. It's a pain, but everybody has to mutually respect each other and grow on. That's how we can grow. We cannot keep on pulling everybody's leg, right? So, so there are few things which we'll cover it. Yeah. So this is the Sonic's answer towards that problem. So if you take Sonic, you have a unification. All you have is whole configuration will be a whole. You need not to learn and keep on learning the different configuration when you try to talk to a different vendor ecosystem, right? That's number one. Second thing is, we all know what is the importance of SI layer in the Sonic architecture. It doesn't require any introduction. It literally decouples everything. Software and hardware is two different things. Your single software will most of probably do the job for almost any hardware SKU if you have it, right? Of course, there will be some pain points in integrating all of them, but it's not impossible. That's the beauty of it. Another one is the architecture of what Sonic has. It's totally modular, right? One fine day, myself and Sudarshan, we were discussing one customer, and they said that we wanted to have this requirement in place. So they were literally scratching their head how they can solve this problem. We said, you can solve this problem in this way. What's the problem? Then he said, how, and I'm talking about 2 or 3 years before, when there was not enough awareness regarding the Sonic, right? They were not aware how literally they can do the things. So we helped them. Ultimately, they were able to see the things in the action and they were literally very happy. That's what it means. And then literally, though we have given the presentation to them that this is what it is, it is a modular, but unless it solves the problem, then only that people or the customer literally appreciate that, okay, this is how you are solving the problem, and because of the extensible and the modular architecture, you are able to provide me the solution. It's not like that we are doing some magic and doing something for them. It is because of the Sonic. And we are using them to solve ultimately the customer's problem, isn't it? And last two, I think I'll put it in the, I don't want to divide it, but I have to call it out as a separate thing. But if you look at it, we are community driven. We have an active customer backed, actively well, I would say, discussed active roadmap. It's not just a roadmap, active roadmap. And I think everybody is fulfilling their promising in every release of the Sonic. We see the rapid number of features being introduced in the Sonic. Here in today's conference itself, how many things many of us are aware that this is the current state of XYZ feature, and this is what is happening in and around it, right? Many of them are new for me. It's not that I was actively aware about it and what's happening, I was aware about it. But yeah, that's the advantage of having a community driven and open source solution in your ecosystem ultimately. So moving on, here we are introducing our AVIS 1 suite, that is nothing but Open Networking Enterprise Suite for day 1 and day 2 orchestration. Okay, so if you look at it as a part of that, we have a very simplified fabric manager which helps network admins to do and manage their multi-vendor Sonic data center. Okay, it does not only help in day 1 orchestration, but any day 2 orchestration or the cost in cost out need. You will be able to do the orchestration or the configuration of targeted devices, whether it is a whole set or whether it is a single device, you will be able to do that. Okay. Second thing is, and good thing about it is, it's a single click interface. You need not to keep giving a multiple input when you want to deploy the fabric. If you have a topology like one which is appearing over here, right? You just give an input parameter, or I would call it as a intent. You give your intent, express your intent, we'll be able to deploy it for you. Of course, when you want to go with the traditional way where you are comfortable in giving some short input and then you want to incrementally build it, yeah, that is also feasible. But if you show and express your intent that I wanted to have such things, yeah, that is enough for us to go ahead and build literally this sample deployment for you. Okay. And as a part of that, what we do, literally we validate whatever the input you have given. There could be a chance that you try to give a wrong input to the tool, that you do this and do this. Both of them literally contradict to each other. Doesn't make sense in the practical. Theoretically, we can do that, but practically it doesn't make any sense, right? We try to warn them why you are doing this. If you want to do it, we'll do it. There is no problem with it. So we validate, we apply, and we do operational verification of that deployment of or the configuration what our tool had done, and we'll show the summary and the status of it, whether it has been done or not. Right? That is a single click interface. Third one is whatever the community or vendor Sonic's offering currently available in the market, right? We are able to try to orchestrate almost all the features which is available right now, which covers probably L2VX, VXLAN, EVPN, MCLAG, IP close, 3-stage, 5-stage, with Tor, without Tor, whether you have a super spine or not, whether you have just a leaf pod, because we have seen some customer use cases where they just have a single node for some reason. Okay, reason best known to them, best for their business and best for their requirement, right? So yeah, we were able to support that, and they were amazed that okay, we made our architecture changes in our data center like anything, and still you are able to give us an answer. Yes, that is one of the advantage of using this particular tool. And third one is the we don't only offer this thing as a whole, simply because if most of the deployments are, I think nowadays are brownfield deployments, right? So people wanted to integrate something in their existing network. They don't want to change each and everything from the top till bottom and try to change everything. They wanted to fit some solutions into their existing pipelines, which creates a value for them. So yeah, it is API based as well, which you will be able to easily integrate it in existing ecosystems as well. So whatever you do it in day 1 and day 2 by having access of some UI client of ours, or whether you wanted to go with your API way and integrate it in your existing environments, yeah, both the options are available here. And some of the sub features which is highlighted over here is if you want to specifically do a custom image upgrade, ZTP, some config validation and the diff across multiple deployment cycles, what you have done, and you can take a backup, restore it, or the RMA case up to a certain extent. Yeah, these all are supported in currently with once. Yeah, so I'll move on, and I think Sudarshan will take it over from here. Thanks, Sudarshan.
Hello. Is it working?
Yeah.
Thanks, Kuldeep. Good afternoon, everyone. So, any deployment. Is this okay? Yeah. So, good afternoon, everyone. So, any deployment that happens in scale obviously needs to have good visibility of your network. So, that's what we are going to discuss. So, this is something that came out of when we helped our customers embrace Sonic. So, some of the stuff that we'll be talking about is deep network visibility, how Sonic is supporting that, how we enhanced Sonic to support those, and how we helped customers embrace Sonic from existing network deployments. And this stems from the fact that Sonic itself is an excellent microservice-based architecture. So the agent that we added, the enhancement that has been done on top of Sonic to support this telemetry is also a microservice-based architecture. And I'm sorry for folks who know this already, I might be boring them, but to touch upon, this is being done on top of GNMI-based principles, which includes gRPC, and we are supporting OpenConfig. I remember there was some question coming up about Sonic Yang model and OpenConfig Yang model. Currently, we are supporting OpenConfig-based Yang model, and we have plans to move to the latest Sonic management infra, which will support Sonic Yang also. So the network state data are mapped to OpenConfig Yang models, and these are exported up towards the controller. Remote procedure calls, again, this is something specific to GNMI. We support capabilities. GNMI supports get and set. We support only capabilities and subscribe for streaming telemetry. We do support standard APIs for integration. This has been already integrated with open source tools such as Prometheus, Grafana, so that any existing ecosystem, it's very easy to plug in these models. And one of the points that I would like to touch about is that, this is very useful for capacity planning for future traffic considerations and demands also, because this gives you that current snapshot of how much the network is utilized, not just bandwidth alone. We will have a short demo showing what are the parameters that we export and what are the parameters that are being shown. This is how we achieve it. Of course, this is what I was mentioning as the first point. We latch on to Redis DB supported by Sonic, as well as few other Dockers like FRR and LLDP to take the data. The data is converted or mapped into open config models. Those models are exported using standard gRPC procedure calls. Of course, there are other some standard operations also. This is this one's solution overview. This is where this multi-vendor concept also comes into picture. We do support agent deployments on Sonic devices, which is supports a disaggregated model that will feed into that funnel or pipeline where we have this controller which will provide deep visibility and assurance and orchestration. And this supports some of the specific stuff that are needed to monitor for Sonic, which includes inventory which includes system, platform, optics, and connectivity, health check of the device that includes control plane and data plane data, utilization of your ASIC system resources, and also about your typical network operating system NAS. You can also see some of them are marked as blue circles that represent current deployment, which is Cumulus. So let's say it was a specific ask from one of our customers where they wanted to support Cumulus so that their migration to Sonic is very seamless. With this, we have a small video that we would like to play that demonstrate the capabilities.
Click, hold on a second.
Hello. Yeah. So this is being done by this orchestration and then this deep telemetry support that we just talked about. I just also want to make a mention that there is another product, Open Packet Broker, that a talk was given by Amit Thoma in OCP Europe, and that is being deployed already in the field for I think a year and a half back for one of our Japanese and North American customer. With this, I would like to stop for any questions.
Thanks a lot.
Thank you.
If there is any question, I'll take that. Okay.
So regarding this open config model, right, that you were showing, how exactly is it going through the Sonic management framework or?
Currently, it's not going through Sonic management framework.
Okay.
But we are having plans to migrate to, or no, not migrate to, rather accommodate Sonic management framework also. This is a separate agent actually.
Okay, thank you. So other question is, for the visibility part of the different switches, right? The locks are very important, the syslocks, which can give me a lot of indications how is the health and is there any problem in the network or not. So do I get a visibility
Yes.
across?
Currently, we do support visibility for those locks, but that's minimal. That's a work in progress. If Ashay promises same better food, right, we'll come back with the better presentation next time for the logs also.
Okay, thank you.
Thank you.
Okay, thanks a lot, Avis team. So we are definitely running behind schedule. So what we are going to do is we are going to take 5-minute break. Tea is outside. I will request all of you to go take 5-minute break, get some tea, coffee, and come back. And then we will start with the next and last presentation from Dorado Software. Okay. After the last presentation, we have 2 more agenda just to let everybody know so people should don't leave. Okay. So after the last presentation, we have a plaque distribution to all the speakers, and we must have to take the community photo because getting everybody together is very difficult. Not only for me, I'll be very honest, for all of you also. Cool. Hello everyone. I hope everybody's here. So we have a our last presentation. After that, we will do the plaque distribution and we'll take a group photo. I'll try to make sure that we are on time and we will try to close by 5, maximum 5:10. I can understand a lot of people are flying and they have to go back, they have a flight. So we will make sure that we will close the session by 5:05 or maximum 5:10. Um, with this, just give me a moment. Let me check the PPT and then I will call the next presenter. Okay, I would like to welcome Vijay from Dorado Software to talk about build versatile network with Sonic topic.
Good evening, everyone. Hope the tea was refreshing. And I'm Vijay Desigan, part of PLM at Dorado Software. Dorado has, can you hear me? Okay. I'm Vijay Desigan, PLM at Dorado Software. Dorado has software solutions that provide controllers, automation centers, and network monitoring for network architects and NetOps people and network operators so that they can deploy a large-scale Sonic environment. We've been, yeah. Hello. Okay, so let's start over. I'm Vijay Desigan, part of PLM at Dorado Software. Dorado provides software solutions for configuration for controllers, automation centers, and monitoring for enabling network architects and NetOps people to deploy large-scale Sonic deployments in enterprise and data center environments. We've been helping customers adopt Sonic in both greenfield and brownfield deployments. And we've also helped customers adopt new technologies for the past 17 years or so. And so with the expertise that we've built over the years, it's easy for us to help customers adopt Sonic without much expectation, much expertise from their side. That said, we've been working on Sonic for the past 3.5 years, and it's been great to be part of the Sonic community for the past couple of years. Being part of the community has enabled us to, accelerate our 100% Sonic focus by interacting with various partners and community members. And at the end, this benefits the end users a lot because this brings out better solutions that help accelerate adoption of Sonic. So today, I want to go back to Saurabh's presentation of, being able to engage with enterprise users and find out the real pain points for them in adopting Sonic. And the topic for today is basically about how enterprise customers are taking to adopting Sonic. So the agenda for today is to look at the expectations that customers coming from the enterprise world have. And we look at how these expectations drive the type of topology or solutions that they choose for their data center or telco data center environments. And the second use case that I would like to touch upon today is the edge or campus use case, which has been receiving a lot of attention in recent times. And finally, the third point that I would like to discuss is how customers fall into a spectrum of build versus buy as far as Sonic goes. And if you are still energetic to ask questions, I am happy to answer them. So let's start off with the expectations that customers coming from the enterprise world have, right? So the customers, I'm not going to read all of it, but to highlight the important points, they like the ability to choose from open hardware, and they like to keep their business practices because business continuity and their operational workflow is very important for them. They would like to have end-to-end automation and a single pane of glass that monitors their whole network, even if they have a heterogeneous set of technologies that are deployed in their network. And if you look at some of the enterprise customers and largely in telco customers, the requirements that they have on multi-tenancy and role-based access is driven by the operational workflow and their business practices, right? It is not a one-size-fits-all. Each customer has their own set network policies, operational policies that they would like to maintain. So these expectations are always like they are a benchmark that any solution that they deploy into their network has to meet, right? So if, when people are looking at a data center refresh in the enterprise or the telco world, they are looking at, adopting a diverse set of technologies at a very rapid pace when they don't have enough time and personnel to catch up to all the technology. And they don't want a lot of operational complexity, and they also have to deal with integrating the greenfield with brownfield environments. So if we look at how Sonic solves this problem, Sonic has been built like Sonic's leaf spine architecture has Sonic's leaf spine architecture is a perfect fit for this environment with the data center. It provides all the objectives that the enterprise customers need, but the challenge here is in making these customers adopt VXLAN, EVPN in a true sense of the way, because they take the leaf spine, but then they still want to maintain their old business practices. So when we sit down with these customers, a lot of times the asks are, can you still integrate to a specific vendor protocol or do something specific, because this is how we've always done it, right? If urging these customers to try trial green pod of Sonic and letting them work with it and look at the capability of Sonic makes them rethink their logical design as well, not just the physical design. And at that point, they are willing to really adopt VXLAN, the technology in the true sense. And that's probably the most exciting part of working with customers on deploying these kind of networks, because when they actually play around with a pod, pure Sonic pod, and they look at how Sonic empowers them, then they get creative about how Sonic can be adapted to their environment. And we've seen a varied set of designs, like the presenters before me highlighted. We have seen situations where customers don't always want to have leaves in pairs, or we might have a remote leaf. There have been like so many varied designs, but I just wanted to highlight two of them today. This is a telco data center where for CNFs, they wanted to have one pod for the data plane and a different pod for the control plane. This was a one-off kind of topology that I had not seen any other customer ask, but then this fit the requirement for, for their business needs. So increasing adoption amongst enterprise customers is about, ironing out the details where, if, they want a particular topology, then we try to help them deploy Sonic in that topology in the manner that they want and supplement with tooling in the management side. The other thing that we've seen is, when they go for the 5-stage class, sorry about the typo there, customers have the choice between going for a unified control plane versus an isolated control plane. And depending on the use case for each network, we've seen customers use either of those. So I think with enterprise customers, the primary question to ask when they design a Sonic fabric is, what is the objective of this network? What purpose is it trying to serve? And then getting them to actually rethink the design and coming up with a deployment that can actually stay for longer and actually uses Sonic's capabilities at full strength is probably the very ideal deployment to do, right? Now, the next use case that I would like to talk about is the edge or the campus use case. This is a slightly different proposition than using Sonic in a data center. It's not a very ideal fit if you think of it at first shot, because these edge or campus data centers are layer 2 deployments, and Sonic comes from a layer 3 world where both the NOS and the platform has been tested well for layer 3 features. But with the recent addition of PoE and port security, it makes Sonic more adaptable for the edge or campus use case. When it comes to edge or campus topologies, we've seen customers take the underlay overlay concept and use it in a different sense of the way where the traditional core layer becomes the spine, and then you have an intermediate layer where it could either be a VTEP by itself, or in some cases it's an aggregator and it just aggregates traffic upstream, and then you have a lower layer which is the access layer, which is the VTEP, depending on if the middle layer was doing the aggregation. And we've not seen a lot of campus deployments yet, and I think one way to we are going to see or add more features as we see more customer use cases. And one way to increase adoption for campus Sonic is to add more campus related features in the open source in Sonic, and also add it across various platforms and distributions, so that it can more customers can be confident that they can pick it up and put it into their environment. Because when customers take Sonic in campus environments, the primary focus is how will it integrate into the rest of the components in my network. And then the next question that they would like answered is, what sort of campus features does Sonic support? The other point is about how resource hungry Sonic is. So if we can get a scaled down distribution of Sonic that can be deployed on low cost hardware and also have size support for low cost ASICs, then it would take Sonic to smaller customers as well. And these are all probably, hopefully, some things that we would see in the future. I mean, I know that we had a presentation on use of Sonic in stacking, but I personally like the scale out that the leaf spine provides when you expand a network, right? To me, when you say it's a chassis, then you go back to the problem that leaf spine solved, and you're going back to scaling up. So, but I guess it depends on each use case to each use case. But for our case, we usually propose MC lag or EVPN multi-homing for the customers as an alternative to stacking. And hopefully, with addition of more campus related features and more choices with vendor platforms for Sonic and campus, we will see more use cases before the next presentation, right? The final topic that I would like to touch upon is the customers in the build versus buy spectrum. So, Sonic has been revolutionary in the sense it has empowered the customer to own every part of the network, starting from concept to execution. They can now choose from vendor to NOS to what goes inside the NOS, what containers do I put in. And having this power means then, if we provide the choices for each step, then it is truly embracing Sonic. So when we look at build versus buy for Sonic as like a spectrum, you have customers like Target who have built their own distribution of Sonic. They have the enough resources to keep their own distribution, maintain it, and sync it up with the community version. And they like the flexibility that their distribution, their personalized distribution gives them, and it meets their needs. It's very customized for their requirements. And on the other end, you have customers who are not essentially software oriented, and they would just like a networking product that they can plug in and gets their network up and going. And these customers typically end up going with the enterprise distribution of Sonic. And while we support both multi-vendor, as in like different vendor NOSes, and we also support multiple distributions of Sonic. We support Broadcom, Dell, and EdgeCore, and the community edition of Sonic. But when customers choose to do the buy option, they kind of lock in with one particular vendor. So that's, if that's the right choice for them, it's fine. But then there are customers who fall within the middle of the build versus buy spectrum, right? These customers don't have the manpower to build their own distribution of Sonic, but then they also don't want to buy a full enterprise edition yet. So for these customers, starting off with base Sonic and then only customizing the feature or features that they need can help adopt Sonic faster. The lack, though, is of options here, right? There's not enough options for the customers who fall in between the build versus buy spectrum. And this is where I think we as a community can provide more options to customers who are on the edge about adopting Sonic because they don't want to buy an enterprise edition, they don't want to build an in-house edition, but they still need some customization. Then assessing where those needs are, which features need that kind of customization, and providing choices using tooling and automation might also help increase the Sonic base amongst various, both enterprise as well as campus customers. So that said, thank you for the opportunity. And if you have any questions, I can take them. Okay. Thank you.
Thanks a lot, Dorado Software Company. So what we will do is we are almost on time. We would like to call Vijay, and we will distribute plaques to the speakers who gave time as well as a lot of efforts to present today beautiful topics, great interaction with the community. And after that, we will take a group photo, and then we will close the workshop. Vijay, can you please come on the stage? So first, I would like to call speakers from Dell, Saurabh and Sandeep, to please come and collect the plate.
So very happy to be here. Ashi and team, fantastic job. I was telling him earlier today that he's got himself into bigger trouble. We might actually ask Linux Foundation that every time we want to be here at Microsoft. So thank you.
You're a good-looking one, Saurabh.
Yes, sir.
For you. Sandeep, thank you for being here and doing the show.
Thank you.
Thanks a lot, Dell team. The Second speaker I would like to call from Cisco. I know Sashi already left, but I would like to call Pratik and to collect play for Sashi and Sameer.
Climb up. Thank you so much. So she's not here. She had to leave for a demo. Yeah,
yeah, I think it was a great session, and especially meeting everyone in the community. I was just, I think, big thanks to Microsoft team, especially I think Ashay and team and Vijay for hosting all of us, and hopefully next year will be bigger and even better. All right, thank you.
Okay, the next speaker I would like to call from Mavenir Virtual Cell, Anish and Uma.
Hi, Anish.
Anish. Thank you.
Thank you for being here.
No, it was wonderful interacting with everyone.
How about try this?
So the event was wonderful. So we had a great time interacting with many of them. So thanks to Microsoft for organizing. Thanks to Ashai. Thanks.
Thank you for being here. All right. Collect a lot of microphones.
I'll take one. Now we'd like to call from Palsi Network. Krishnamurthy and Kingston is not here, but we'll give a plaque for him. Okay, Kingston is not here, so we'll.
Have you? Thank you.
Yeah. So yeah, big thanks to Ashay and team. I know it was how tough it was and how they have nailed it. So congratulations and looking forward to it. Yeah.
Thank you. Thank you for coming.
Can you allow me to speak?
Yes, of course.
Yeah, thanks Microsoft for hosting this event. It was really a good conversation with all partners and the competitors. I think we are missing customers. Probably next time, whenever this event happens, we will have customers. And when I talk about Sonic beyond the data center, we will have more use cases and the deployments. Okay. Yeah. Thank you.
Thank you. Next, I would like to call from Marvel, Ravindranath and Rajkumar. Yeah.
Yeah, thank you.
Say something.
Yeah, sure, definitely. Thanks a lot, Microsoft, for having this opportunity. And thanks a lot, Ashai, DDP, and all the teams. We liked especially setting up every weekly calls to answer questions and stuff, right? It was new to me. So hope to see you all next week, next year. Thanks.
Thanks a lot for coming and presenting.
It was a nice event to come in and participate. This is my first kind of a conference I'm attending, and it was well organized. Thank you.
First of many, right? That's good.
Thank you. I would like to call Arista team, Karthik. And there is
my counterpart.
You flew in. Yeah. This one's for you, Karthik.
Thank you.
Would you like to speak few words?
Sure, yeah. So I was really exciting to be part of this inaugural workshop in India. And on behalf of the Arista team, I'd like to thank Akshay and Microsoft for hosting us, and looking forward to bigger and better in the coming years. And we will obviously play our part.
Don't stay far. Thank you.
I would like to call Avis team, Sudarshan and Kuldeep. Great presentation and great video in the last. That was amazing.
Sudarshan. Say something to the community.
Thank you very much, Microsoft, and of course, Akshay, for continuously holding that weekly conferences while we are getting launched to this events. Please bring it on more. We will come back with more presentations. That I promise. Thank you very much.
Hi everyone. And first of all, I think we should thank Akshay and team and Microsoft for hosting us. But I would like to thank all of you to have patience, listen to us till the end. That requires a good amount of energy. And yeah, feel free to reach out to us and feel free to explore our demo pieces if you want. You can talk to our marketing team about that. Thank you.
Thank you. Photograph.
Thanks.
Thank you.
Thanks, Avis team.
Okay, see you.
And with that, I would like to call our last presenters, Vijay and Tim from Dorado Software.
It's great to be part of this India conference. We actually came all the way from California to meet you all, and we hope to meet you next year with customers, right? I'm really excited to see how Sonic is going to be used in India in various use cases. I'm sure it's going to be different from anywhere else, and hope to be here next year too. Thank you.
Thanks a lot. Thank you. So with
Oh, here.
With that, Vijay would like to speak a few words.
Well, not much. Thank you for being here, folks. Really energized by the participation, the various demos. I know I wasn't there most of the time. I just went back for some work. But, the energy is great. Let's hope this is the first of many. It really inspires us as well. Akshay, on behalf of everyone else, and my own behalf also, thank you for doing all the hard work here. And thank you all for coming over. We promise that let's do more of this so we can get together and exchange ideas and show each other stuff that we have done. So thank you.
Thanks a lot, Vijay. So with that, we will be closing today's workshop. I would like to say a few words before we close. Microsoft is, as we all know, is one of the initial contributor, inventor, when it started coming from the MSR group and with OCI, and together they started building Sonic couple of years back. Lot of cool things are happening. Today also, I learned a lot of good things. Uh, the focus from the cloud enterprise side, we may always see there is a scope in the cloud architecture. We, being one of the biggest cloud provider, at least we can say with the confidence, we are running around like 500K plus network switches, and on that, more than 60% switches are running on Sonic. So that gives the confidence to the community. And when I see the presentation today, the development which is happening in the telecom side or in the enterprise network or the mobile network, that gives a lot of opportunity. Especially, I loved about the network broker and the telemetry optimization side. We were talking about the ML prediction, how can we do. So the good part is everything is open source. Whatever you guys are developing, we can use directly. Whatever we are developing, you guys can use. That's the beauty of the open source. With that, I would like to thank everybody for participating and coming today, because getting this kind of community is very, very difficult. Believe me. So I hope the momentum will be on. This is a first, I will say, the first of own kind of India Sonic workshop. The lot of development is actually happening of Sonic in India, in Bangalore, in Hyderabad, in Chennai. So when we were discussing in the Sonic outreach community, this was just an idea which we pitched like 4 or 5 months back, and it got a lot of good support because there was a momentum and sentiment they wanted to do and have this happen in India, and we did it. So this will not be only one and last. This is just a start, and we will try our best that it is a yearly conference which happens. Location may change, or maybe location will not change. It's a beautiful Microsoft campus, am I right? The weather is also amazing. Food is awesome. So next year also, again, we will try to do the same conference in September in Microsoft campus with more beautiful agenda, more customer panel discussion. There was a question like why customers are not here. We did plan for customer panel discussion today. Because of the time and other limitation, we could not do, but definitely we'll make sure that next time that is on our priority. Customers comes and talk about their experiences. How are they feeling? What are the feedback to the community? And how can we take that feedback and improve on that? With that, I would like to call all the team members who did this, to be honest, because I am the only front. These are the members who made this happen. So I will call all everybody, please, in my team, come here on the stage. Let's take a photo at least. Come. Who made this possible? Gautam, Naveen, Ravi, Pooja, Kavya, Didipya, and Nirmit. They all are from my team, and without them, it was not even possible, believe me. So thanks a lot, all of you guys. Let's have a please come. to everyone. With this, we definitely want one group photo. And for that, Gautam will help us how to take a group photo. Gautam is, by the way, in my team and he's a wildlife photographer. So all the AV kind of, all the AV set. No, no, don't do just under the technology. You see, platform can be different, software is same. So, so I have given all the photography and AV setup to Gautam. So Gautam, you tell us, what should we do?